Hello, Madip, how are you? I'm testing my microphone to be sure it's working. Hello, Madip. Hello, Vishwa. Is my sound system clear?
Hi.
Okay, fine.
Hello, Nilufar.
Hello.
Yes, Nilufar, do you want to test your audio and video?
I don't access to video because sent some messages to me. It is disabled by host.
Oh, you're the host now. I mean, you're the one of the attendees. Sorry, panelist.
Yes,
So,
I am. But
Yes,
now I cannot start video because you can't start your video because that host had disabled it.
Vishwa, host disabled or not? Even mine. Okay, we're trying to check that.
Thank you.
I also need to test my video too.
Yes, yes. Nilufar and Anthony, could you try again?
Okay.
I think the setting has been changed.
Oh, yes.
Yes. Anthony, yeah. Yes, perfect. Perfect. Okay.
Thank you, Krishna.
Anthony, you can change, put the background, and I think Nilufar, we can start. Sure, Nilufar, you can start.
I can hardly find the background now. I don't know what's the problem.
Good morning, good afternoon, good evening to one and all. Welcome to the second day of the International Symposium on Multi-Hazard Early Warning and Community Resilience, MWCR 2022, organized by Amrita UNESCO Chair on Experiential Learning for Sustainable Innovation and Development and the Amrita School for Sustainable Development and Amrita Center for Wireless Network and Applications. I'm Nilufar Abed.
I'm Tony Chaffee.
We are PhD scholars at the Amrita School for Sustainable Development, and it is our pleasure to welcome you and all to host for the event. We will now have the first plenary session of the day titled Integrating Technological Solution with Community-Based Initiatives for Disaster Resilience. This session will be chaired by Dr. Danya, Assistant Professor, Amrita Center for Wireless Networks and Application. Over to you, Madam.
Hello, everyone. Welcome to today's first session. This is the very important topic on how integrating technological solutions with community-based initiatives for disaster risk resilience. So yes. The sessions yesterday, we saw the topics on global and national perspectives and solutions for multi-hazard early warning, and also on how to implement along with the lessons learned in multi-hazard early warning for disaster resilience. So today we continue with the next aspect, how to integrate the developments in technology with society-centric or community-centric initiatives for disaster resilience. We have our eminent speakers today. We have 5 keynote addresses in this plenary session, which will be followed by a question-answer session. So after each presentation, the attendees, if they have any questions, please post in the Q&A box. So our first speaker today is Dr. Darren Chian, who is an eminent scientist who is the director at Center for Soft Ground Engineering at the National University of Singapore. He will be presenting today on estimating earthquake damage and its role in disaster preparedness. Without much ado, let me welcome Dr. Chian to this session. Over to you, sir.
Yeah, thank you very much, Chairman. Let me share my screen. Okay, yeah, can you see my screen?
Yes, we can.
Okay, great. Okay, so I'll get started. Hello, hi, good afternoon. I'm Dr. Darren Chian from the National University of Singapore. I'm deeply honored to be speaking to you in this very meaningful conference. My topic today is on estimating earthquake damage and its role in disaster preparedness. Okay, so with increasing world populations living in urban cities, an earthquake is likely to cause higher damage and casualties due to its concentration of people and buildings. And as such, there has been growing attention to disaster reductions and resilience against natural catastrophes such as earthquakes. However, many would feel that this is something out of their hands and is the government's responsibility to ensure safety and offer support to affected communities. For academics, perhaps preoccupied with new sustainable technologies and sophisticated building designs that can generate immediate impact in research and publications. For financial institutions, they often adopt a probabilistic perspective. If the insurance payout is less than the total premiums that they have collected, they make money and they are happy. Building owners have very little knowledge on building resilience and vulnerability, and their interest is in saving costs and look at the short-term perspective. Who knows? They might have sold their property before the next earthquake hits. And for the authorities, their priorities are seeking solutions to mitigate these risks, and their interest is about infrastructure redundancy. And should one airport gets damaged, for example, then there is another airport to function so that the country is still able to receive aids as well as being able to recover from an earthquake event. So the fact is, everyone in fact plays a collective role in ensuring the next major earthquake is not going to cause too much of damage. And I'm going to tell you why. I hope by the end of my talk, you'll be able to see that education and instilling greater awareness of the importance of collective disaster management is necessary. Second is the vital roles of academics, industry, and authorities in enhancing urban resilience. And finally, how can we anticipate the likely damage to infrastructure so that we know which buildings to pay more attention to? In my view, being able to advance the science of anticipating the extent of damage would be the starting point. So in order to estimate the extent of damage to buildings, we can rely on some basic engineering fundamentals and principles. By just looking at these three buildings, which do you think would suffer the most damage? The short building, the medium, or the tall building? And I'm going to run a video on this. Okay, so right now, the table is shaking. And let me try to fast forward due to time. Okay, so as the table starts to shake more and more quicker, okay, oops, sorry about that. Okay, you will see that the tall building is shaking while the medium and short building remains intact. And this is the case as the shaking gets more and more rapid. However, as the rate of shaking continues to increase, you will realize that the tall building stops shaking, and rather the medium building starts to take place in the shaking phenomenon, as you can see right now in this video. However, as we continue to increase, you realize that now tall and the medium building doesn't shake. Instead, it is the short building which is shaking all the time. So this rate of shaking is what we call as frequency. And when the building oscillates the most violently, that is a time where we expect the most damage to be inflicted on the building. And this violent shaking of the building is at that juncture whereby the frequency of the ground shaking coincides with the natural frequency of the building. And this is known as resonance. As a rule of thumb, a 2-story building has a natural frequency of 5 Hz, meaning there are 5 cycles of shaking per second. For a 10-story building, the natural frequency is about 1 Hz, while a 30-story building is likely to be affected by a much lower frequency as low as 0.3 Hz, meaning every 1 cycle takes about 3 seconds, just like how you pet a baby to sleep. And the ground shaking is affected by the type of geological conditions below the building, okay, underneath the below the building. And if the ground is soft, the soil would filter the high frequency shaking from the source of the earthquake and instead amplify the low frequency waves, as what they can see on the left hand side of the animations. In the case of a stiff ground, as you can see on the right hand side, the soil would attenuate the low frequency, leaving only the high frequency shaking, as you can see. The geological frequency of the ground can be represented equivalent linear soil model or a more sophisticated nonlinear soil model. The attention is placed on the shear wave, which tends to cause buildings to sway from side to side. And this, for the structural frequency, it is dependent on the height and the material of the building. We often focus on the first mode of vibrations, which has the largest amplitude. The period, which is the reciprocal of the frequency, can be estimated by multiplying the square of the height of the building by a coefficient C, okay, depending on the material of the building. As mentioned earlier, the greatest damage is when the ground shaking frequency and the natural frequency of the building coincides, i.e., where your normalized frequency is at 1.0, okay, where we can see a sharp peak in the graph above here, and as the two frequencies start to depart, starts to be different, the amplification of the shaking will naturally be reduced, just as what they can see from this graph. So now we know that frequency plays a big part in the response of the building. So how are we going to translate this into damage? How are we going to quantify this damage? We understand that earthquake has a complex frequency content and durations. We also know that the presence of soft ground would amplify the shaking. What we have done is to translate the earthquake time history, as you can see on the left hand side, into a wavelet plot on the right, where the time and frequency of shaking can be observed in a 3-dimension. Taking into account of the wavelets, as you can see on the top left hand side, and the resonance effect graph that we have discussed just now, we can actually compile them together. We can actually superimpose them. We write a code that allows us to calculate what is the expected damage. That will be in the form of a dimensionless factor. And in order to validate this point, a few case studies are provided here. The first is on the 2011 Tohoku earthquake in Japan. As you can see from the earthquake, that it has caused a huge ground motions of duration more than 2 minutes, with peak ground accelerations up to 2G and more than 1G in many locations along the eastern coast of Japan. And this slide on the right hand side shows you the frequency content of the earthquake at various locations. And by comparing this with the mid-Niigata and Kobe earthquake, you can see that the 2011 Tohoku earthquake does not have significant long period content, and the dominant shaking is typically about 0.1 to 0.3 seconds, or equivalent to a 3 to 10 hertz of shaking. And this explains why structural damage caused by the much larger moment magnitude of 9.0 Tohoku earthquake is not causing as much as extensive damage as what that we have observed in the Kobe and in the mid-Niigata earthquake, simply because buildings of 2 to 10 stories buildings typically have natural frequency falling within the 1 to 5 hertz range rather than the Tohoku's 3 to 10 hertz. And taking two of the Japan's KNET seismic measuring stations at Sendai and in Tokyo, as shown in the map denoted in blue, we evaluate the buildings near to these two stations, and they are identified as T1, T2, T3 in Sendai and T4 in Tokyo. The characteristics of the ground motions are found in the table with maximum peak ground acceleration as high as 1G. And this slide shows the observed degree of damage to two buildings in Sendai. The Tohoku University buildings and the Takasako apartment buildings were categorized as heavy and moderate damage according to the International EMS 98 scale. Another two buildings, one in Sendai on the left-hand side and the other in Tokyo on the right-hand side in this slide, both are high-rise buildings. However, they appeared to have minimal damage. Based on the damage prediction of these four buildings that we have just went through, it did appear that the wavelet damage factor value calculated matches with the observed damage classification. Okay, just as you can see here. The heavy are having a much higher damage factor as compared to the moderate and non-damage, whereby we have a much far lower value here. Okay, so it seems to be able to match the factor values and the observed damage classification. The second case is an earthquake in Indonesia, as presented here. The Bengkulu earthquake is unique because there were two aftershocks within a short time interval after the main moment magnitude 8.4 earthquake. Hence, we are expecting a superpositioned resonance effect over here. We can see buildings with complete, with moderate, as well as lightly damaged buildings following the earthquake. And based on our damage prediction, over here they can see main shock, the first aftershock and the second aftershock. Again, by looking at the total value, the cumulative value of the damage factors, again, larger damage factor tends to coincide quite well with the damage that was observed in the field. One thing that you like to take note is that despite a weaker 7.9 moment magnitude aftershock for the aftershock 1, as compared to the main shock of 8.4 main event shaking, the damage predicted for this aftershock, the first aftershock, was generating a much higher damage factor, and this was in line with reports from the local community affected by the earthquakes, indicating that the first aftershock was the one that causes most of the buildings to suffer the more extensive damage as compared to the main shock. The third case is the 7.6 moment magnitude Chichi earthquake in Taiwan. Taking again four buildings as examples around nearby seismic measuring stations as shown in the map. Okay, so the blue ones are the measuring stations, while the red color CC1 all the way to CC4 are the buildings which we have observed. And we have seen complete, heavy, moderate as well as light damaged. And we again observe that from our damage factors values, again that we saw that that larger damaged buildings in the field seems to be in line with the higher damage factors that we have computed. So coming back to the contributions from academics like myself, we can support disaster preparedness by identifying infrastructures of high vulnerability to earthquake damage and translating them to practice. Certainly, I'm very sure that researchers in this conference could do the damage predictions much better than me by introducing further refinements, further improvements, to such a methodology. And from the financial institutions, such as insurance firms and building owners, they can also play a part. For example, the insurance industry could attempt to price insurance premiums more accurately and according to the structural typology and ground conditions where the buildings to be insured sits. More accurate pricing of premiums also mean that there will be avoidance of excessive claims and insolvencies resulted if there is a major earthquake. So for building owners, with the higher premiums that you can see for vulnerable buildings, they will be incentivized to retrofit their buildings such that they would enjoy a lower premium and perhaps a higher value of their own property if they were to sell their properties later on. And in this case, then buildings around us will get improved, will be safer, and that is going to improve the resilience and the extent of damage that an earthquake can cause. From the authorities and urban planners' perspective, with greater understanding of earthquake vulnerabilities of certain building types and ground conditions, urban planners can allocate less safe ground conditions like the one in red here for parks, while the safer ground conditions are more suitable for high-rise buildings due to the fact that the ground is unlikely to cause low frequency shaking that could cause large damage to high-rise buildings for the higher population density living, as shown here in the green color, as well as for critical infrastructures to be built at. In this way, infrastructure damage and human casualties will be kept to a minimum if we have been able to do a more wise urban planning from the resilience perspective. So I hope that you can now see that everyone plays a part in ensuring that we and our future generations have a more resilient urban environment to live in. And this is the end of my presentations. Thank you very much.
Thank you, Dr. Xian, for that wonderful presentation, comprehensively explaining about the basics of earthquake dynamics, as well as showing us the videos and demonstrating through case studies all the details of earthquake disaster, as well as presenting all perspectives from the community, academia, as well as from the industry also. Thank you very much, sir.
Thank you so much. It's my pleasure.
So with that, let me welcome our second speaker of today's plenary session. We have Dr. Sujit Singh Randhawa, who is the Principal Scientific Officer at the Himachal Pradesh Council for Science, Technology and Environment. He has a distinguished scientific career with research in exploration of natural resources, snow, glaciers, using satellite observations, as well as expertise in mapping and managing natural disasters in Himachal Pradesh. He is presently coordinating the activities of the State Center on Climate Change. Dr. Randhawa, welcome to you, sir, for the symposium. And let me hand over the session to you.
Thank you very much, ma'am. Very good afternoon to all the panelists, distinguished panelists, participants. On behalf of Himachal Pradesh Council for Science, Technology and Environment, it's my privilege to convey my sincere thanks to the organizers to give us an opportunity to share our views and our observations on Himachal Pradesh on this platform. Thank you very much. So I'll in view of the time slotted to me, I'll immediately go to my presentation. Share. Presentation. Is it
Sir, sorry to interrupt you. We can see your screen, but could you please adjust your camera so that your face is fully visible?
my presentation is visible to you?
Yes, yes.
Am I
go ahead.
audible?
Yeah, yes.
Should I start then?
Yes, sir.
Okay. So I'll be talking in another 15-20 minutes on the hazard vulnerability of Himachal Pradesh. As we all know that Himachal Pradesh is a small hilly state in the western Himalayan region of the Indian Himalayan region, and we all know that Himalayas are the youngest mountain chains in the world and are still in the building phase, resulting that the state is highly vulnerable to different kinds of hazards, either whether it is an earthquake, it's a landslide, or it's a floods, or it's avalanches. So I'll be talking briefly on the hazards which are one from which the state is vulnerable to. So this is the satellite picture of Himachal Pradesh. You can see here, these are the two major wetland water bodies. This is a Pong Dam and this is a Govind Sagar Dam. And this is the drainage map of Himachal. These are major rivers. This is a Chenab River and this is the Satluj River which enters Himachal and originate from the Tibet Himalayan region. And this is the Byas River. This is the Raj. So this is the major drainage, well-developed drainage system in Himachal. But these all drainage form part of the Indus River system as well as the Ganges River system. So as far as the hazards identification are the concerns, basically the High Power Committee of India identified 5 types of hazards, and that they are geological, atmospheric, hydrological, fire, accidents. And you can see here in geological we can have earthquakes, avalanches, landslides, and atmospheric we can have cloudbursts, lightning, hailstorms, snowstorms, and hydrological floods, drought, and dam failure, whereas fire, forest fire related, and accidents related hazards. So as far as the Himachal is concerned, Himachal is vulnerable to natural as well as the anthropogenic hazards. In natural hazards, we are vulnerable to earthquakes, landslides, floods, snow avalanches, droughts, and hailstorms. In anthropogenic or man-made hazards, we are vulnerable to accidents, electric fires, forest fires, building collapses, serial bomb blasts, and festival-related disasters. So I'll just quickly go through the geological hazards in Himachal. These are the earthquakes, landslide, avalanches. So this is the geological map of Himachal Pradesh. We have diverse geological geological formation in Himachal, right from Precambrian to recents. So here this portion, because geology mainly controls the hazards like earthquakes, landslides in Himachal. So this portion of the geological formation, which we call it as a Punjab re-entrant part of the Himalaya, is bounded by thrust system. Like we have the Himalayan Perthed thrust, then we have Jwalamukhi thrust, then we have the MBT and the MCT. Besides, so we have all different kinds of rocks. And this is the seismic map of the country. This is whole country, and we are located somewhere here. This is Himachal. So these are the major tectonic lines which defines or which controls the seismicity in Himachal. In Himachal, seismicity is being controlled by these northwest southeast trending thrust or faults. We call them as like here we have a Himalayan frontal thrust as we separate Punjab plains from the Himalayas, upper Shivaliks. Then we have the Jwalamukhi thrust. Then we have this MBT main boundary thrust. Then we have the main central thrust. These all thrust controls the overall seismicity in Himalaya, and resulting to have major concern in this part of this Punjab re-intent part of the Himalayan regions. Besides this, we have numerous transverse and trending lineaments which control the seismicity in the Himalaya. So these are the 10 major thrust: main boundary, Vaikarata, Mustgard, and all these thrusts are represented in a map form. So this is the seismic hazard map of Himachal. This whole is called as a zone 4, and this inner circle is a dark brown, is a zone 5. You can see here these major tectonic lines are part of the zone 5, which is a very highly damaged risk zone in as far as the seismic map of country is concerned. Then we have a next severity is a zone 4, which has a highly damaged and slightly less damage than the zone 5. So we are confining in two zones, zone 5 and zone 4, and this constitutes about 32% of the total geographical area of the state, as constituting as a very high damage risk zone from the earthquake point of view. So this study, we did one study. We tried to correlate the past epicenters in Himachal. We delineated all lineaments, all thrust, all perpendicular to the Himalayan thrust, all lineaments, and plotted all the epicenters on this lineament, epicentral and lineament map of Himachal. This map has been developed from the satellite images, and you can see here the density of the epicenter is very high. Another cluster is over here. So we can infer from these analysis that this part of the Himalaya or Himalaya is highly prone for the microseismicity, resulting to have microseismicity in number of daily in less than 4 and 5 every day. So this, we can say that this in this part of the Himalaya, that is the northwestern part, we can have micro seismicity very high, and also in this part micro seismicity very high. So we can say that in this part we cannot expect a major earthquake. We cannot overrule, but whatever accumulation is taking place in this part of the Himalaya is continuously being released in the form of the micro earthquakes. Same is the situation over here. So we can say that here the chances of getting a major earthquake are comparatively less than this part, because here we have the MCT and MBT over here, and we have a Jwalamukhi thrust, we have the Himalayan frontal thrust. So this whole area is locked. So this we can say this is a seismic gap. Although the prominent structural lineaments, structural features are there, but the microseismicity is not as high as in this case. So we can say that this is a seismic gap, and we can infer that in this part of the Himalaya, this can be the reason of the major earthquakes in the future also, because of the tectonic regime or the gap of microseismicity. Similar situation over here because of the gap and not having microseismicity in the area. So this is overall analysis of how the epicenters, lineaments, thrusts, and are related to each other, based on which we have tried to attempt deduce some micro or some zoning of area, which are the areas which are highly vulnerable or which are less vulnerable, using these epicenter lineaments vis-a-vis the geological lithology of the area. So we also try to correlate it with the radon estimation in that this part of the Himalaya, and we measure radon in water and soil in this. So we can see there these graphs here, the radon concentration is very high in water. So we can say that these areas which are close to the lineaments or close to the faults, we can say are still active. So these radon has been used as a measure for the early warning system, or you can say we try to do some research work in this area based on the radon concentration in water. So we try to analyze based on the past epicenters. We can say one gap, one abnormality could be seen in this part, and one abnormality could be seen in this part. So these the whole set of data has correlated with two major earthquakes, that is intensity 4.7 and 4.9 and was correlated with the abnormality in the radon concentration. Although we cannot be sure that not much work we could do in this area based on radon concentration. So this is all about the seismicity. Now we can come to the next geological hazard, that is the landslide hazard. So in Himalaya, we have we have divided Himalaya in Himachal, higher Himalaya, lesser Himalaya, and the outer Himalaya. We are, as far as the landslides are concerned, we are much concerned in these two parts, lesser Himalaya and the outer Himalaya. Since this higher Himalaya is mainly the snow-bound region, where we don't have much developmental activities, we don't have inhabited areas, so we are not much concerned about the landslide activity in this area. Since most of the developmental activities and all the inhabited areas are bound to in these two lesser and outer Himalaya, so landslide is mainly concerned within these two zones. So you can see here this zone and these zones are mainly concerned for the landslides, whereas this zone where this is mostly the snow-bound region, we are not much bothered about the landslides in this region. So this is the whole district-wise scenario of land, how much area in which district is prone for the landslide, like severe to very high, high, moderate to low. This is as per the BMTPC Atlas of Government of India, which describes the district-wise area towards the vulnerability to landslides. So these are some of the important landslides in Himachal, like Maling landslide, Kinnaur landslide, Jhakri landslide, Lugarbhatti landslides. Prominent slides in Byas Valley like Madi, Bhang, Jayal, Mandu, Kotrupi landslides. Then these are 2019 landslides, and as per the published literature we could gather. So this is the landslide inventory map of Himachal Pradesh, which have been derived from the satellite images of list 4 having spatial resolution of 5.8 meter. So we have, this is a whole Himachal in which we have deduced some of the prominent landslides. Most of the landslides are in this Mandi, Kullu, Kinnaur, Shimla and Sirmaur district, whereas in Solan we are also some of the landslides. Likewise in Lahaul and Smiti we have landslides which are prominent. So these are the snapshots of the landslide from the list 4 satellite data. So how does it, I'll not go much in detail to this. So as we all know, there are natural causes of landslides and there are anthropogenic causes of landslides. So major landslides in Himachal like creep, these loose debris where we find these type of features and the landmass, we can say this is a creep and this can lead to a landslide in future also. So another is a debris or mud debris landslide, like here. This is a satellite image. This whole mud, this channel was filled up with a, here you can see there was no debris in this channel, but after the post satellite image shows that this channel was filled up with the debris, which causing blockade of the channel because of the mud debris slides. Then we have a rock falls, Vinga hilly state, higher Himalaya, rock vertical cliffs are there. So these types of lands are very common in Himachal. So then there are in sedimentary Shival terrains like sandstone, clay, shales, we are getting planar failures and we are also getting debris landslide in some parts of the state. Then in Shimla, it's also since Shimla is a top of the Shimla is a ridge, is a popular tourist place, is also sinking to one side because of the landslide. So this is the picture of landslide which is sinking towards one side because the whole debris is there, water tank is there, seepage is there. Because of that, this whole loose unconsolidated material is causing linkage, sinkage of the ridge. This is the ridge area. Then down, this whole unconsolidated material have been deposited on the hill slope, which is sinking causing to landslide in the downslope areas. Like here, this rock fall took place in 2014. This causes a damming of a river, choking of the river formation in the lake in this stream. So which causes huge loss to the government property. Likewise here, about in 2014 or 15, this area was very stable, but since this is confined by major tectonic lines. On the southern side is a Jwalabaki thrust. On the northern side is MBT. So it is landlocked between two sides. And this is all of a sudden this landslide took place. When we visited, we could find that this landslide must have been activated because of some tectonic activity in some adjoining areas. So you can, these trenches which have been which could be seen in the area after the landslide signifies that this landslide must have been caused because of some of the tectonic disturbances. So landslides are not only caused because of the developmental activities, but because of the tectonic movements within the earth crust. So another prominent landslide which occurred in 2017 in Himachal was the Mandi Kotrupi landslides, in where around 50 people lost their lives because in the evening time, some 3-4 buses were taking their dinner, and all of a sudden this landslide took place and buried of the 3-4 buses. This is you can see the picture of the landslide here. This is all the Savathu Dakshites from sandstone clays of the Savathu Daksite formations. You can see here, this is the whole panoramic view of this landslide started from this is the crown of the landslide, and these buses are somewhere here, and this landslide took them away, and the casualties happened in this area. So this analysis was done for the tectonic to correlate with the tectonic features in the area. So this is the MBT, and this Ropar Mandi fault was very close to the landslide. So it was observed that this must have been related with the tectonic movements because of the major tectonic lines surrounding the landslide. So
Sir, sorry to interrupt, but could you finish a little?
yeah, okay, just continue. So this analysis was done for the landslide in the past, how it happened. So this is the signatures was started for this landslide 2001 and then 2018. So these are the few photographs of the landslide in Himachal. This is another landslide in Kinnaur, another landslide in Kinnaur. So when the developmental activities are taking place, the blasting, these landslides are activated. Some blasting edit was here, some hydro projects was here. This caused the development of a landslide in this area. So when we develop the road cutting, the landslides are happening over there. So this is another landslide which caused 65 people in 1995. This unconsolidated material, all of a sudden, this is unconsolidated material, structurally weak. So this mass came down, causing burial of 65 people. Then we have avalanches. These are the avalanches in Himachal. The most of the prominent avalanches are Lahaul Spiti districts, and 397 persons and 298 lost their lives way back in 1991. Then we have climate-related hazards. We have river Satluj, Byas, Ravi, Yamuna, where floods are happening everywhere. These are some of the field photographs after the post-flood damage. You can see here. So you can also see here after flood. So now, because of the climate change, landslides are happening in the higher Himalayas. So this is another landslide-induced lake which causes damage in Himachal. This is in Tibet in the Chinese part. And this lake, this is geomorphic depression. This lake was formed here because of the landslide. You can see here, this water came down. This in 2004 again. This and this is in 2004. Ultimately, 2026 July, this lake was formed because of a landslide choking the river course. So since then, we are monitoring this lake and updating the government of Himachal Pradesh about the vulnerability of the lake here. These are landslides. This is the landslide. So if anything happens again, so this can cause again the formation of a new lake here. So as the glaciers are going back, lakes are coming. So this is one of the Moran Dam Glacier Lake in front of one of the glacier. This is a glacier. This is a lake. You can see the field photograph of the lake. This is the closer view of this lake. So these are the lakes from the climate point of view. We are mapping all the lakes which are coming in the higher Himalayan region of the glaciated region. So you can see and 17, 18, 19, this whole Satluj basin, we are mapping right from China to downstream. This is Chenab basin. We are mapping and taking all the Gulf glacial lake outflows in Himachal that can be potentially vulnerable from the hazard point of view. This is the Byas Basin. These are the lakes. And this is the Ravi Basin. These are the lakes in the high riparian regions. So these are the examples of how these lakes are coming. This you can see here. These are the lakes. These are the lakes. These are the lakes which are coming in front of the glaciers. These are the lakes. So besides this, some lakes are also coming within the glacier body, like here. These are the lakes because of the less snowfall in the winter, they are coming over here. You can see here. So these are the recent floods that happened in 2021 in Himachal. You can see here damage occurred because of the floods activity during the monsoon season. Change of river course over here. Again, change of river course. This was the main course and this was the change of the river course. You can see here another landslide took place over here. This is from here this landslide started, debris came, formed as temporary blockade, and then again this landslide causing deaths about 14 people in this small village. You can see the field photograph of the land damage caused by a flash flood after the landslide. So another landslide occurred and such a temporary lake was formed along this river in 2021. So hazard risk vulnerability assessment, we are mapping hazard identification, mapping, risk mapping, multi-hazard mapping, then vulnerability assessment based on people, infrastructure, environment, economic activities. And based on these, we have developed a matrix: earthquake, landslide, floods, avalanches, industrial, overall vulnerability of Himachal Pradesh in district-wise towards these hazards. So these are the maps in GIS platform. You can see here, this is the earthquake, this is the landslide map, this is the flood vulnerability of Himachal, this is the avalanche vulnerability of Himachal, this is the industrial vulnerability of Himachal, and this is the overall vulnerability map of Himachal. This is the very high vulnerable area of Himachal. These are the high vulnerable area of Himachal, and these are the moderate vulnerable area of Himachal as for the all multi-hazards maps are concerned. That's all. Thank you from my side.
Thank you very much, sir, for your detailed overview of the various hazards experienced by Himachal Pradesh, highlighting the monitoring and mapping of landslides, flash floods, as well as various multi-hazards also. I'm sure that your presentation was very exciting for the researchers at Amrita University who are working in these areas in managing and mitigating these disasters. Thank you very much, sir.
Any questions?
Sir, we have kept the questions at the end of all the sessions. So if you could stay back.
Because I have to go for another meeting.
Oh, okay. So we have one quick question for you. Do the locals get to see these photographs or images of the new lakes that you showed?
Pardon?
The new lakes that you showed during your presentations, do the locals get to see these photographs or images?
We are sharing this information with the district administration because they are the main stakeholders, and the lakes which are vulnerable, we give them detailed information that these lakes are coming and you have to take some precautionary measures. So every month we are sharing information with the district administration as well as the state disaster management authority.
Thank you very much, sir. We would like to be in touch with you. Dr. Manisha, ma'am, you want to ask something?
Sir, thank you so much for joining, sir. It was a very eye-opening presentation for us. We would like to have a closer interaction with you because I have also several PhD students working on multi-hazards area. Yeah. So your immense, knowledge will help us to actually detail for Himachal the different perspectives of what are the multi-hazard and their probabilities and interrelationships. We will write you and we'll take forward.
You are welcome anytime you can interact with us.
Yes, thank you so much.
Thank you so much.
Thank you so much, sir. So let me welcome Dr. David Lalmond, Assistant Professor, Earth Observatory of Singapore, Nanyang Technological University. He has an academic background in earthquake sciences and engineering, predictive modeling, geostatistics, reliability analysis, etc. which promotes resilient societies. He's an active researcher, an award-winning active researcher who has groundwork in post-disaster assessment and community resilience in communities such as Haiti, Nepal, etc. Welcome to you, Dr. David. Please let me hand over the session to you.
Great. Well, thank you very much to Amrita University, Dr. Manisha, and other organizers for inviting me here. I'll start sharing my screen right now. I know we're a bit behind on time, so I'll just jump in my presentation, and so I'll be sharing with you some information around the topic of building a more resilient future in the face of uncertain extremes. Thank you again for the introduction, and I'll do a bit more of an introduction in the next few slides as well to kind of highlight some of the different paths to kind of careers in research and practice of disaster risk management, which are things that I've been involved with. Almost all my slides are hand-drawn, but I am colorblind. So if the colors don't seem to match what you expect, forgive me for that. So I grew up in a small city in northern Thailand, actually, in Chiang Mai, a beautiful city if you ever have the chance to get there. And this is what my house looked like. This is my mother and sister in 2005. So while our house was along the river, as you can see, sometimes our house was in the river. And this certainly kind of played a big role in shaping my interest in these topics. In fact, last week, this is the aerial picture of Chiang Mai, 2 weeks ago, sorry. From the Bangkok Post. And as you can see, these floods are happening quite regularly, and unfortunately, they're becoming more common. And this, of course, is true of cities throughout the region and the world. I did my studies, my undergraduate studies at MIT, first in computer science. And while I was there, my family decided to go on vacation here, which maybe some of you have gone to on the southeastern coast in Tamil Nadu. And we landed in 2004, the day before Christmas. I'm not sure if you remember what happened on Boxing Day of 2004, but it was the day of the 2004 Indian Ocean tsunami. And we landed minutes after the tsunami wave. I remember seeing the flooding from the plane. And we weren't directly impacted, but certainly seeing the impacts of that event on coastal communities in this part of India had a profound impact on me. So when I went back to MIT, I decided to shift my studies from computer science to engineering and building engineering, and really trying to understand how earthquakes and other hazards impact buildings. So they didn't have an earthquake engineering program, but there were some brilliant researchers that were studying old buildings, and old buildings are really interesting because like old people, they have a lot of experience and they've survived a lot of crises. So in fact, there's a lot that you can learn about natural hazards and resistant buildings by studying old buildings. And so I work with some researchers doing some of the first experimental tests of simple arches to earthquakes. I then thought, well, perhaps another way that we can make our buildings stronger and more resistant to earthquakes is through better materials. If we can develop better materials, then our buildings won't be impacted by these events. And so I went to Berkeley for a master's in earthquake engineering. And specifically, I was doing research then on fiber reinforced concrete, which can, as you can see from the right, can bend in earthquakes. And this is a picture of me doing these large scale tests. And when I finished my master's, there was a huge earthquake in Haiti in 2010, one of the deadliest earthquakes in recorded history. And these are images of what downtown Port-au-Prince is the capital of Haiti, what it looked like after, and this is actually 6 months after the event. I was asked by the World Bank if I could support in helping. They had launched a very innovative program using remote sensing and crowd sensing to analyze damage. So they sent images to thousands of people around the world, and people tagged buildings according to damage, but they needed someone on the ground to verify that what they were seeing from space actually was real. And so I did that, but I ended up staying for 2 years working on building damage assessment from the ground, where we assessed 400,000 buildings, and then developing safe reconstruction guidelines that were all kind of cartoon-like, so that people, even if they didn't have an engineering degree or architecture degree, could easily follow and reconstruct safer buildings. What was very clear from that experience, though, is that the understanding how buildings behave from the building scale or even the material scale is completely insufficient to understand how these events impact entire cities. And that's what I really wanted to understand. So I went to Stanford to do a PhD. After that, specifically working with some of the leaders, intellectual leaders who developed a lot of the reliability and large-scale risk analysis methodology to study urban risk. And I founded the Stanford Urban Resilience Initiative, as well as a multidisciplinary center there. I stayed involved in post-disaster response and recovery, specifically following the earthquake in Nepal. I've now been in Singapore, so I'm back in this region, which is very impacted by various natural hazards. And I lead the disaster analytics side for society. And as you can see, we now not only focus on cities, but really on people, and trying to understand how these hazards impact different people. And we do a lot of pretty advanced analytics, but in fact, a lot of what we really focus on is on issues of equity in disaster risk. So I wanted to share with you kind of two challenges that I really see in the next few decades for better managing disaster risk. One is related to managing growing risk, specifically growing urban risk. The other is about managing extreme events. And so, in the risk analysis framework, and perhaps you are already familiar with this, but we define risk as really the intersection of hazard, exposure, and vulnerability, where hazards describe the floods and the earthquakes and the typhoons and the droughts. These are kind of the natural drivers of risk. Exposure describes the people and buildings that are impacted. Sorry, actually, let me just go back. Clearly with climate change, the hazards are growing, and we know this. Sea level rise will mean more flooding of coastal communities. We can expect more significant and frequent typhoons. And when people think about growing risk, usually they only think about climate change as the main driver for changing risk. And in fact, there's a lot of other things going on. Specifically, exposure is also growing. So, global population is increasing, but it's through urbanization, particularly cities, that are growing. And a lot of these cities are coastal, so they're much more exposed to coastal hazards such as flooding and typhoons. But then even if you look within cities, as you get constrained in space, it puts added pressure for people to occupy more and more hazardous land. So people will start building on steep slopes or building on floodplains or even above water as they run out of space. And unfortunately, the first people to do that are typically low-income communities who are more vulnerable anyway to these events. And finally, vulnerability. And I think we think that we're getting smarter in the way that we build our buildings and the way that we organize our urban systems. And in fact, we have very little evidence of that. And one of the things I'm very concerned about is that as cities get increasingly complex, as our systems become increasingly complex and interconnected, it's creating new vulnerabilities that we really haven't identified or thought through. So that's definitely a concern. And in fact, as cities themselves become connected between each other, that creates new vulnerabilities. So today, a major flood in Bangkok will have impacts in Delhi and Singapore and around the world, as we saw in 2011. These are really complex processes that we don't properly understand. I wanted to come back to this idea of urbanization just to highlight just the scale at which this is happening. So I developed this graphic to highlight that today in 2020, there are more people living in cities than there were total people on the planet in 1980. And 1980 is really not very long ago. And obviously this process is ongoing, and more people are still moving to cities and so forth, which isn't necessarily a bad thing, but it does have big consequences when it comes to risk. Ultimately, a lot of my work is focusing on helping cities and communities understand their long-term risk and their risk trajectory, because that's a scale at which they need to be making decisions. When cities and municipal governments decide on infrastructure projects, building new roads or new transportation systems, those will last for 50 or 100 years or more. So that's really the timescale that they need to make decisions. So we've been developing tools to try to account for changing hazards, changing exposure, and changing vulnerability. And we have some references for that. And ultimately, what we want to do is kind of summarized in this quote by Chinese philosopher Lao Tzu. If you don't change directions, you may end up where you're heading. So we now have the tools that help cities and communities understand where we're heading in terms of risk, which gives us an opportunity to actually change that trajectory today. And it's much more empowering to municipal governments or governments and national governments as well, because addressing existing risk is so difficult when something is already built. Retrofitting buildings is incredibly expensive and complicated. Moving populations is not a good idea anyway, but managing future risk and changing the risk trajectory, that's something that governments are empowered to do much easier and with less resources. So this isn't just abstract. You know, I did the study for Kathmandu in Nepal, and we're doing another more in-depth study for Manila in the Philippines. You know, this shows the rapid growth of Kathmandu city over the past few decades, and you know, we see similar trends in cities throughout South Asia and Asia in general. And one of the concerns I have with changing vulnerability is this kind of ad hoc process of incremental construction, which we see throughout this region and throughout the world. So a household will start with a 1 or 2 story building, and over time we'll add another floor, we'll expand it, and so forth. This is sometimes what it looks like in Kathmandu, you know, and it's one of the most seismically exposed cities in the world. These buildings are not safe for earthquakes. Every time you add a floor and an expansion, that makes it less and less safe. And so we did models to show this, and we can use all this to try to understand the current trajectory of risk for a city like Kathmandu. Importantly, up till today, this is just predicted. It's not predetermined, right? So what would happen if all new construction in Kathmandu was to higher standard? It can have a massive impact on reducing future risk and really changing the trajectory. So I think this is why these tools are powerful. Just coming back to this graphic, because I talked about it as a source of concern, but in fact, it's also a massive opportunity, because in order to meet the demands for housing and infrastructure in the next few decades, we're going to have to build so much infrastructure. And if we do it right, we can really set our cities and communities on a more resilient trajectory. So that was my first point of concern. The other point of concern is related to extreme events. And these can be just extreme in that they're much more significant than what we've seen before. New threats, perhaps climate change is creating new threats that have never happened before, or cascading events. Part of the problem is that most of our understanding of natural hazards and their impacts, and most of our models are focused and are built off of the common event, the frequent events, by definition, because they're frequent. That's what we have more data for. But extreme events are often what controls risk. And these extreme events are the ones that we're most concerned about, because these are the ones for which communities might never recover. And we can think about, you know, I'm sure you can think about some examples of these things. New Orleans, Hurricane Katrina still hasn't recovered, 15, 17 years later. So these are the events that we're really concerned about. And as I said, the big issue with these is that we build our understanding of extreme events and of hazards on limited past data. And if we haven't seen something in the past, we can't think about it in the future. This is where the term black swan comes from. It was coined actually quite a while ago, but the idea is that the Europeans couldn't have imagined black swans because all the swans that they knew were white. And then they went to Australia and realized actually there are a bunch of black swans. So that's a metaphor that's used here. So what we've developed is this stochastic counterfactual analysis methodology, where we're basically saying that one thing that can help us imagine a plausible future and imagining extreme events in the future is to look at the past events that actually have occurred and imagine how small changes in those events could have led to much worse consequences. And specifically, it's a downward counterfactual because we're looking at worse consequences rather than better consequences.
Dr. Lalman, can I request you to wind up in 1 or 2 minutes?
Yes. So we've looked at kind of past volcanic eruptions to show how small changes in wind patterns could have made them much worse. We've looked at past earthquakes, showing how slightly different locations or time of day could have made it much worse. And we've looked at a bunch of these events. We've also developed this idea of the black elephant. So that's these events, these huge events that we actually know are possible. And the scientists have been documenting it, but no one wants to discuss it. And so no one is addressing it. So these are the mixture of black swans and elephant in the room, and we published on this. So right now I've talked about, growing risk and extreme events. I'm actually very optimistic about the future. So I don't want to make all this negative. And actually one of the examples that I use is an event that you might be familiar with, which is Cyclone Fani. The problem though, and I think the problem with disaster risk management in general, is that success in disaster risk management is invisible. So we never hear about successes. So Cyclone Fani, other than perhaps communities in India and the region, most people don't know about it. And the reason they don't know about it, despite the fact that it was the largest cyclone to make landfall in 20 years, is that almost no one died because it was a great success. The government evacuated millions of people, and that was a huge success in terms of disaster risk management. Likewise, we look at Nepal. It was a huge disaster, but they had implemented a school retrofitting program, and none of the schools that were retrofitted had any damage. And these successful lessons should be highlighted and shared and learned so that they can be replicated in other places where they need it. So we used the same methodology, but in order to highlight successes. So we looked at both a reanalysis of the Nepal earthquake if the schools had not been retrofitted, and a reanalysis of the Cyclone Fani if people hadn't been evacuated. And what we see is that in most cases, thousands of lives were saved. So, this was published in the latest UNDRR Global Assessment Report. And importantly, it's led to the Averted Disaster Award, which we launched with the World Bank and GFDRR a few months ago. And the first winners of that award will be announced next month at the Understanding Risk event, which perhaps some of you will be attending. So just in summary, what I wanted to highlight here is really the need to manage growing risk, the need to plan for extreme events and black swans, and the need to recognize and celebrate successes in disaster risk management in order to share, learn, and scale solutions where they are needed. So with that, I will end. Thank you again for inviting me.
Thank you very much, sir, for the wonderful presentation, combining together the ideas of black swans and expanding cities, and ending up with a very positive note also. Thank you very much. We will please be available. We have a question for you, which we will take up at the end of this plenary session.
Perfect.
Thank you very much. Next, we have a very interesting presentation on low-cost sensors for disaster risk reduction by Mr. Chris Quinn, who is a principal and founder of Resilient Projects. He holds a master's degree in disaster preparedness and reconstruction and is a certified practicing project director. He has a keen interest in resilient infrastructure, organizations, and communities with extensive experience in providing successful disaster risk reduction and resilient solution to state government, local government, large utilities, and emergency service organizations. Mr. Chris has also worked in the response, recovery, and reconstruction effort to major natural disasters, such as the North Queensland monsoon and Townsville floods, cyclones Debbie, Marcia, and Yasi, and is an active member of the Queensland State Emergency Service with multiple commendations from the Emergency Services and 2 awards of the National Emergency Medal. Welcome to you, sir. Let me hand over the session to you.
Thank you so much. I'll just share my screen. Now, hopefully you can see the presentation.
Yes, we can. Please go ahead.
Lovely, thank you. I'd just like to take a quick moment to thank all of the presenters that came before. Very interesting presentations and very challenging presentations. Certainly get me thinking about all of the things that they're speaking about. I also wanted to thank Dr. Manisha, Professor Sudha, the advisory committee for inviting me to speak today. And before we go any further, I really must acknowledge the country on which I'm standing today to deliver this presentation to you. It's the country of the Woolgooroo, Kabar and Bindal people in Australia. I live in town called Townsville in North Queensland. And I'd like to acknowledge all of the traditional custodians of the land on which you are today, right around the world, this beautiful world that we inhabit. As you rightly said, we'd like to talk about low-cost sensors, but interestingly, we arrive in pretty much the same place that Dr. Lalman arrives, and that's on people. So we'll start with the sensors, and then we'll move into the people section. So this is a picture of Townsville as it's pretty much as it was on Sunday when I went for a walk along this very path. I dropped my daughter at an event and went for a walk for about an hour and a half along a beautiful strand, which covers the seaside. We face the Coral Sea and we really enjoy the environment here in Townsville. We have a tropical climate. It gets quite warm, but we have beautiful weather. But of course, that comes with its own set of risks. And this is an image from the 2019 Townsville floods. Obviously, these were devastating floods for our region, and you can see that the river has clearly exceeded its banks. And much like some of the presenters before, you can see the effects of that on people's lives and livelihoods. This shot from a drone is particularly telling. You can see people, the rain hasn't even stopped, and people are trying to return to normal and collecting up all their possessions and things like that. So there's obviously a really serious impact on people. My day job is to prevent disasters, and as Dr. Lalman rightly pointed out, it's pretty rare to receive any awards or success or medals for that. But my volunteer job, my love job, is to respond with the state emergency service when these natural hazards befall us. This is some image of some work that we did around the Townsville floods. In North Queensland, we love boating, we love fishing, and contrary to popular opinion, this is not how we normally park our boats in our garages in North Queensland. But there were some successes as well. Some infrastructure was built with exactly the types of circumstances in mind that we're discussing here today. This is a picture of an electrical substation at Anoomba, again from a drone shot. You can see in the middle of screen, the power transformers are well and truly out of the water, and the control building is as well. This was a 0.2% annual exceedance probability event. So what people sometimes refer to as a 1 in 500 flood event. I don't like that terminology because sometimes people misunderstand and think that they'll get 499 years without a flood now. And of course, that's not the case. It's a 0.2% chance of this flood happening every year. And obviously, we need to protect critical infrastructure. We need to protect people, more importantly, but we also need to protect all of those things that we value. Jacques Cousteau, who, for those of you who may be a little young to know who Jacques Cousteau was, he was kind of the David Attenborough of the ocean. He, in the 20th century, he was very famous for promoting sustainability and the resilience of the natural environment, especially within marine environments. And I guess that whole idea that Jacques Cousteau used to promote was that people protect what they love. I think we have to understand that before we can develop the systems and the technologies to allow us to protect those things. So low-cost sensors are one way to do that. Let's talk about the sensors now, but then we'll talk about why we do it very shortly. So as you can see here, this is a very cunningly placed sensor on the bank of a river. Obviously, the river's overflowing at the moment. You can see the sensor in the middle of the screen, and it doesn't have much visual impact on the natural environment. You can obviously make them any color that you like. But what's interesting about this one is that the sensor is a housing for a LiDAR framework. And the LiDAR framework can measure the distance to the ground. So when this area floods, the LiDAR picks up very rapidly the changes in flood height. And these are relatively low-cost sensors compared to the sensors that your national meteorology services use. These are extremely low-cost sensors, and they can, in fact, be attached to almost anything. So they, you can, quite often we attach them to electricity poles, so you get a really good feeling for what's going on. We can attach them to trees or buildings. And as you can see from the graphic on the right, hopefully that graphic is playing for you, and you can see as the water height changes, the sensors can change color on a map. So you can geolocate the sensors on a map and you can see what's happening. And this is a recent event in Townsville. So the images that I showed you at the start of the presentation are from 2019. This is from 2022 in an area called Saunders Creek. And in this area, the flooding came through rather rapidly, as you can see, and then it peaks and then it drops off, and the sensors change colour. The representations of the sensors change colour, and this, because we had so many of these sensors in place, the Townsville City Council that installed these sensors was able to get better information than the actual Australian Bureau of Meteorology about how the flood was progressing. So more discrete information, which of course you can then share with your population. And traditionally in Queensland, which is where I live in Australia, we do that through what we call disaster dashboards. So these are web pages that display all sorts of information about what's happening on the ground during either a flooding event or a storm event or fire, bushfire, or whatever it happens to be. Road closures, airport closures, all sorts of information can be displayed through these disaster dashboards. On the left is the information that the public sees. We recently did a project for Cloncurry Shire Council, which is a massive council. It's a council in the west of Queensland. There's only about 2,000 people living there, but the size of the shire is 40,000 square kilometres. So it's bigger than a lot of countries. It's bigger than Greece, but there's only 2,000 people living there. And a large part of that is mining and cattle farming. And what we see here is that the population is better informed about road closures, so that instead of driving out during the rain and getting caught between two creeks or two rivers, they access this information and they stay at home. And so, you know, instead of being caught in a fairly dire situation, they're able to make a good decision based on this information that we're gathering from either the Bureau of Meteorology or these sensors or those sorts of things that's communicated. The image on the right is actually the incident management system that sits behind that. So that is the system that the authorities use to manage the event. So they can structure the event in any way and they can publish information to the community through that dashboard. So it's important to not only collect the information to manage any hazard that is befalling a population, but it's also extremely important to communicate that information out. So we always need to take into account that entire system of gathering information and then sending information to the parties that can best use it. There are plenty of other ways in Australia that we use low-cost sensors. This is one of my favourites. I'm sure many of you will recognise the Sydney Harbour Bridge, one of our national icons. And although this is more for asset management and preventative maintenance, exactly as Dr. Lalman said, we build this infrastructure and we intend to build it for 40 years or 60 years or 80 years, and it lives for much longer than that. So the Sydney Harbour Bridge is about 90 years old, and only recently did it have to go through a serious amount of preventative maintenance to kind of uplift the ability of the bridge to continue for a longer period of time. So assets are often exceeding their intended service life to sort of go on with providing the service that they do. And if you took the Sydney Harbour Bridge away, not only would we lose a national icon, but plenty of people would have difficulty, you know, commuting and getting to and from work and to all of the things that people value, the things that they love, the things that they want to protect. So, of course, these sensors are installed on spans within the bridge and under two of the main decks, and they can detect vibration and they can give a picture to the engineers of how the bridge is performing. So again, it's about averting a hazard before it falls. It's exactly what Dr. Lalman was talking about with this growing urban risk, but preventing the risk rather than waiting for it to happen and responding. And I think we can all get involved in this. This is something that I love, is that with low-cost sensors, we can all get involved in it. So this is a particularly interesting device that I like called a Raspberry Shake or a Raspberry Boom. They have a couple of different models. It started with a very low-cost electronic suite called Raspberry Pis. And some clever people took the Raspberry Pi and turned it into effectively a seismometer, and it's a very cheap seismometer. So, you know, these devices usually cost, you know, a significant amount of money, but for a few $100s, people can have a Raspberry Shake or Raspberry Boom or whatever within their house or their business or wherever they want to install it. And then it contains 3 main sensors that allow you to work out if there's up and down shaking or lateral shaking and changes in pressure. And then those can be reported via the internet up into a mapping system. And what it does is it gives people a much better idea of what's going on when we have, you know, an event that many of our speakers previously have been talking about, a shaking event for whatever reason, whether it's volcanic eruption or earthquake or landslide. These sensors can predict all of those sorts of things and give us a lot more data. So I absolutely love citizen science, where we kind of democratize science, where science is able to be done for a low cost everywhere. And what I find interesting about this is when it comes full circle. So the Raspberry Shake is now being used by Geoscience Australia. So these are the folks that use, you know, obviously the high cost sensors, and we shouldn't be replacing those. We still should be investing in national high cost sensors, but they're supplementing that with low cost sensors. And recently there was a very successful project in Papua New Guinea, just to the north of Australia, that was funded via Australian aid and performed by Geoscience Australia, where they developed one of these Raspberry Shake networks, community-based seismic network, where people were able to access the sensors and spread them right throughout Papua New Guinea. And because the sensors and indeed some of the webcams that they're using are so cheap, they're actually able to put them in high hazard locations. So they have sensors on the sides of volcanoes, and they have webcams right up near the volcano, so they can see what's going on. They can monitor very, very closely. And if you lose a sensor, it doesn't cost that much. It's okay. You can replace it after the event subsides. Of course, as well as just sensors, there was a whole raft of things that the Geoscience Australia did in Papua New Guinea as part of this project, including information, talking to the public, again, communicating the information via a public tsunami guide. And of course, they did the genuine science that sits behind the risk assessment, as we've heard about from other speakers today too, a national seismic hazard assessment, the tsunami hazard assessment, and then a website to communicate that information so that emergency managers and those sorts of folks can use that information. Anybody can use that information to do their risk planning. So I think an incredibly successful project that has kind of come full circle, where the people who are using the expensive gear are now using the cheap gear to provide a better picture for an entire country about their natural hazard risk. And again, why do we do this? Well, we do it to protect communities. And one of the things that we promote here in Australia is a concept called community continuity. You may have heard of business continuity, where you look at a business or an organisation and you try to keep it running based on its critical functions. You look at what it does, how it does it, and you try and protect those things from whatever comes along. Well, a lady by the name of Anne Ledbetter in Australia came up with this concept of community continuity, where you do exactly the same thing for communities. You work out what a community loves, what they want to protect, how the community would normally look, and then you try and set the things up that can prevent the hazard from becoming a disaster. Just as David well and truly pointed out, it's only a disaster when it meets a vulnerability. If there's no vulnerability, the hazard passes through and nobody dies, damage isn't done, then it's not a disaster, it's just a hazard. And obviously that's the goal, that's what we'd like to achieve. So as part of community continuity, we grab a picture of the community as it normally functions, and we try to protect that. You build a community profile, and then you protect the critical functions. You think of how long you can live without certain things. How long can we go without water? How long can we go without power? How long can we go without food? Those sorts of things, without new logistics coming into the organisation. You try and protect those supply chains and those elements of the community that people really, really need And often it's on their worst day when something terrible like a flood or a fire or an earthquake has happened. And I think it kind of looks like this. So you've got all these hazards that could possibly befall the community at the top of the screen here. And between that and the hazards, there's lots of different things. So, these blue items are all the organizations, the financial institutions, the grocery organizations, the supermarkets, the fuel organizations, those sorts of things. And then there's also the infrastructure, the harder infrastructure, the electricity networks, the communication networks, all of the bridges and roads and traffic lights and those sorts of things that allow us to continue to function. And then amongst all that, there's the things that we really live for. These are the cups of coffee. These are the opera, the music, the art, the shows, those sorts of things. Those things that we love about our communities that are kind of the cherry on top that we really, really enjoy doing. And if you put all those together, I think they can provide an effective defense against many of these disasters. If we build resilience into them, if we do exactly as David was talking about, we think about the future and we wonder what our future selves will thank us for, we can build both sustainability and resilience into our current activities so that instead of vulnerabilities, these become protections against all those hazards and our community can continue. It can keep functioning even when there is a hazard that befalls it. And I think it looks a little bit like this. So I tend to think of these things in systems because I think the encouraging thing about the graphic before was if you improve the resilience of any component of that system, you're actually improving the whole system. The arrows go in two directions in this graphic for a reason. Community resilience is at the top. It's absolutely most important. Whenever you talk to the emergency services, they want to protect lives first and foremost, protect lives, then livelihoods, then property, and then the environment. And that's really important that we understand our objectives to make sure that we can improve the system most efficiently as we can. So community sits on top, the infrastructure sits underneath that, and the organisations that allow that to work and the organisations that allow us all to have productive lives are also a big part of this picture. And it all sits on the environment, obviously. And the reason the arrows go both ways is because it's a feedback system. So, if you improve community resilience, that means people are more able to go to their workplace, to be parts of organisations. And if you improve the infrastructure, the organisations can continue. And if that organisation happens to be the electricity company or the water company or the communications company or any company that supports the community, well, then the community resilience feeds into the organisational resilience, which feeds back into the community resilience. It allows the community to keep functioning. So again, another encouraging graphic to show us how we can create these systems and intervene in these systems to make them more resilient and build up the resilience of the whole. There's a famous resilience engineer, a man by the name of Eric Holnagel, and he gives us a very good definition of what a resilient system looks like. And a resilient system can adjust. It can adjust its functioning prior to, during, or following events that disturb it, which we're talking about today as natural hazards. And it can sustain the required operations, whether you have expected conditions or unexpected conditions. And so building resilience into all of these systems allows us, effectively, the objective is to continue no matter what the hazard. If we can continue no matter what the hazard and remove so many of those vulnerabilities, all of a sudden we have systems that are truly resilient and they can continue functioning. And of course, that comes back to the people. The people can continue functioning with their lives and move on. And I'd like to sort of get close to finishing with a diagram about systems resilience and then just three key takeaways. So this diagram shows the inputs to provide systemic resilience. So absorptive capacity is the ability of a system to absorb those external events and keep functioning. So, no or very little disruption to the system. But of course, that's not always possible. And so systems often have to adapt to conditions within the environment that allow for that adaptation. But we start getting into really interesting areas where we start talking about anticipative capacity and predictive capacity. So when the system can see what's happening in advance and then adjust its operation accordingly. So as an example, that might be an electricity network. On a very, very hot day, the electricity network changes its operation so that it can derate itself so as not to pass quite so much electricity through. And that might be during a high fire hazard day when we heard earlier about electrical fires potentially happening. It might be an opportunity to prevent those electrical fires from happening by changing the way the electricity system works based on a prediction of fire weather behaviour. And also one of the holy grails of system resilience, I guess, is restorative capacity, which is restoring the system. It's kind of like a self-healing network, a little bit like your body. If you get a cut on your arm, it heals itself. Well, if we have networks that can restore themselves automatically, and even more incredibly transform themselves so that they're ready for the next event. So if they learn from the event and prepare for the next event even better. And I think that's where low-cost sensor arrays and multi-hazard early warning systems can feed into those anticipative and restorative capacities and that transformative capacity to make even better systems. So I'll finish very shortly with just these 3 observations. I think if you're working...
Mr. Quinn, sorry to interrupt. Certainly. Could you please wind up in 1 or 2 minutes?
Absolutely. So just 3 key takeaways and then I'll be done. So these 3 key takeaways, I think, are really important for us to think about. So if you are thinking about how to use technology and sensors and these sorts of things to improve resilience, I think look at the objective, which is the people, which is the community, and you'll know what you need to do. So I'd say focus not just on warnings, but on helping your community to continue. Think about community continuity. Think about what it is that you're trying to protect. Communicate the hazard information to your community. I was very pleased for the question to Dr. Ranhawa about whether the community had seen that mapping and that information. And he said, yes, that was shared with the community. That is excellent behaviour. That's great for allowing people to make good decisions because the people out there are the first responders. They need the information when something happens. So I love the fact that that information is being shared in his province. And then the last thing is, I would say, look at the system, not just the service. So if you're thinking about infrastructure, don't just think about the concrete and steel. Think about the service that it delivers to the community. Is it electricity? Is it water? What do people do with that? What is it that they actually need rather than how we actually deliver it? And if you think of the system and not just the service, I think we can go a long way to building resilience in to the future and, potentially maybe taking the top off that graph of that hazard information that Dr. Laumann was showing us previously. So look, thank you very much for listening to my thoughts on this matter. And I certainly hope that the rest of the conference is as interesting and exciting as the presentations that I saw earlier this morning. Or earlier this afternoon for you, and it's well and truly evening for me here in Australia. So thank you very much for your attention, and happy to take questions now or at the end. I'll be staying.
Thank you, Mr. Quinn. It was a very excellent presentation. Very interesting for us who work in a community-centric research framework, incorporating low-cost sensing as well as how to communicate hazard information to the community. We would love to hear from you more about this at the end of the session during our short discussion session, which follows the next speaker.
Thank you.
So with that, thank you, sir. Let me introduce our next speaker, Professor Ronnie Alexander, who is a UNESCO chair on gender and vulnerability in disaster risk reduction support from Kobe University, Japan. Her work in peace research and international relations focus on life and security, attempting to look critically at the intersections of gender, sexuality, peace, and violence. A warm welcome to you, ma'am. Let me hand over the session to you.
Okay. Thank you very much. Let me share my screen, please. Okay. Thank you very much for this opportunity to be here. I'm truly honored and grateful. And I've been very impressed with the presentations thus far. Let me, hang on a minute, Zoom is in the way of my slideshow. Here we go. Thank you. So I'm going to present something a little bit different because it's really a social science perspective. And I'm just going to very briefly introduce to you the work of the Kobe University UNESCO Chair and talk a little bit about why we think it's important. So our UNESCO Chair is on gender, vulnerability, and well-being in disaster. And it's run by the Kobe University Gender Equality Office. And this office is, I think you probably have one in all of your universities. It's the one that's responsible for faculty and staff work-life balance issues and increasing women faculty members. And this is very important in Japan. And in 2016, for the first time, they applied for a UNESCO chair, and it was finally granted in 2018. And the impetus for this was, first of all, the Great Hanshin Awaji earthquake, which happened in 1995, and it was the largest urban earthquake that Japan had seen. I was living in Kobe at that time, and it really was quite terrifying. And one of the things that we learned from this is that lots of people do disaster research, but not very many people do research from a gender perspective or a women's perspective, and also from the perspective of sexual minorities. That's even less. And so we wanted to get a UNESCO chair to try to promote more emphasis on gender. And the other is that I suppose you all probably know that on the global gender gap ranking, Japan ranks 116th out of 146 countries. And so they thought it would be a good way to get people to start thinking about gender. Okay, we have partners in Asia, and as you know, we've seen some examples that Asia is very prone to disaster. And so our UNESCO chair is focused on Asia, and the idea is to think about gender and vulnerability. And now the second term is well-being as well. And as far as I know, it's the only UNESCO chair that focuses on gender and disaster. And our partners are in Indonesia, Malaysia, Taiwan, and Thailand. And this is sort of who they are, universities and one NGO, Mercy Malaysia. We work very well together. We have a education program and a research program, and hopefully we'll have an outreach program at some point. This is just a summary on this slide of the difference between the two, but basically we focus on a 2-week summer program for students, and we're now trying to create some curriculum materials and build our research network. So we're most, I think, successful in the education program. And some of the students that have taken part in this as undergraduates have now decided that they want to study and learn more about gender and disaster and have gone on to graduate programs. We now have some of the students who participated as undergraduates coming back as facilitators for later conferences. So we're doing, I think, a very small but good job of getting students interested in training professionals in this field. So we began in 2018, so we only had a couple of chances to travel. And since 2020, like everybody else, we've been online, but we have a lot of students, 60 students participating in those conferences. And this is our education program where the students are given, I guess you call it problem-based learning. They're given a task and they have to work on that and present their findings at the end. And these are all multinational groups, so it's a very good international exchange program for the students. Our research program, we're currently working on publishing a book that has case studies on different aspects of gender and disaster. Hopefully the manuscript will be finished. We've passed our referee, and hopefully we'll be actually finished sometime by the end of this fiscal year. But I want just for a few minutes to tell you something that I think you already know, but maybe perhaps to remind you of it. And that's that in disasters, and we've seen photographs and really excellent presentations this evening, or maybe it's this morning where you are, women, boys, and girls are much more likely to die in disasters than men. And sometimes men, being men, do dangerous things and they die too. And of course, it depends on what they're doing and where they are. But as a rule, women, boys, and girls tend to be more vulnerable. So we focus on gender. And when we talk about gender, we think about it as socially constructed rules and expectations for women and men and others that underlie social institutions and relations. And these are, some of the ideas that we work with. You can read the slide yourself, but the idea that gender binaries prioritize masculinity, and they deny equal opportunities to women, but also to other genders and to marginalized masculinities as well. And so that we question binary approaches in their entirety, but we also focus on women as being one large group that tends to be very, very vulnerable. And the reasons so when, for example, we talk about community, we need to talk about community, but we have to understand that in those communities, oftentimes, women might be excluded just by virtue of their gender, or the social institutions might be gendered. There might be assumptions that keep women from participating in community decisions in the same ways that men do. And there might be reasons that women, even if they had information, they lack access to information, but even if they had it, oftentimes they're not really able to effectively evaluate it or to distinguish between information that's reliable and information that is not. And we have seen quite a lot of that with COVID-19. And also, when there's a disaster or after a disaster, many of the responsibilities that were done by other people, care responsibilities, fall on women. So maybe grandmother and mother did them, but now grandmother isn't there to do it, and they all fall on mother. Other people come to live with them. There are lots of different reasons why it might happen. But care responsibilities tend to increase, and women have fewer ways to access social resources and opportunities. So the effects of disaster can stay with them for a longer time. And we've also seen this. There's been, I think, quite a lot of talk about how COVID-19 has really done bad things to women all across the board, that the care workers tend to be women, frontline workers tend to be women, the layoffs, domestic violence, all of these things. And I guess I should add that when there's a disaster and after a disaster, there generally tends to be a great increase in gender-based violence, particularly violence against women. Now, I think this is also another thing that everybody knows, but perhaps we might find it useful to be reminded that it's not just disasters or emergencies that make women vulnerable. It's what makes them vulnerable is the underlying inequalities in their lives. And those start well before disasters happen. If they can be changed, then resilience can be raised, or this is what we believe. And this, from the global gender gap, perhaps there's some criticism of it, of course, in Asia, as well as acceptance of it, but you can see, actually my Zoom is covering it, but here we go, East Asia. This is the number of years that it's estimated to take before the gender gap can be closed. And they're suggesting that for East Asia and the Pacific, our region here, it's 168 years. So, and it's gone backwards since COVID. So we really do need to think about these underlying causes. So this is all of what we've learned. And what now we want to learn, we want to know more about is we want to be able to make more specific guidelines to reduce the vulnerability of women. And this is what we're doing through our book with different case studies. But we want to be able to do it better and to do more of it. We also want to be able to contribute to disaster research that includes sexual minorities. And there's a great need for this. And we're just beginning now to work on that. And we also want to develop some curriculum materials around these things. We're now thinking about a comparative study among our partner universities to look at COVID-19 and look at disaster plans and the ways that universities have coped with this in order to try to find ways to help universities to be more inclusive and to develop better plans and guidelines, particularly for vulnerable groups in their universities. And finally, I'll just end up with my own work, which is the presentations that we've heard, and most of what I've talked about too, really focuses on being safe. But the other side of being safe is whether or not people feel safe. And my work involves drawing with people after disasters, not in a therapeutical way, but in a way to collect their stories of disaster and to help to understand what it is that makes them feel safe or unsafe. And it's very interesting and I think very important when we separate this safety from physical safety to how a person feels about their safety, because they can be very different. And until a person feels relatively safe, even if they aren't really physically safe, they're not going to be able to move forward and to take part in community and other activities to rebuild their communities. So emphasizing feelings of safety, I think, is also very important too. And so I will end on that note and thank you for your time and for listening and for this very interesting session.
Thank you very much, ma'am. With that, we are coming to the end of this session. We had a very dynamic session with topics ranging from estimating earthquake damage to a discussion about hazard vulnerability in Himachal Pradesh to discussions on resilient futures in the face of extreme events, monitoring disasters, as well as how to use low-cost sensors for disaster risk reduction. And we wound up with a very important topic on taking a gender-sensitive approach to resilience. With that, since we have overshot our allocated time for the session, I'm extremely sorry to announce that we are not taking up question answers in this part. I humbly request the speakers to please go through the chat box, because there are a couple of questions in the chat as well as Q&A box. If you could answer them, it would be extremely useful for the attendees. Thank you all once again. Let me hand over the session back to the organizers, because we have a very exciting panel discussion awaiting us. Thank you, everybody, for listening to this session.
Thank you for a wonderful session. We'll now have a short break for 5 minutes and then reconvene for the next plenary section. Thank you.
For over 4 decades, our Chancellor, Srimata Amritanandamayi Devi, Amma, has traveled to all 6 continents, addressing and bringing solace to over 50 million people. Her embrace, that began as a sheer expression of compassion, has over the years shaped out to be the largest global drive to create a sustainable future for all. Love and compassion towards all beings are the very foundation of our existence. Amma is the living embodiment of these very values. Amma says, "We are not isolated islands, but are connected to each other like links on a chain. With an unparalleled vision to revive, nurture, and protect nature, Amma has for more than 40 years continuously strived and pioneered various initiatives to restore harmony and embrace sustainability as a way of life." Amma's initiatives are aligned towards achieving the Sustainable Development Goals. As a member organization of the United Nations Billion Tree Campaign, through Amma's initiative called Green Friends, over 1 million trees have been planted across the 6 continents since 2001. Amma has promoted the cultivation and consumption of organically grown vegetables in 101 communities adopted under the Amrita Serve program. Along with this, organic gardens and farming initiatives such as Haritamritam and Growin have been established. To make clean drinking water accessible to one and all, Amma's organization has launched Jeevamritam, a $15.2 million clean drinking water provisioning project for 5,000 villages in India. Along with this, Amma has initiated several programs to provide water access by implementing a number of solutions. Through Amma's Amalabharatam campaign that started in 2010, more than 7,500 cleanliness drives have been organized by mobilizing 10,000 plus volunteers, clocking over 500,000 hours in 23 states across India. One of the largest drives has been the cleanup of the Holy Pampa River at Shabarimala, which hosts one of the massive religious gatherings in the world annually. The cleanups have been mammoth efforts of 72 hours of hard work of 5,000 plus volunteers from over 12 countries, participating each year, clearing over 2 tons of waste each day. Other key initiatives include awareness drives and distribution of handkerchiefs to school children to promote personal hygiene, design and distribution of banana fiber-based sanitary pads, and a citizen-centric approach to clean the roads across Kerala, with the distribution of 1,000 bicycles and waste bins deployed at 2-kilometer intervals. Amma's organization has donated 1 billion Indian rupees to the Government of India for rejuvenating the River Ganges as a part of the Clean Ganges project. The team has built more than 12,000 toilets with democratic participation.
Welcome back, everyone. We will now have a panel discussion on governments, industries, non-profits in MHEWS. What is next? It will be chaired by Professor Vinod Menon. Professor Vinod is a founding member of the National Disaster Management Authority, NDMA, India. We are delighted to have you, Professor Vinod. Over to you, sir.
Thank you very much. I think the day one and day two of MWCR 2022 has been extremely refreshing, reinvigorating, and challenging. I feel that actually, these sessions have been very thought-provoking and forcing everybody who has been listening to these presentations to really challenge themselves, because I think most of these sessions have actually been really giving us the input to challenge ourselves in really trying to see how best we will be able to meet the challenge posed by Antonio Guterres, the Secretary General of the UN, when he said that I'm going to announce early warning for all within the next 5 years. And we know that the International Day for Disaster Risk Reduction on 13th October came up with a report which said that half the countries in the world do not have any early warning. And the number of people who are actually—
Excuse me, sir.
Yeah.
Would you please speak a little louder?
Yeah. Can you hear me?
Yes, but it is not so clear.
Okay, just a minute. Are you able to hear me now? Hello?
It's in the same situation. If it is possible for you, please use some device to enhance and boost your, amplify your voice.
Okay, please let me know if you are able to hear me. Hello?
Professor Menon, this is good. This is good. Thank you.
Is this fine?
Yeah, we can hear you, sir.
Okay, thank you. Actually, I think the challenge is that we need to really see how best we will be able to come up with a better early warning system to make sure that we are able to communicate in a way where the vulnerable sections in the last mile will be able to get the early warning. So now this particular panel discussion is actually bringing together a group of experts who will actually be sharing their thoughts on how governments, industries, and non-profits will actually be able to give their inputs in terms of how multi-hazard early warning systems can be more effective and people-centered. We listened to the presentations of the earlier panel today, where Dr. David Lallemans and Mr. Chris Quinn brought in the systems thinking, and Ronnie actually brought in the gender aspect. I think we need to really look at social engineering, because one of the things which Margaret Mead had written is that we need to really, a small group of people can really change the world. If we are committed, if we are passionate, and I think Amrita University brings in passion and compassion, a passion for bringing together like-minded people who can actually contribute to really a transformative society. And that 2021 to 2030 is the UN decade on ecosystem restoration. if you look at decadeonecosystemrestoration.org, you will see that there are lots of things which they're talking about, and systems thinking is important, and we will actually listen to these presentations. So I have basically asked these distinguished panelists who are assembled now to really tell us what, in their view, would actually be, what are the most important critical gaps in the early warning systems, the multi-hazard early warning systems from the perspective of your sector, whether you're working in the government, in the civil society, as a professional. What are the critical gaps in multi-hazard early warning systems from the perspective of your sector and your constituency? By constituency, I mean your professionalism, in your discipline, and your thoughts in terms of how you think, like what Chris Swin talked about sensors, low-cost sensors. Now, low-cost sensors can actually contribute in flood level monitoring, water quality monitoring, BOD levels by sensors remotely. You can actually do that. And the most important things which can happen is that you have edge computing or cloud computing. Even without internet, the sensing devices can actually take records of data, take feedback, voice and text, and then communicate that to others by uploading it onto a server on the cloud when you are actually entering a Wi-Fi zone. So these are all things which are possible. And I'm very happy that we have Dr. David Lalaman, Mr. Chris Swin, repeatedly also joining this same session, because this is actually challenging ourselves. We need to really come up with this. And finally, if we have time, we will also ask you on building from each other's thoughts, because we have people who have that kind of background. So we have Dr. Srivalsa Kolakiar, Assistant Professor, Department of Civil Engineering, NIT Surathkal, which is one of the best NITs in the country. Ranks as one of the top institutions in the country in civil engineering. And he's an Assistant Professor of Civil Engineering with an MTech from IIT Kanpur and a PhD from Indian Institute of Science, Bangalore. And he's an author of 5 books. Many of them are actually, compulsory study materials for even universities like MIT and Stanford and, and many other leading universities. So very happy to have Dr. Srivalsa Kolakiar. Request you to kindly give your thoughts on how multi-hazard early warning systems can be more people-centered.
Thank you very much, sir. Sir, how much time I can take?
5 minutes.
Yeah,
I'm sorry.
thank you, sir.
Yeah.
So, Dr. Vinod Menon has given a overview with insights into the multi-hazard early warning system. So all of us know it has been suggested by and recommended by the United Nations also as part of the Sendai framework. So government, industries, and non-profit organizations' role. So first, when we talk about handling the disaster, I think first, as Professor Menon rightly suggested, the responsibility, integrity, commitment, and compassion. That should be the main point, because we know how even the policy makers or even the national leaders, they react to the people's emotions. And we know in all countries, not only in India or in any democratic country, actually, they need to satisfy people, because when the elections are arriving, because I am saying this with my personal experience, because we have visited tremor affected sites and landslide affected areas. So I personally felt that our leaders also lack integrity. They make announcement to satisfy people. When there is a disaster, after post disaster, there is a lot of actions. But maybe after 1 year or even just after a few months, everything is forgotten. So there comes the importance of integrity, and also the importance of these kinds of symposiums and panel discussions, where we have to remind ourselves to keep the preparedness alive for long. Now, when we talk about early warning, so these days sensor networks, so sensors are very popular. maybe I have a different opinion. Of course, we should use all the advancements in technology, including sensors, but our sense is more important than the sensors. We should apply our common sense, because in my district where my institute is now, where I am sitting now, couple of months back, there was a landslide where one house was completely buried under the soil. 6 hours ago, the people, the local villagers have warned that house owner to evacuate, because there were trees were tilting. It was a rubber plantation. There were cracks visible. So without any sensors, just by observation, observing nature, they could perceive that there is an impending landslide that is going to happen. But they did not listen. They have not evacuated, and unfortunately, the house was buried. Same thing happened during the Talakavi, the landslide, where the Kaveri river originates. There were 2 houses. Repeated warnings were given just based on rainfall intensity. No other assessment was done. There was no network or any other assessment, just based on the rainfall intensity. The district disaster management authority has given a warning, even written notice to evacuate the house, but one house was evacuated, other person did not. So I think, of course, sensor-based early warning can give us more reliable prediction, but just by observing nature and from the experience itself, actually, we can sense any impending disaster. Say, for example, floods, landslide, or even tsunami also we can give an accurate warning, because the earthquake waves reach just within few seconds, and the tsunami waves to reach the coast, it may take 1 to 2 hours for the water waves, but the body waves, P waves will reach very fast. But for earthquake, actually, giving early warning is impossible. We can give, just by observing the arrival time difference between the P wave and S waves, maybe just a few seconds of warning, which may not be sufficient to evacuate the people. But one small example, I will just take only 2 minutes, sir. So when there was an earthquake, Latur earthquake happened, we lost around 10,000 life. But same magnitude earthquake early in the morning, same time, actually next year it happened in California, and the casualty was just 2, where we lost around 10,000 life. So there is a popular saying, earthquakes don't kill people, but buildings do. So it is on the engineering, how we engineer the building, because all the infrastructure, because earthquakes, if an earthquake happens in Greenland where there are no people or buildings, there is no risk. Risk is 0. There is a hazard, but risk is 0. There is no disaster.
Okay, Dr. Shivalsa, I'm sorry, we need to.
Yeah, please. Yeah, thank you, sir. Thank you. Yeah.
Thank you very much. We have Mr. Chris Finn. We listened to him earlier in the earlier session. We would request him to also address this question. How can we really look at this? Because, we know that systems thinking is important. And the Club of Rome and the International Institute for Applied Systems Analysis in Austria and the Balaton Group, they have all been talking about it. MIT, Jay Forrester at MIT talked about urban dynamics and systems dynamics. We actually know that there is also the need to really look at modeling, scenario analysis, looking at quantum technologies, the quantum mechanics. Actually, we need to really look at IoT, AI, expert systems, machine learning, big data analytics, and what he talked about, Raspberry Pi. There are lots of things, even in terms of looking at monitoring earthquakes, it's possible. So over to you, Mr. Chris Finn.
Thank you, Professor Menon. And I was struck while Dr. Srivalsa was talking about sensors, how the original sensors are eyes and ears and taste and touch, and the folks that you were talking about in your example, where they could see the destabilized ground and predict the landslide. That's exactly what we're talking about. So the electronic sensors that we've discussed in the previous presentation, they're really just an extension of our senses, our eyesight. And the interesting thing is when you see something, you don't necessarily understand something. And what takes information or data, and all these sensors do is produce data. And exactly as you say, you need a system to understand that. You need to understand all of the external parameters and the way things input, and people do that very well. So those people that saw that destabilized ground and knew there was going to be a landslide, they've got that wisdom or experience or something that allows them to imply intelligence to that data and actually predict an outcome. And I think that's really important when we think about sensors, that the human brain is kind of the best computer of them all, right? If you want to find the greatest technology for disaster risk reduction on the planet, we all have one. So, it's people that we're protecting. It's people that come up with the ideas. It's people that come up with the systems and that understand the systems and program the systems to make sense of this world and try to improve this world, which is why we're all here, right? We're trying to reduce suffering effectively by, protecting lives and property and those sorts of things. So I guess you asked what the key gaps are, and you mentioned the last mile, and I think that's extremely important because that's where all the people are. The last mile is where all the people are. So I think the low cost helps. I think we need to pursue that low cost option for gathering that information to understand the system and make sensible predictions. But then the communication, as we talked about in the last presentation as well. So that communication so that people can then make their own good decisions, because people make really great decisions. You were talking about some books that have been written recently. And I love Dan Kahneman's work where he talks about the ability of risk experts, and I consider myself a risk expert, but also, people in the street to both make really sort of good decisions around risk. So I think we have to empower people with the low cost and the systems that can produce the intelligence that allows people to make good decisions. I see big gaps there, and I think we have an opportunity across, as you say, across the next 10 years or so to fill them.
Yes. Yeah, thank you very much. We will continue to come back to some of these questions. And so we have now Dr. Yogita Shukla, who is the CEO and founder of, Agio Foundation. And she is also the founder of Women, WO-MEN, a network of women geospatial pottery, WGC, of which I'm also a member. And I have been attending several webinars, which WGC has been organizing. Very, very happy to see you here. And, you are an expert in GIS, remote sensing, and in environmental issues. And then I have been really watching the webinars and also participating in some of the discussions which you have been hosting. Very happy to see you here. And I would request you to kindly give your thoughts. Over to you.
Thank you so much, Dr. Menon. And I've been working as a researcher, a scientific researcher, and working in high altitude Himalayas. And this is where I find the disconnect, between the science research I was doing and how it is going to impact the lives of the people, because the research, whatever being done, either it is put as a project report or it is submitted as some paper or something, which doesn't reach the last mile. And this is where I realized that we need a kind of an information infrastructure, particularly geography-based information infrastructure, because nature has no boundaries. The boundaries are all created by us. So we should focus on from an eco-region perspective, and that and create build an information infrastructure which includes both the spatial and the non-spatial information. So as we are seeing a lot of technological improvements and new technologies coming up, but geospatial technologies and earth observation, they are not being mainstreamed the way they should have been. With related to disaster management, it's only when we need it, we talk about earth observation images, but we don't focus on building those infrastructure where the past data, the historical data, the present data, all clubbed together with the other sensors data can build that infrastructure for early warning systems. So that is where I started this foundation, where I wanted to focus on the application research and link it with the communities. The other important aspect which we forget is that we all have an intuitive intelligence towards nature, and that intuitive intelligence we have over a period of time, we have lost it, forgotten it. We have it with our indigenous communities, so we should also give importance to that intelligence, which where we observe not just the physical parameters but also the biological indicators, which talks about all the changes, very subtle changes happening in our surroundings. There are biological indicators, but we don't really focus on those biological indicators. And our indigenous communities, our indigenous people, they have a host of such information which needs to be brought together into the framework. The other thing which I have found out is the information which is kept in silos. So for example, Wadia Institute of Geology, they are doing a lot of work on the Himalayan region, but their work is accessible only to a few people. Then there's G.V. Pant Institute of Himalayan Ecology. Then we have Snow and Avalanche Institutes. So when we look, when we consider nature, it is a sum total of all the information, all the research we are doing. We need to have this information infrastructure which has integrated and collated the information from all these aspects also. Rather than having a siloed approach, we should think from a holistic approach, consider an eco-region, and bring towards efforts, as I said, not just government, but NGOs, and but also the communities. There is no direct participation of communities. There is no representation of communities into any of the forums, which we have been talking about. And they are the ones who are impacted. They are the ones whose lives are, at stake. So this is my thing, that we should build a platform where we should also engage with these communities also, and let that indigenous knowledge also be pulled into our systems or information infrastructure. What we are
Thank you. Thank you very much. In fact, what you're saying is the idea behind a national spatial data infrastructure, NSDI.
Yeah.
But the National Database on Emergency Management, which is with the National Remote Sensing Center, NRSC, is actually also to be crowdsourced, to be supported, because we have lots of APIs from IMD, from CWC, from INCOIS. But I think we need to have public domain access. We need to have access to this information. We need to build on the data. It has to be data driven. It has to also have OpenStreetMaps and OSM and crowdsourced image building. Because you remember when MH270 was missing, entire world got together to really start looking at specializations on every 1 degree by 1 degree grid on the flight path to see whether we could actually try and locate that aircraft from Malaysia Airlines, MH270. And there are many opportunities available for professionals to come together to start working together. So we have now Dr. David Lalaman, whom we have already listened to, but he's there from the Nanyang Technical University, and he's also the NRF fellow of the National Research Foundation in Singapore, also heading the Earth Observatory, the principal investigator of the EOS, Earth Observatory Singapore. And I think we need to really understand how technology solutions can be possible. And then there's a report which has actually come out from NTU, the National Technological University, from S. Rajaratnam School of International Studies in NTU, recently came out with a report last year. During COVID, they talked about disaster governance in the Asia Pacific, future pathways for South and Southeast Asia. So I have also contributed to that with Christopher Chen Ziming, and also Dr. David Blair, Alexander Alistair Cook in NTU. So actually what Dr. David Lalaman was talking about, he's also from MIT and Stanford, and also now at NTU, and I'm sure that he will also have lots more to say. I know that 5 minutes is not enough, but I would request you to kindly share your thoughts.
Well, thank you, Professor Vinod, for that, and glad to know that you're already working with some of the folks at RSIS at NTU. But I wanted to kind of follow up on some really kind of thoughtful insights that Dr. Yojita Shukla, sorry if I mispronounced that, mentioned, on the importance of developing models and technologies that are more equitable. And, there's a few things I wanted to mention. One is that in the way that we calculate risk, the standard practice is to calculate asset losses. And that's very different than calculating welfare losses. And it has big implications when you think about equity. And two simple examples to think about this are, if a household is very wealthy and owns 10 houses, and an earthquake happens and 3 of them get destroyed, another household only has 1 house and it's destroyed in that same earthquake. Somehow, when we do the analysis, the super wealthy household has suffered much more impact, 3 times more impact, in fact. And that may be true from a financial accounting standpoint, but for any real way that this earthquake has impacted these households, it's completely nonsensical. And so that's one example. The other example is when we do cost benefit analysis in order to construct a risk reduction intervention, if we focus only on asset losses, we'll consistently protect the high value neighborhoods and the high value communities, not the high vulnerability communities, because typically, the actual assets have low value. And we don't do this on purpose. Risk experts, when we do these calculations, and consultants, they don't do this on purpose. But that is a very real outcome of the way that we do these analyses. And there are alternatives. Chris Quinn mentioned a publication by Stefan Hailgate, who's published a lot on this approach of looking at welfare losses. And so we know how to do that already. At best, that only accounts for socioeconomic inequity. And as Dr. Yojita mentioned, there are other dimensions that we need to think about. Even when we look at fatalities and injuries, we count the number of people. We don't identify who those people are. In fact, we know that the elderly and the young children and the women are much more vulnerable to floods and earthquakes, and actually dying from them. But we don't do that in our models, and we should, and we can already develop some models to better do that. Same, with languages. There are different communities with different languages. If we think about, obviously, early warning systems, we need to make sure that we know which language the most vulnerable groups speak, so that the early warning systems can be better targeted. And the other thing, so right now, this is really just related to distributive justice and distributed equity. But Dr. Yojita also mentioned participation. And so there's also really important kind of procedural equity issues at stake, that we need people to participate in the development of these tools. And women need to participate, indigenous communities need to participate in these tools. And because oftentimes, a lot of the experts, which primarily are not the marginalized groups, have blind spots when it comes to the impacts of these
technologies.
I think I'll just leave it to that.
Yeah. Thank you very much. Dr. David, actually, you mentioned about the challenges in terms of distributive justice. I think this is one of the big challenges in disaster risk reduction when you're talking about risk, vulnerability, and exposure. Just think of a community where you have a women-headed household, which has a physically challenged or a mentally retarded, or a disabled person, and also from a family which is a Dalit family. You actually have differential vulnerabilities in the same household. And if you have a bedridden person or a wheelchair-bound person in that household, or a palliative care patient who has gone through an organ transplant, or a cancer, chemotherapy, radiation, or kidney dialysis, you have multiple complex challenges in trying to look at how we protect the rights and entitlements of communities. And that is where, we need early warning systems which are understandable, communicated to communities who will be able to understand this. So there's a difference between forecast, alert, alarm, and early warning. We need to understand that. How do we really distinguish between a forecast, an alert, an alarm, and an early warning to save lives, to minimize economic damage? So now we have, Dr. Lok Vidya Adhikari, from Nepal, from the Nepal. He's chief of the senior divisional seismologist in the National Seismological Center in the Department of Mines and Geology in Kathmandu. One person who has actually been extremely active in the 2015 earthquake and post-earthquake assessments. And so I have been interacting with the Nepal, the National Disaster Risk Reduction and Management Authority, with people, who have been actually working, from the Nepal Reconstruction Authority, NRA, and which became the National Disaster Response and Reconstruction Authority. So we have been having some discussions in terms of the work which you have been doing in Nepal after the 2015 earthquake. So over to you in terms of your expectations and your understanding in terms of your contributions and suggestions on how multi-hazard early warning systems can be more people-centered. Over to you. Please unmute yourself.
Thank you, Professor Menon, for the presentation and introduction. So most of the sessions I took yesterday and today, so we learn a lot about the need of the multi-hazard early warning system and how it works and what we have to do. So for me, like you said, so I'm a seismologist working in the earthquake and especially in the Gorkha earthquake. So, so today, just I want to emphasize on the disasters that are common in India and Nepal, and what we can do in case of research in a similar field and in the early warning system, because the need of early warning system is now it is proved and it is necessary for all the institute, all the people, for the community and for the government to reduce the loss of the life and the livelihood of the country. If we talk about the large disasters in Nepal, so the earthquake is come the first. Similarly, even though it is not regular, and then flood. So is another the great disaster that is happening every year in Nepal and simultaneously in India also. And Gulf. So we don't have to forget about the Gulf because we have many incidents recently in the past years also, and the landslides. So typically these four hazards we have in common, except tsunami and volcanoes that may occur in India also. If we talk about these disasters, so first I would like to talk about the earthquake. So if we remember the 1934 earthquake, so similar number of people were killed by that earthquake in Nepal and in India. So almost more than 8,000 people in Nepal and more than 8,000 people in India. So the source region for the earthquake lies in the Himalayas, let's say. It's the northern part of India. And Nepal occupies almost 1/3 of the Himalayas. And fortunately, so we share, more than 1,800 kilometers of borders between Nepal and India. So that means we have many things in common that we can work for future to reduce the loss of life of the people of the both countries, which we haven't maybe initiated or worked till now in government level, but in privately in institutional level, maybe we have started, we are working, but it is not enough. So what we are doing together.
Yeah, but the National Center for Seismology in India and your National Seismological Center have been having a lot of data sharing, and so there has been some work.
So sorry to say, so we don't have any kind of data sharing or official relation till now. So I many during this kind of conversation and this kind of meetings, so I used to raise these questions. At least we can work on the data just nearby borders, because so we can start our work near the borders at least, even though we cannot do any other kind of things. But
right.
I'm talking.
But there are certain transboundary issues. We will come to that because this issue is very important. What we're talking about, the need for cooperation and data sharing, not only for earthquakes but also for floods between Bangladesh,
yes,
India, Nepal. We need to have a lot of data sharing in transboundary data sharing between communities and also between governments. So we will come back to you. I would request the next speaker, Dr. Venugopal Rao from the INCOIS. He's one of the senior scientists, Scientist E in the INCOIS, and very closely involved in multi-hazard early warning systems, the tsunami early warning system. When Dr. Shailesh Nayak was heading the INCOIS, when the tsunami early warning system was actually under preparation, and Dr. Srinivas is there now. So I feel that INCOIS work is not only relevant in terms of the tsunami early warning, but also information to the fishermen in the coast, and so Navik and many other things. Dr. Venugopal Rao, we'd like to listen to you on multi-hazard early warning systems and what your thoughts are.
Thank you, Professor Menon. This is Venugopal from INCOIS. I'll be talking mostly in communication and last mile connectivity. Right now, we have a lot of content information. Our major challenge always last mile connectivity. Last 15 years, INCOIS working on different communication technologies. Initially, we have started with the SMS, digital display boards across the Indian coast and Andaman Islands. In 2018-19, we started with aggressively with ISRO, and we could able to bring one a Navik receiver. And there is a limitation of a boundary around 1400 kilometer Indian coast. Further, we went to with the airport authority. We have developed a garner receiver. It covers 3/4 of the world, actually, it up to Australia. That is a very good development. We have done it actually, and this is one of the, and we could able to develop some of the 2-3 industries also. And further, recently we have also discussed in ISRO, and we could develop actually the two-way MSS terminal. There's a major challenge is when fishermen venture into the ocean. There is two-way communication is a major challenge actually. We have now one-way communication is coverage is there totally Indian Ocean actually up to Australia and all. Two-way now there is a satellite GSAT-6 actually. Its major problem is that 25 kilometers from Indian coast is there is a voice and data. Now the Tamil Nadu state government, state fisheries coordinate with the SAC of Ahmedabad. They have developed actually device actually. Now we recently had a meeting with the ISRO chairman and MOE secretary. We requested actually for the two-way communication terminal, especially it's not only for Indian coast actually. It's apart from the other party, it can be able to cover the Himalayan region actually. There, especially Sase require actually snow and avalanche and Himalayan Uttarakhand also. And we are working with ISRO actually looking for the two-way communication terminal for coverage of up to Andaman Islands, in Lakshadweep Islands. Even we are looking up to even further actually Maldives and I think we are looking for I think maybe coming with in the couple of years there is new satellite may come up with a two-way communication terminal. Right now, we are pushing actually Gagan receiver. Actually, now the major challenge we have seen it while distributing these fishermen with these terminals. At the end of the day, they are not utilizing. That is the major we have seen. We have tried actually. I think Professor Menon also aware about the NAVIC receivers were distributed by the ISRO and around 2,000 terminals, but we have not seen any terminal now. That is also major challenge. Somehow we are we now working with a two-way terminal. That is very important when we, the fishermen or even our major boats, merchant navy boats. Totally, we are dependent on other satellites actually. And that's a very major challenge actually. I think what we have seen last 15 years, I have traveled here and there. But major is we have content information available, but the reaching of the last mile connectivity is the major challenge. Especially I've seen that is a major challenge where I feel actually.
Thank you. Dr. Rao, actually, with Amrita University has also been working on this in terms of communication of how we will be able to use, various ways of reaching the information to fishermen in the deep sea. So I'm sure a lot of collaboration is required in technology as well as, institutional collaborations are required. So, in terms of the work which ISRO is doing, and INCOIS is doing along with other collaborating institutions, I think there is a need to really look at strengthening this further. So, Mr. Dijan Bhattarai, now we will come to you in terms of your thoughts in terms of because you are heading the National Emergency Operations Center. You're working with the NEOC. So at the national level, what do you think would be the way in which data and information and warnings could actually then be communicated? We'll come back to you, Dr. Rao.
Thank you, sir. Thank you very much.
Okay, thank you, sir. All we know, a people-centered early warning system necessarily comprises 4 key elements: knowledge of the risks, monitoring, analysis, and forecasting of the hazards, communication or dissemination of alert and warnings, and local capabilities to respond to the warning received. In the context of Nepal, we have followed the Sendai framework. For the implementation of the framework, we have formulated National Action Plan. The Action Plan highlights the multi-hazard early warning system. Similarly, we are making different concept notes in the action plan for the multi-hazard early warning system. However, the major problem lies in knowledge gap regarding the issues. Mostly it is found that risk is either ignored or underestimated. Such a culture of lax is the major issue of the day. Therefore, our job is to work on the issue at every level. We have to do lot of things to sensitize them about risk information. Monitoring and analyze and forecasting of the hazard system is not reliable in the context of Nepal. Lack of data, weak institutional capacity, we are not getting the hazard information properly. Department of Hydrology and Meteorology is doing a lot of things to improve the rain forecasting system, but we have to do a lot of more. Not only DHM, but also various institutions have the same situation. Department of Hydrology and Meteorology has established 51 hydrological and 282 meteorological stations covering across the country and major river basin. This provides the rainfall information for warning to the affected people through the mobile system, and also linked to the BPOT portal. That is our BPOT portal is one portal that is the give us the real-time data and alert information. Nepal is witnessing significant progress in the generation, accuracy, and timeline of early warning of floods in the southern plain. This year alone, 15 million SMS were dispatched to the potential flood-affected locals with the warning message. Communication and dissemination of the alert and warning system is going to set up, but not appropriate and enough. Also, the government of Nepal is about to establish common alert protocol system, but the development of the early warning system is landslides remains a key task. That is a challenge for Nepal government to minimize the loss. Similarly, the awareness and the application of disaster-sensitive development practice remaining the key tasks. In a single sentence, we are still struggling with the traditional home, though we need modern and well-equipped system to work effectively. That's the major gap ahead. And now we are going to impact-based forecasting system is a structural approach for the combined hazard, exposure, and vulnerabilities data to identify risks and the support decision making with the ultimate objectives of the encouraging early action that reduce the damage and loss of the life from the natural hazard. Traditionally, Nepal government have employed hazard focus warning to communicate impending extreme weather condition. However, while providing scientifically accurate information is important, it is critical to communicate what we will need to know to effectively respond to hazard risks.
Mr. Bhattarai, Mr. Bhattarai, can you hear me? Yeah, we will try and come back to you if time permits. Now we have Dr. Sudha Ardikati from Amrita University. She's a professor and also the research head in the Amrita University's School of Sustainable Development. She holds degrees in architecture from Pune University, in city planning from IIT Kharagpur, and urban and regional science PhD from Texas A&M University, with emphasis on environmental planning and hazards management. And yesterday we also listened to her in terms of the work which she has been doing in India, in the US, and the Middle East. So over to you, Dr. Sudha. We'd like to listen to your thoughts and your insights.
So I feel that the government sector is doing their very best, but I somehow in all our conversations, I feel that we are missing out the private sector, especially the sector like the hotels and the motels that need to be used to raise awareness and to raise hazard intrusiveness. So especially for the transient population and the tourists and visitors from other countries, I've been to so many different countries, and I feel that a lot of times the private sector, which is making the profit, they tend to underplay the risks that are there. And so when we visit, we go from one place to another, and as visitors, if we are not aware of the hazards, it can be really detrimental. So I think that sector needs to really come up, and I urge a lot of the disaster scholars and academia to kind of try to do some research, conduct research in that sphere, like trying to inquire about how hotels can increase the awareness. I saw this happening in Thailand after the Indian Ocean tsunami, when I visited after about 2 years, how despite they still make it attractive for you. So that's one thing I would like to underscore. They are thinking that hazard warnings are a bad thing for their land. So we must have some more accessible signages like billboards and posters and things like that on our land. So when I drive around, even though I live in a place that's prone to tsunamis or even cyclones, I have never seen a signage, at least along the coastlines that I've been traveling. It might be in other coastlines, but I think we need to bring hazard awareness and intrusiveness to the people on an everyday basis so that they are aware. So it's very popular in say California in the US, or maybe in some of the Japanese cities. But I think for the other disasters, we tend to underplay it again. So we need to make them aware of that through easy to understand signages. And the last one I would like to talk about is that our universities have the youth that have so much to give back to the communities. And so we need to build up an infrastructure where the youth can participate in disaster resiliency. Recently, in the 2018 floods and 2019 floods of Kerala, they actually volunteered and worked tirelessly in manning a phone station, a phone booth for about 72 hours. And then they even created an app that came out of it. So it's the Amrita Kripa app. So I think if we give the youth, if we enable youth, we empower them through some infrastructure that they are taught about this kind of compassion-driven work, it will go a long way. So just like Yogita's talking about sharing information, geographic information, and just like Dr. Adhikari is talking about sharing between borders and everybody else, I think the youth should also be involved in this sharing of information. So that's what is it from me, from my side. Thanks so much.
Thank you very much. I think, we had an excellent round of inputs from all of you. I'm sorry that, we really do not have much time left because, this is actually something where, we feel that if we can actually create a network of practitioners who are actually interested in making sure that social engineering along with, the structural engineering aspects could work together with technology solutions, if geoinformatics and also IoT sensors and Doppler radars and early warning systems and things like that, we can improve data and have a community of practice if we can actually do that. And if Amrita University can take that initiative of bringing all the state disaster management authorities like the NEMA, the network of emergency management agencies in the US, which is supporting 50 states in the United States, with a national emergency management authority network. If we could actually have a similar thing in India and also in South Asia, Southeast Asia, we will actually be contributing in terms of bringing together some kind of a knowledge portal and knowledge platform of community of practice, practitioners network. We had initiated this dialogue in the UNDRR, trying to create a community practitioners platform when Margareta Wallström was the Undersecretary General and also the head of UNDRR. So that, I'm one of the people who actually is a co-founder of the Community Practitioners Platform, along with the Viro Commission, which is working with Women's Network in 50 countries in Asia, Africa, and Europe, and Central America. We need to have these kind of communities and practitioners network and partnerships, because I believe in the Sustainable Development Goals, the goal 17 on partnerships is most important. I would like to thank all the distinguished experts. And if you have any further thoughts, please use the chat box to keep contributing. And I believe one more thing, which I would like to just mention, because of the knowledge inputs which have been provided by all of you, we need to read a lot more, and I think that is one thought which I would leave with all the research students, who are there from the university, multidisciplinary scholars, because, we need to work together, bring all the disciplines together. In 1936, in the Story of Philosophy, Will Durant wrote this, that the world has changed, knowledge has expanded, and then, we are talking about psychology interpreting every dream and physiology, every organ, and, talked about, architecture and archaeology and, philosophy and social sciences. If you read the forward to the volume, which, or Story of Philosophy by Will Durant, in 1936, he wrote that. And now we are in 2022 with internet, with explosion of knowledge and things like that. And, 8 hours every day we sleep out of 24 hours. And I'm 66-year-old now, and I've spent 22 years of my life sleeping. I would urge all of us to really think and contribute to the knowledge and be uploaders, share knowledge. Thank you very much. Thank you very much for giving me this opportunity to coordinate this session. Thank you.
Thank you.
Thank you. Thank you all the panelists and Professor Menon for such a wonderful session.
Over to the organizers. Please carry on.
Appreciate all for a magnificent session. Now we will going for a second plenary session titled Community Scale Disaster Resilience, Challenges and Opportunities by Dr. Sudha, Professor Amrita School, will be charging in this session. Over to you, Dr. Sudha.
Good evening, good morning, good afternoon, everyone. So I'm Dr. Sudha Arlikati, and as was already introduced in the previous session, I'm a professor and research head in the School for Sustainable Development. So we have 5 presenters this evening. I'll take the Indian Standard Time and speak about it that way. So let's not waste any time. My first presenter today is Professor Deepti Vikramasinghe, Professor in Zoology and Environmental Sciences, University of Colombo, Sri Lanka. Professor Deepti is a professor in zoology, and she has held many key positions in local scientific organizations, including the Sri Lankan Association for the Advancement of Science. She serves in many international expert committees, such as the South Asian Water Partnership, the South Asian Association of Disaster Risk Institute, and the Digital Belt and Road Initiative. Her main research areas are biodiversity, water and wetlands, disaster risk reduction, nature-based solutions, and coastal ecology. She has also won several awards for her research, including the Presidential Award for Excellence in Research at the university and at the national level, and 2 international awards as well. So I welcome Professor Deepti. Professor, you have 15 minutes, and when 2 minutes are left, I'll give you a warning so that we can keep to time and we have some time for discussions. Thank you so much.
Thank you very much, Professor Sudha, and distinguished guest and my colleagues. Greetings from Sri Lanka. Let me share my screen. I hope everybody can see the screen. So thank you very much for the opportunity given to me. This is one of the best topics that I deal with because I love this topic, this research area. So my topic today is nature-based solutions and eco-DRR, that is ecosystem-based disaster risk reduction. And I'm going to talk about key knowledge gaps and challenges for sustainable development. Now, everybody know about sustainable development goals, that we know that there are 17. I would like to highlight that framework of sustainable development goals introduced by the United Nations firmly establishes disaster risk reduction as a core development strategy because it is related to any one of the goals mentioned here. The poverty, zero hunger, good health, quality education. So disasters are linked to them because these are affected by disasters. Now I'm going to talk about the ecosystem approach. So this is to enhance the resilience by promoting and facilitating healthy ecosystems and their services. Having said that, I would now like to explain what nature-based solutions are. As you can see, the nature-based solutions refers to sustainable management of natural ecosystems in order to enhance their services that they provide for the benefit of the community, benefit of us, benefit of human beings, as well as the global biodiversity. In other words, we need to have ecosystems. They should be healthy. They should function smoothly. And if so, we can get their benefits. We can get the services that are being provided by ecosystems for free. Now, what are ecosystems? For the non-ecologist, I would like to explain this a bit. Ecosystem is defined as a community of lives. It could be the microbe, the plants, animals, and they live in concurrence with non-living components, that is water, air, soil, anything which is not living. And these components of ecosystem, the plants, animals, and microbes, they interact with each other. At the same time, they interact with soil, water, air, you name it. That is basically integrating non-living and non-living components. So these ecosystems are basically the habitat of one type which is distributed in a huge area. All of us know what these natural habitats are: the forest, wetlands, estuaries and lagoons, coral reefs, mangroves, everything we consider as ecosystems. And these ecosystems provide 4 types of services which are linked to regulating and maintaining ecosystems, and they increase environmental and community resilience. I have included some photographs from Sri Lanka. This is a big forest reserve we have, and a Ramsar site of this. This is a Maduganga mangrove site, and this is a Batiklo lagoon, which is in the eastern part of Sri Lanka. So as you can see, people might wonder how these the water and plants, how do they provide services? We know that they provide us with timber, flowers, nuts, medicines, but apart from that, they provide many services. And that way, ecosystems provide us with multiple functions. They can regulate extreme weather events such as floods and drought. I will give some examples in my forthcoming slides. And they can reduce the impact or lessen the impacts of tsunami waves. They can act as a buffers to coastal erosion. They can protect soils and surfaces, and in that way they can lessen the hazards of landslides. And they act as a natural barrier in certain places, like in trees and coral reefs, in the edges of the estuaries and in the coastal areas. They act as a natural barrier to stop or to lessen the impacts of tsunami waves and coastal erosion. I have included some photographs of some estuaries and lagoons in Sri Lanka. As you can see, these are the mangroves, right? Now, when they grow up, they become a huge forest. As you can see from here, there are the roots. These roots can act as a live barrier. And this one, this is a little weird, as you can see. These are seagrasses. We actually underestimate their function. These extensive seagrass beds, which are the kind of grasses that we have in the terrestrial environment, these are grasses inundated or they live underwater. These grasses can trap, like in any terrestrial plant, the carbon dioxide from the atmosphere. So they act as a huge carbon sink. Actually, currently we are doing some research in certain lagoons, how these seagrass beds contribute to sequester or store carbon, which is, so if we have healthy seagrasses in our lagoons and coastal areas, they can trap carbon dioxide and lessen or decrease the environmental concentrations of greenhouse gases. Many of you would know in coastal areas or in estuaries, there are these the biological components, different trees, right? These, especially seagrasses, mangroves, they act as nursery grounds for fish. So if you want to have a fishery with lots of harvest, a very good fishery activity, you have to have this kind of habitats alongside the coastal areas and the lagoon. And probably one of the most tangible or one of the most visible impact would be the recreational and potential for leisure provided by these coastal areas, lagoons and estuaries, because these areas which are enriched with a lot of biodiversity, a lot of nice scenery, they attract people for leisure and recreation. At the same time, these are kind of natural laboratories of nature. So they offer very much a huge potential for research. Having explained some services by nature, now I would like to talk about some evidence. Now, worldwide, there are certain evidences are available and they are being increasingly available to show that nature-based solutions can deliver ecological and socio-economic benefits to the local community. Because with those, the services provided by nature, communities can build resilience against impacts of climate change and achieve sustainable development goals. Now, I would like to present some examples from Sri Lanka and elsewhere. Now, this is one of the attractions in Colombo. So I live in Colombo, the capital city of Sri Lanka. The Colombo metropolitan area have been experiencing many floods in the last few decades, and some have been very devastating. And there was a devastating flood in 2010 where several deaths occurred and many millions of economic loss. So the authorities recognize the link between the loss of wetlands and water bodies. And sorry, especially the wetlands in low-lying area. Now, the researchers and authorities, the policymakers have understood that the loss of wetlands can increase flood events, because if you have wetlands, wetland can store water. So if you lose wetlands, the water will be there and there will be inundation. So a new project started, actually it's not new, a decade ago, a new project started to restore Colombo wetlands and develop a canal network which connects these wetlands. At the same time, they develop a wetland park for education, leisure, and recreational activities. So I have put two photos of this wetland park. This is known as Diyasuru Park in Kalawatugoda, Beddagana Wetland Park. As you can see, these are very low-lying areas with mud and wetlands, but they are they are full of biodiversity and the ability to reduce floods because they can store flood water. So in that way, Colombo has become world's, there are 11 wetland cities in the world, according to Ramsar Secretariat. So Ramsar declared Colombo as a wetland city in the world. The other opposite of the water cycle, the drought. So this activity or this practice has been there for many centuries in Sri Lanka. Tank cascade systems to mitigate droughts, especially these are found in the dry area. These are known as in local language Ilangava. So this what Ilangava is, the principal theory behind this is recycling and reuse of water as a network. There's a small to large tank system. As you can see from here, there's a huge tank over here, which are connected by waterways to small tanks. So it acts as a huge wetland because of this connection. So in the middle, there are paddy fields, villages, other storage tanks, upper canals, forest, right? So because of this topography and this system, the entire area which I have, which is demarcated in the color, the soil is saturated with water. Even during the drought period, even this wherever they lose a lot of water, the soil is saturated, and because of this wherever, tanks and reservoirs and their connectedness from this tank, even the smallest tank over there gets water. In the middle, they will nourish soil moisture. So, so the dry zone, which has a little less rainfall, and they get sustained with water because of Ilangava or tank cascade system. And at the same time, so as you can see, it reduces the impacts of drought by providing water. At the same time, during the rainy season, they act as a storage for flood waters, right? So, and then they increase community resilience because they provide water for their livelihoods, because they basically farmers are the people who live there. So they can ensure continuous cultivation. Now, I would like to move to my friends, our neighbors, India. I never visited this, but I have read, and I'm very much happy to present this Nagavan scheme. So the Indian government the authorities have used nature-based solutions to plant urban forest in Chennai. I've never seen this, but I know you guys, our friends, colleagues, you might have seen this. They are Miyawaki forest, where the communities get together to create urban forest, which has a lot of functions, which has a lot of, which gives many ecosystem services, including this wilderness, the cleanness, the greenness, clean air, reduced temperature, accommodation of biodiversity, retention and conservation of water and soil. So all of these given by the nature-based solutions of this urban forest. And if somebody has seen it, I would like to share this experience. I learned from them Naga Ban scheme, which has started in 2020. So in Bhutan, another neighbor, what they do is there's a community forestry as a part of watershed management.
Dr. Deepti, we are at 1 minute. Thank you.
So, so these are some examples, and I would like to talk about some knowledge gaps, but even though these are there, we don't know about this. We have poor knowledge of the ecosystems. And there are no suitable indicators and metrics or metrices to measure. So we don't know. So whether they decrease carbon emission, whether they clean air, we don't know. So we have to have some indicators. And we don't have at the moment evaluation and assessment system. And basically, we have a poor understanding of co-benefits. For instance, like the urban forest that I talked about, the urban forest gives some opportunities for leisure activities and accommodate biodiversity. At the same time, they store carbon dioxide. They store carbon, so they reduce the impacts of climate change. So we don't know about the co-benefits. And basically, people lack of awareness. The general public are not aware how to conserve the watershed or conservation in a river. And this is again from India. And sometimes we can't see the impacts. Nature-based solutions are intangible, effects not obvious. People are basically, they love to have rather than a mangrove forest, a revetment or a stone ridge embankment to stop coastal erosion. And as a way forward, what I would like to suggest is to close the gaps. We have to have conservation actions, integrating science that we know of into policy. We have to invite policymakers and share this knowledge. Exchange our experience and speeds. That is what we are doing here right now. Monitoring of these programs, awareness raising, and involvement of all stakeholders, including the communities. So there's nature's free service to reduce impacts of climate change, disaster risk, hunger, biodiversity, which are related to sustainable development goals, and increase safety, resilience, and equity. So this is, at the end, I would like to extend my sincere thanks to the audience. Thank you very much.
Thank you, Professor Deepti. What a beautiful presentation and bringing home the importance of nature-based solutions. So we leave some of the questions to the end. Thank you very much. I invite the next speaker. And before that, I wanted to just shout out to my volunteers. I have 2 volunteers. You can't do anything without your student volunteers. They're working on their PhD. So I have Mushtaba, if you will please turn your video on. And I have Isaac. Both of them are working on their PhD in sustainable development. Great students. Behind all that you're seeing is hard work by a lot of our student volunteers. So a big shout out and a big hand to them. Thank you, Dr. Deepti, very much. And now I call the next presenter, please, Sri Sunil Jayavira. He's the Director of Preparedness and Planning Disaster Management Center, Sri Lanka. He has been actively involved in the preparation of national disaster management plans, and he also has over 30 years of experience in the fields of mapping, landslide risk management, human settlements and planning, and environmental quality management. Further, he has gained significant exposure in the field of tsunami early warning systems and was instrumental in successfully organizing an international hybrid symposium on multi-hazard early warning systems and disaster risk reduction. He is also a member of the Population Association of Sri Lanka, a corporate member of the Institute of Town Planning of Sri Lanka, a committee member of Sri Lankan Women's Partnership, and an expert member in EIA and SIA studies in Sri Lanka. So after having Professor Deepti from Sri Lanka, now we have Sri Sunil Jayavira, also from Sri Lanka, sharing his immense experiences in community work. So over to you, sir. Hello.
Hello.
Yes. Yes, sir. Please go ahead.
Good evening, ladies and gentlemen. On behalf of the Disaster Management Center, I wish to thank the main organizer of this event, Symposium, for inviting me as a speaker for 2020 Symposium. Going to my presentation, the Sri Lanka is a country, as a small country. The main capital city is the Jawaharlal, and land area of the 65,610 square kilometers. Population nearly more than 22 million. Disasters characters in Sri Lanka. Topographic and difference in region climate are moving cause the contrast in many effects of the island. Most frequently natural hazards that affect Sri Lanka are drought, flood, landslides, cyclone, and coastal erosion. Tsunami infrequent but have caused severe damage in Sri Lanka. Strong tendency towards drought in the southeastern districts and the northeastern region. Flood hazards indicate high risk in the western, southeastern, northern, northeastern, and eastern parts. 8 districts out of 25 districts in the Central Highlands are at risk for the landslides. Majority of cyclone and storm pass through the northern and northeastern parts. Risk profile disaster as a risk index. OCHA published in 2017, still tsunami having great risk, 8.2, and second in the floods. The Indian Ocean tsunami, most significant disaster in Sri Lanka on 26 December 2004, due to lack of proper mechanism, disaster management mechanism established in Sri Lanka. Due to that reason, a number of deaths 30,959 and number of missing 5,644, and number of displaced more than 500,000. After that, disaster management established in Sri Lanka based on the Parliament selected Committee on Natural Disaster. After that, Disaster Management Act number 13 and 2005 established, provide the framework of disaster risk management in Sri Lanka, and this address disaster management holistically, leading to the policy shift from response-based mechanism to the proactive approach. The Disaster Management Center was established in August 2005 under the National Council for Disaster Management. After that, the National Disaster Management Policy established, and thereafter there are other guidelines and regulation review, and presently National Disaster Management Plan review based on the Sendai framework. This is the organization overview, state structure and disaster management Sri Lanka. National Council for Disaster Management, under that Disaster Management Division. Under Disaster Management Division, there are 4 institutions: Disaster Management Center, National Disaster Relief Service Center, National Building Research Organization, and Department of Meteorology. Institutional structure disaster management. The chairperson is the president, vice president the honorable prime minister, leader of the opposition, and 9 provincial chief ministers and 5 MPs opposition. And there are so many government institutions in the Disaster Management Council. Under the ministry, it directly connects to the Disaster Management Center. This is the subnational disaster management mechanism. District Secretary is the head of the disaster management coordination, and in line with all the district disaster management related agencies are involved in the disaster management subnational framework. And village volunteer groups, under the village volunteer groups, there are village warning subgroups, medical health subgroups, search and rescue subgroup, coordination subgroup, and village task force. Disaster Management Center is the head office control the 25 districts in Sri Lanka. Emergency hotlines the 117, 24 hours operate in Disaster Management Head Office, Emergency Operation Unit, and 117. To achieve the disaster management objective of the disaster management mechanism, Disaster Management Center, Director General, the head of the divisions, and additional Director General, and there are 4 technical divisions: preparedness planning, disaster mitigation, training, and emergency operation unit. And under this 25 district disaster management coordinating unit at district level. We have established a multi-hazard warning system, hazard different areas: meteorological forecast, floods, weather-induced forest fire, drought, weather-induced health impact, winds and storm surge, and snowfall. And the threshold level of the different hazards in Sri Lanka, that we have a early warning message based on the 5 stages. First, in the alert, warning, evacuation order, withdrawal, and stand down. All are based on the hazard. The tsunami, the lowest boundary can be identified as the time at which the earthquake occurs, at the threshold level. Flood, time at which the water level reached the flood level on river or reservoir, declared by relevant, identify the technical agency. Likewise, hazardous and threshold level, different hazards. Receiving the technical information from various agencies. Let's cite the international agency. We receive the information from Pacific Tsunami Warning Center, United States Geological Survey, Global Disaster Alert and Coordination Service, INCO's Indian National Center for Ocean Information Service, Regional Integrated Multi-Hazard Early Warning Service, Australian Meteorological Service, Japanese Meteorological Service, and local level early warning centers we receive for the disaster Department of Meteorology, Department of Irrigation, Geological Survey and Mine Brewery, National Building Research Organization. Together with all the information analyzed and pass the message to the community from the Disaster Management Center. And each technical agencies responsible issuing early warning in Sri Lanka. Department of Meteorology, responsible cyclone, floods, tsunami, storm surge, drought, and lightning. Department of Irrigation, responsible floods and drought. National Building Research Organization, landslides. Geological Survey and Mine Bureaus, responsible earthquakes. Coast Conservation and Coastal Resources Management Department, Oil Spill, Marine Environment Protection Authority, Maritime Hazardous. All the information received to the Disaster Management Center. Disaster Management Center pass the message to the last mile community. And all the multi-hazard early warning dissemination system in Sri Lanka. We received the earlier I mentioned international organization and technical agency, and all the information we receive the Disaster Management Center, and Disaster Management Center pass the message to the through the technical agencies and stakeholder agencies through the established mechanism to the community. And also the media roles the key roles of the dissemination early warning. And also the police and tribe forces. When you receive the early message to the Disaster Management Center, we pass the media agencies pass the message to the vulnerable community, as well as military and police receive the disaster information, and they also pass they are using their mechanism to the vulnerable communities. And the early warning dissemination methods currently adopted in Sri Lanka. This is the national level and district level. We have seven early warning towers established in the coastal area, especially in the tsunami early warning, police and military communication, cell card system, intra-governmental network, satellite and radio communication, telephones, police and military communication system, and media. These are the national level as well as village level. We have a separate system: telephone, police vehicle, NGO and community-based organization, PS system, media, and traditional and religious methods, and early warning committee, especially in the community level. This is the mechanism to pass the message to the community level. We receive the community level police, they pass the message to the sirens and loudspeaker to the community, and Grama Niladhari, the head of the community, and they pass the message that they are through the village development community, sport community, disaster management community, other community established in grassroots level, and also the local fisheries pass the message for the fisheries community through their communication methods. This is the mechanism, coordination and regulation mechanism for tsunami, early warning and evacuation process last man. This is the communication at national level, district level, divisional level and local level. Really mention the path of the communication system and also the political authority, how they pass the message to the local community. This is the slide more elaborate in the message I discussed in last slide. Establish last mile communication method and early warning. We have a communication method developed with the other stakeholders, district, police, media, technical agency, district, community, and other transfer the information other pass the community. This is the early warning equipment used at the local level, especially the megaphone, PS system, electric sirens, manual sirens. These sirens have been distributed among the military, police and CBO and VDMC, etc. And also we use the traditional methods, electric and manual sirens at the community level. The other one import is in the National Emergency Operation Plan. That is a cabinet approval document. National Emergency Plan provides stakeholder agencies role and responsibility just before, during, and just after disaster and standing order operation procedures. Other than the National Tsunami Warning Center, Sri Lanka Disaster Department of Meteorology is the responsible agency. Their main function of the meteorology department, monitoring earthquake signal, receive and analysis TSP's message, estimate earthquake parameter, location, magnitude, depth, etc. Provide timely information to the disaster management center and general public according to the standard operation procedure. We prepare the SOP for different disasters, especially the tsunami, landslide, flood, and cyclone. And all the irrigation department, early warning mechanism. They are presently responsible for the flood management and forecasting, flood monitoring system, manual, semi-automated system, hydrometeorological information system, rivernet Varisava system. And also we conduct the International Symposium in 2020, that's the virtual conference launched in Colombo, that is we create the great awareness, local, national and international. And also this year we celebrate the International Day for Risk Reduction. Theme was early warning and early action for all, leave no one behind. And also the we plan to conduct the World Tsunami Awareness Day 5th November. For that, we plan to conduct the great awareness in the Eastern Province this week. With that, I conclude my presentation. Thank you very much.
Perfect timing, sir. Thank you so much for explaining to us about how you conducted in Sri Lanka. And I was fascinated to see that you receive early warnings from so many different countries. So you cross-check and so on. So I'll leave the questions for later and we'll move to the next speaker. So our next speaker is Dr. Giuseppe Formetta. He's an associate working on areas such as multi-hazard impact assessment in the alpine regions, the influence of bedrock structures, variability on the hill slope, hydrology and stability, and analysis of blue-green infrastructure for more sustainable urban drainage. Dr. Formetta is an experienced researcher in the water cycle, hydrology, hydrological modeling, and data analysis. During his 2 postdoctoral degrees, he was involved in developing models for landslide trigger, understanding, and prediction. He is also experienced in hydrological model development, flood forecasting, flood frequency analysis, assessing spatiotemporal changes of flood and drought hazards, and multi-hazard risk assessment at the global scale. We are especially excited to have him here because he is going to be mentoring some of our students. So welcome, Professor, and the floor is yours now.
Good afternoon to everyone, and thank you very much for the introduction, Professor Sudha, and also thank you very much to all the organizers and the support students that helped me out on setting up all the environment here on the platform. So I am delighted to be part of this workshop, and today what I'm going to talk about is assessing multi-hazard vulnerability at global scale. And first of all, why vulnerability? Because it is one essential component of the well-known risk equation, which also account for the hazard, of course, and for the exposure. What I'm going to show you today is a little bit a zoom out idea of, in terms of scale, spatial scale, because I'm going to speak about global or European scale. And this is the outline of my presentation. First of all, I would like to speak a little bit about some trends in reported multi-hazard impact during the last 38 years. Then I will move on the assessment of the multi-hazard vulnerability and its change in time, also in at the global scale and clustered by income of the country, let's say. And finally, I will try to give a short idea of what we are working on in quantifying the impacts. And so, for example, the the fatalities, the amount of people killed by heat waves, for example, or the gross domestic product damaged by natural hazard. And finally, I will move to some conclusion. So here is the first slide, in which I wanted to just point out that impact of natural hazard are increasing all over the world. First of all, are increasing at local scale, of course. And this is, for example, on the right-hand side, you can find my hometown, which is situated in the south part of Italy, where 200 millimeters of rainfall in 5 hours caused a lot of floods, coastal floods, and a shallow landslide, as you can see here. But if we move to the global scale, here we can see from the data that comes from the NatCast service of Munich Re, which is an insurance company, of several hazards like floods, flash floods, coastal floods, cold-related and heatwave-related impact, droughts, and wind. On the first column, you can see the number of reported events. So here in the first column, I show that the number of reported events is increasing during time. On the central column, you can see instead the fatality per years from 1980 to 2010 that have been reported and have been caused by the single hazards. And finally, on the last column, on the third column, you can see the reported damages in billions of US dollars. And if someone may discuss that the increasing number of reported events may be explained by the because we are better in reporting these kind of extreme events, it's clear that there is a trend significance for most of all the hazards we analyzed, which is strictly increasing and also statistically significant. And therefore, this motivated us to go deeper in the vulnerability of extreme natural hazards. And therefore, this is the methods that we used. So we linked a dynamic exposure procedure together with the reported impacts that I just showed in the previous slides, and in order to build a time-varying multi-hazard vulnerability for each hazard. As a dynamic exposure, here you can see that we used global maps of populations, so time-varying population from 1980s to 2016 for assessing the social vulnerabilities. And also the GDP maps in raster maps, time-varying themselves from 1980 to 2016, to assess the potential damages of the natural hazard. And then we combined this framework with the reported impact to compute the ratio between the people killed, so the impacts, for example, and the exposed populations, or the damage, the economic damage, and the exposed GDP for each country, let's say. Those are the hazards that we analyzed, and in particular, you can see that there are all the the main hydrogeological hazards: river floods, coastal floods, flash floods, cold wave and heat wave, droughts, and windstorm events. And from the dataset of the insurance, we get the disaster type, the position of the result, and the impacts, fatalities, and damages. So for each year, we were able to provide the total exposure in terms of population and GDP, how according a circle around our points in which the disaster was associated with. And so we also provide a sensitivity analysis of that circle in order to understand that for certain hazard like flash floods, we consider lower radius of the circle, for example. And for widespread events like droughts, we consider a large radius. Of course, for floods, we also mask these population and GDP maps, accounting for the inundated area that are available from global inundation model. And then we quantify, therefore, the mortality rate and the loss rate. And finally, I'm going to present the result aggregated per country, aggregated per income class of the country, and per type of hazard, which are these one that I present on the left-hand side of the presentation. Here is the first result, in which we show the fatalities as a percentage of exposed populations. And we provide it for different radius, as I was mentioning before. Why? Because some radius, for example, a lower one, like 50 kilometers, are better for risks such as local risk, like flash floods or convective windstorm. Other radius may be more appropriate for widespread events. And here you can see the vulnerability in black for worldwide, and in red and blue for low, middle, low income countries, and for high, middle, high income countries, across all the type of hazard that you can see by row. And here you can see that we analyze all hazards together and then separate single hazard. There is the main conclusion, the take-home message is that there is an evidence of a decrease of almost 6 times of the mortality rates across different hazards between the period 1989 compared to the period 2007-2016, which may be interpreted as a good news, but is not the entire picture. In fact, we have still 5 times gap between low-income countries. Moreover, those studies are very high scale, global scale, so it is important to move towards local scale risk analysis. But for now, they provide good insight for the global trends. And here as well, I show you the evolution or the relationship between the fatalities as reported as a percentage of exposed population and the GDP per capita. And also here there is a clear decreasing of this. But we have still to improve and provide more and more attention to local hazard and risk assessment, as previous speakers before me put in evidence in their very detailed and nice talk. Finally, I want to move to the second part of the presentation, where I show you how we are trying to model the impacts caused by 2 particular hazard. First of all, heat wave hazard, where we try to estimate through a Bayesian model the logarithm of the fatalities explained, of the reported fatalities generated by heat waves, explained as a combination of hazard, as exposure, and as a vulnerability. We separate the vulnerability in social vulnerability, and we account for the Human Development Index to account for it, and health vulnerability, because of course old age or very young people are more vulnerable to this kind of hazard. The exposure is the same that I used before, therefore time varying map of population. Here is an example of Italy, but we are running this application all over Europe. And here is the intensity of the heat waves, which is in this case computed as HWMID, which is the heat wave magnitude index daily. We are also trying to investigate how those impacts will vary and where in the future. We calibrate the model on the available data, performing quite good agreement between predicted fatalities and reported fatalities. And also in validation of the model, we used a 3-fold cross-validation to assess the robustness of the estimated model parameters. Finally, we are doing more or less the same things for the wind, so intersecting intensity of the wind velocity, and exposed GDP. And in this case, we were trying to estimate the reported damage. given the wind velocity, and as a product of the wind velocity to an exponent and the GDP exposed to another exponent. Those two parameters are fitted through the reported damages using a Bayesian model. And here you can see very preliminary results that we are going to finalize, I hope, any soon. Then let's move to the conclusions of the talk, and in particular, I want to put in evidence that we applied a global spatial explicit framework that integrates dynamic population and economic GDP through the time with one of the most completed natural disaster database. This has been used to quantify mortality and loss rates across all different countries, and the result from one side show a decreasing trend in reported impact during the last 38 years. But this should motivate us to do even better and to improve our abilities to face through multi-hazard, especially because there is a need of moving from global scale to local scale. And here you can see some events that occurred very locally here, for example, in my region in Italy, where windstorm or severe drought events are hitting our regions. And so this study was really to motivate to do better and improve, both from a point of view of data collection and from a point of view of modeling. Thank you very much for your attention. And
thank you so much,
yes.
Dr. Giuseppe. That was great. Very good presentation. I am really fascinated by you making sure that it's not just that we are better at reporting, but in fact, actually our weather patterns have changed and we are more susceptible. But I'll wrap up later. So we'll go to the next presenter, and it is my greatest honor to invite Dr. Yogita Shukla, founder and CEO at Geo Foundation India. And she's also the founder of Women Geospatial Coterie, expert faculty in remote sensing and environment at the Dronacharya Group of Institutions, and advisor to a few geospatial and natural resource management organizations. She has over 24 years of experience focusing on climate change, natural resource management, rural and urban development, and energy management. Her scientific research focuses on understanding the impact of climate variability at high altitudes, the Himalayas above 3,000 meters, using geospatial techniques. She's also working closely with government departments and ministries for the adoption of these technologies in national development programs. So it's my pleasure to welcome Dr. Yogita. Over to you, please.
Thank you so much for the introduction, and also for giving me the opportunity to present my work at this forum. So as suggested, I work on high altitude Himalayan region, and from there only I realized that just being a scientific researcher or a scientist won't suffice in current times. Have to move beyond being a scientist or a researcher and take whatever knowledge, understanding which we gather from our scientific analysis and results to communities and to a wider audience. And that's how I started this foundation at Geo, where we it means that adding earth to all our concerns, adding geospatial to all our concerns, and putting focus on earth systems. So geo basically is earth systems, so putting our focus on the earth systems. And so today I will be talking about how geospatial technologies they can help at building resilience in a climate uncertain future. And this is what I'm talking about. So as I said, that earth systems is where we have to focus, and geospatial technology, both these entities are mutually exclusive to each other, and they both strengthen each other. So Earth systems, as I said, that they are mutually collaborative functionality. It means that it is not in silos. The biosphere, the hydrosphere, the cryosphere, whatever spheres we talk about, and even the human sphere, anthrosphere, all these are connected, mutually interactive, and they are not disconnected systems. And
sorry to
hello?
interrupt. We are not able to see your slides.
But
Do you want
okay.
to share?
Yeah. I thought that it's here being shared, so that's why
Okay.
I'm seeing it here.
Yeah, now we are sharing it.
Now we can see it. Sorry, Yogita. I thought some speakers prefer to just speak.
Yeah.
So that's why I didn't interrupt you. But and also, if I could just have you adjust your camera a little bit so we can see your whole face.
So
Thank
now
you.
it's okay?
Oh, better. Thank you so much. Appreciate it. Yes.
So and geospatial, what geospatial bring is it brings to fore the interesting interlinked linkages in between these Earth systems, between these spheres. So that's why geospatial is very inherent and key to understand Earth systems and bring to fore the Earth system intelligence. So as I said, that geointelligence or the spatial intelligence, it brings the Earth's inherent intelligence to the fore. So whatever connections, whatever network are between the plants, the animals, the hydrology, the biosphere, all the biotic and abiotic components which are connected. So it's all a connected system, and geospatial intelligence, it brings that intelligence to the fore. And as I said that, the oceans, the land resources, all that information, it is built one overlaid over each other, and the analytics. So right now, like we all are exposed to Google Earth, we are all exposed to the visuals and view and query aspect of geospatial and GIS, but what we really don't have got to the depth is of the spatial analytics, because spatial analytics is where we can bring all this information into one. And as I always talk about this thing, that in the data and information systems, we have the whole journey from data to knowledge, and from data to information to knowledge to wisdom. And in that journey, the wisdom comes from where, because everything what we do, whatever happens on the planet, the where component, the spatial component is so intrinsic to it. So, and then the topic is like what we are focusing on is building climate resilience. So how do we build the climate resilience is there are two major aspects of building climate resilience is mitigating and adapting. So mitigating means we have to reduce, we have to refuse, we have to do a lot of things, understanding our ecosystems. We have to do a lot of things to restore our ecosystems. And adaptation is to whatever changes we have, whatever I have, we have to engineer it in such a way that we are able to live in the times where the climate uncertainties have become a new normal. So so what information do we need, like for the mitigation, for the adaptation, we need the information on how we are protecting our forest lands, how the land use changes are happening, how we are allocating land from one land use to another land use, what are the infrastructure development which are happening, and how we can build a design which is sustainable, which is green, not just in word, but actually in action and in practice. And mitigation is by being more energy efficient, switching over to renewable energy, use of common lands, use of having a collective common goal. So all these information sets, are basically we derive it from geospatial information, like what are the changes in land use, relocation, what are the emergency and business continuity planning that needs to be done in terms of the changing environment. Similarly, for mitigation measures, all the information, it's the geospatial which is the key to building all these information sets. So as I said, that geospatial information is integration of a lot of other technologies also, like artificial intelligence, machine learning, and information from sensors and IoT. So spatial information over a period of time, it builds an intelligence, and that intelligence is built through AI and machine learning, because whatever information we get from Earth observation, satellites, they are all in the form of images. And these images in an AI and ML environment give us a kind of trajectory of how the land use changes happen, how the forest cover changes have happened, how the energy exchange, the changes between energy exchanges happen, because again, Earth observation, it captures the reflected energy from the Earth's surface. So we can also track the changes in albedo and how these albedo changes are impacting the climatic setup of that particular region. So from understanding, so from being a science, from being a scientific discipline where you bring the understanding of environment, you integrate it with geospatial information, and with on an IT platform, on an IT backed systems, we deliver science from understanding to solutions, which are very helpful in our decision making, because all our decision making comes, the root is from our scientific understanding and our scientific knowledge. So rather than putting our scientific knowledge or an understanding as a paper or as a report, building such an information infrastructure where this scientific understanding is delivered as decision-making solution is what we are focusing on to. And this is what we are building now. We'll be starting with the Western Himalayas, because that's where I started my scientific research. The dream is to take it forward to the entire Himalayan range, because as I said that we have the borders created in terms of countries, in terms of state, but nature, there is not much boundary. So we have to treat, whenever we are talking about such a knowledge and information infrastructure, especially with respect to climate resilience, adaptation, and mitigation, we have to focus on from an eco-region perspective, because the entire climatic setup of one eco-region corresponds to that particular geography, that particular biosphere, that particular hydrosphere, geosphere. So all the interactive systems of that particular geography builds the entire climatic setup of that region. And when we have to deal with in terms of when we have to build those climate resilience strategies, and we have to build those climate resilience practices, an information infrastructure which is siloed won't help. So this is, we are creating a data and information infrastructure where the geospatial change from an analysis ready Earth observation, we are looking into decision ready information, as I said, the decision making solutions. And the key principles for the development of these indices would be findability, accessibility, interoperability, and reusability, which is acronymed as FAIR principles. And as I said that we started from high altitude regions of Uttarakhand, and this is the decadal changes which have been observed in the Uttarakhand region. So the snow cover changes and the vegetation cover changes for the 2 seasons, which is the maximum snow and the minimum snow, it was observed. And we have been doing this, and we have found that there's a profound reduction in the snow cover. And these are the changes which we have seen in the high altitude regions, where the snow cover, majority of snow cover, it has been converted into rocky barren islands, and in some areas we are also seeing dry alpine scrubs coming up in these regions. So these are the decadal changes from one, because observations of such changes on a scale at the climatic scales, we have to look into years. And so between 2 years, like from 72 to 79, which was like 7-8 years, and then from 2002 to 2013, when we compared, the changes were very much profound. In 2002 to 2013, there was very drastic reduction. And for each, then we did the special analytics for each altitudinal zone. So we divided the altitudinal zones based on the geography. So the tree line is 3,000 meters. The tree line stops, and around 4,000 meters, the snow lines is there. So we have seen a shift from tree line of 3,000 to 3,500 meters to, it has moved to 3,500 to 4,000 meters, and the snow line has also shifted something about 500 to 800 meters upwards. And this has a very significant ramification on the climatic setup of that particular region. And similar studies other than mine have also reiterated this fact. So now what we are doing is that all this analysis, we are creating vulnerability indices for the ecosystem vulnerability, hydrological vulnerability, geological vulnerability, even livelihood vulnerability, because there are a lot of communities which are, where their livelihoods are dependent on those ecosystems. So all these vulnerability indices we are developing, and these, based on these indices, we would be giving decision-making solution as to how, if there's an infrastructure development which is going to happen, or a plan there, these, based on these vulnerability indices, we can say that that infrastructure development, what would be the stability, the structural stability of that infrastructure development in that particular region, and what would be the sustainability of that infrastructure over a long period of time. So similar indices we are also developing for the disaster risk reduction, for predictive agriculture systems, for predictive developmental scenarios, and this all would be done with the support from the communities, from the grounds people over there, the information capture.
Dr. Yogita, you have 1 minute.
Yeah.
Thank you.
Okay. So, and this is also based on the framework of the United Nations Global Geospatial Information Management Framework of how the data, the innovation, the standards, the governments, the policy coming together to develop such an information infrastructure. And as I said, that the major aim for this infrastructure, and we can call it an SDI, but it's a regional SDI rather than a national SDI, to deliver science as a solutions. And so these are the timelines which we are following. It's almost been 2 to 4 years. We are working on the data sets, Landsat data 2002 till date. We are processing it and creating decision-ready information, Sentinel data from 2016. And also we are collaborating with other institutions like Wadia Institute of Himalayan Geology, Indian Institute of Remote Sensing, Sidho Kanu Murmu University, KG Sumaya College of Engineering, Uttarakhand Open University, GISC Hub, IIT Mumbai, and my own organization, Women Geospatial Poetry, because we plan to bring more and more women from the science side, also from the STEM side also, to build this system. And also from the community, the engagement, the focus would be on gender parity and a lot of inclusion of women in decision making for delivering this information infrastructure. Thank you so much.
Thank you so much, Dr. Yogita. It's amazing the kind of work you're doing, and especially my interest to speak at the end when you talked about gender parity and bringing more institutions. And so we will definitely get in touch with you. So thank you. We'll keep the questions for the end. May I ask the next speaker? And this is my honor and privilege to invite my very own dean and also the provost, Dr. Manisha V. Ramesh. She is the Provost of Strategic Initiatives, Research and Innovation, Dean of the Amrita School for Sustainable Development, and the Director of the Amrita Center for Wireless Networks and Applications. She's also the UNESCO Chair on Experiential Learning for Sustainable Innovation and Development. And in a subject-wise analysis carried out by Stanford University in the US, she has been cited as among the top 2% of scientists in the world based on the publication list available on Scopus. She has more than 160 publications and 50 patents to her credit. I've seen her working, and I know she is one of the most hardworking people I've ever met, and it's my pleasure to have her speak at this forum. Over to you, Professor.
Thank you, Dr. Sudha. Thank you for the organizers also. I hope I will be able to do a justice. And if I am overshooting the time, you can just alert.
Yes, I'll let you know. Thank you.
So good evening, everybody. I come from the University Amrita Vidyapeetham, which is initiated by the world-renowned humanitarian Sri Mata Amritanandamayi Devi, with the objective of providing education for life and education for living and compassion-driven research to solve the global challenges. So let us see how we are working on the multi-hazard areas. I would bring in the multi-hazards, the identification, risk assessment, and resilience factors. These are the contributors in this particular presentation. Mr. Nitin Kumar is the Senior Research Associate in our landslide team and also a PhD student. Ms. Harichandana is also the Research Associate in the Amrita Center for Wireless Networks and Applications, and she is also the PhD student. Both of them, Nitin is working on resilience as his area for the PhD, and Harichandana is working on multi-hazards as her area. So in the multi-hazard early warning and resilience system, where we are looking into in four pieces actually. One, I am looking into the multi-hazards, quickly about the definition or classification and frameworks, etc. is the largest perspective people look into it. In risk assessment, people look into vulnerability assessment, risk classification, spatial impact, and then also the experts look into community resilience and their factors and the status and the solutions and interventions through in situ systems, remote systems, remote sensing, crowdsourced application, etc. Because of time limitation, I may not be bringing everything. I will try to bring in some case studies where we can see these integrations. So if you look at multi-hazard cascades, I am just taking one scenario where if you are looking at geophysical and hydrometeorological cases, in geophysical, if you see that, seismicity can lead to earthquake, which can lead to tsunami, and a tsunami can lead to a landslide, which can also be initiated because of an anthropogenic activity. If you look at the right-hand side, the hydrometeorological cases, a climate change can lead to extreme rainfall or blow-off, and they both can cause a flood. And the flood can cause landslide, and landslide can cause flood. So they are all interrelated. All these different activities are interrelated, which is impacting on the community. So we will need to actually work on the infrastructure side, the livelihood side, and lives of the community to build the resilience. Let me just dive deep into a single event called landslide, where in the landslide itself, if you have, the classification of landslides have multiple types of landslides like slides, topple, etc. And when you are working in that area, you need to understand what are the key sub-events which is causing a particular type of landslide. So that's where the identification of sub-events of landslide is very important for us. And there you have, based on that, you will be saying whether it is a deep-seated or a shallow or a mud flow or a creep, etc. Now, when you identify the sub-events, now to understand the risk in it, we have to map the interrelationship between the sub-events, where we are looking at the extreme rainfall leading into infiltration, to leading into percussion, leading into deep-seated landslides. And once you have the understanding of interrelationship, you go into the exposure analysis, where you identify the elements at risk, whether in each of those areas, the roads, bridges, etc., its proximity, etc. And then based on that, come up with the vulnerability, where estimating the possible losses incurred during the exposure, the physical vulnerability or social or economic, etc. And thus coming up with the multi-hazard risk curve, drawing the resilience curve, so that we will quantify the risk and move forward. Let us see that in each of these types, how we have gone forward. So in the landslide type, just to give you an example of a rock slide and a debris slide, if you see in the fourth column, you can see the sequence of sub-events. So each of your events or each of your hazard, you have to understand what are the sequence of sub-events. And based on the sequence of sub-events, you have to come up with the measurement techniques. So I am just going to discuss about the Amrita's IoT system for landslide monitoring, detection, and early warning, which is deployed in Western Ghats and Himalayas with more than 300 plus sensors, which is continuously and collecting the data, and real-time monitoring and detection and early warning is happening. And this, while building this system to understand the sub-events of the landslides and to measure those things, we have actually used the geoscientific inspections, electrical resistivity-based tomography, and geotechnical laboratory to understand those parameters. And then we also have integrated a multi-layer heterogeneous sensing, which went up to a depth of more than 33 meters with heterogeneous sensors. You can see that on the side on the left as the top view of nested piezometers, which gives you the measurement at multiple layers of the soil. And this will help us, this heterogeneous sensors will help us to identify the sub-events which we had seen in the previous slide. And then based on that, and plus the continuous monitoring of the different events, where you can see rainfall, pore pressure, moisture, microseismic, and movement. These will be continuous monitored and try to understand the interrelationship between them. So here I'm giving an example of an interrelationship where you see that rainfall, which is in the blue color, is just increasing in the year 2013, but the yellow color, pore pressure, is just stand still for some period, and then at some point it drastically increases, and then the landslide event is happening. So it is very important for us to map the interrelationship, so that when will the event happen, that is very important for us to know, so that the elements at risk can be identified and they can be notified, so that we will be able to take care of the resilience factor. Now, if you look at Chanthamari, this is an image of the Chanthamari area. These are the elements which are in the site Chanthamari, Sikkim. You can see how heavily populated in this area. If a landslide happens, what would be the impact on this area and what is the exposure? Now, how do you capture this? Because the landslide is a very highly spatial thing. So to capture the spatio-temporal tracking, we have built a landslide tracker app as part of landslide project, where the community members itself actually map the elements at risk, the landslide events, which will give you also the history of events, etc. And this will help us to understand the trigger, develop early warning, and then initiate the rescue. So this helps you to bring in the elements of risk into it, and also through that, you are able to also integrating that data with the sensor data. Here on the right-hand side, what you are seeing is an inclinometer data, which gives you the data in 2019 in the blue color. In 2020, the inclinometer shows that it is in the green color. That means that much displacement happened. The slope has been moved that much. So you are able to get the rate of movement and how much it is moving, at what depth this movement is happening. So you see here at 16-meter depth, this is happening. So if a landslide initiates, the whole earth surface above 16 meters is going to slide. So the integration of the crowdsourced mobile app with the elements of risk plus the sensor data is going to give you what is the vulnerability they are going to actually, what is the exposure, which are the elements which are going to get affected due to this. And based on that, the stakeholders or the administration can take the mitigation activities. So when you have these data, it is fed into a multi-hazard monitoring and early warning systems decision support model, which will give you the community level multi-hazard risk assessment, and which will also utilize the factors which are coming from India Meteorological Department, and take the air forecast also, and use that also to forecast what is the events that is going to happen, imminent events that will happen. So this will help us also to get into the knowledge of the risk and the exposure which you are looking. So based on that, you can build the resilience ahead of time and save. So for this, we have also built a parameter specific threshold models for regional scale, site specific, and also AI ML approaches for forecasting multiple parameters. So what we have used is IMDs is weather forecast has been taken. Based on that, we have actually built the pore pressure models, which simulated the pore pressure models, and based on that, slope stability has been simulated, which you will get 24 hours ahead, so that the administrators can take the action required. And these all has been combined together into a multi-scale, multi-level warning dimension with a 4-level warning system, which will give you automatic warning. And you can see on the right-hand side, the visualization system which we have, which derives which utilizes this warning system to provide the early warning and disseminate the warning to multiple stakeholders through either through phone, through emails, through also over the phone and alarm systems. You can see that the right hand side, you are seeing the emails which are going to the Kerala State Disaster Man. So with this approach only, we have built the AI enabled IoT system for detection and early warning of landslides, which is capable to sense deep earth layers, use AI ML integrated models and threshold, which is providing both site specific and regional warnings in both active deployment sites, Western Ghats and Northeastern, in early warnings in multiple years from 2009 to 2022. And so if you see that the development happened from 2006 to 22, which is capable of doing multiple types of landslides can be monitored, and it has the knowledge, it has the decision models where it will derive the knowledge and derive the events accordingly. And based on that, also parallelly capacity development and community engagement is brought in, so that community scale resilience is achieved through risk visualization and real-time risk communication. Now from the single event, from the single hazard, let us go into a multi-hazard. Kerala floods 2018, a case study of a multi-hazard event. In 2018, the extreme rainfall Kerala has gone through is about 42% departure from normal, which caused 14% of total land has flooded, 200 plus landslides, 36 dams had to be opened at a stretch, and the rivers have changed, and more than 450 plus death toll has happened. And these are some of the images, and this has contributed to the initiation of landslides, floods, collapse of infrastructure, houses. And not only that, out of the 14 districts, almost every district ended up into the combined multi-hazard events. Predominantly now, these are some of the districts. And if you see here the dam network, this is the 36 dam networks, one simple illustration of how the dam networks are connected. So if the dam number 1 opens, 2 opens, 3 gets flooded, and then everything gets flooded. And that's how the flow of excess water has contributed a large scale of flooding in the area where you can see in the pink color. So if you look at the chronology of events, you have a spatio-temporal correlation of events from rainfall to floods to landslides, dam opening, leading to combined, which is the joining or merging of many hazards in same location, consequent occurring as a direct result, and subsequent as occurring one after other, and simultaneous occurring at the same. These types of events has happened. So if you look at the right hand side, from the date 1st June to 25th August, you can see the rain which is continuously happening, and you can see that consequent events which are coming in almost like an yellow-orange color. Orange color it is coming, which has written landslide triggered by rain, flood triggered by rain, then landslide triggered by rain. And if you come down, you can see that there is a red colored one which says the demolition of bridges in the date of 5th August. And then you can see that as you move along in the group of 9th August to 20th August, you can see that it became simultaneous where rain, dam opening, landslide, and flood. So if you go a little more deeper with a lens from 9th August to 20th August, you can see how the impact of death toll. It started from 23rd, 23 people dying to 300 plus. See the amount of impact it has brought in. This clearly tells us that it is not enough for us to work on just one hazard. We have to go dive deeper and understand the interrelationships and the impacts, the risks, the vulnerability it is happening due to a multi-hazard, and based on that, resilience has to be brought in the community. So just the Kerala floods alone, you are able to see multiple scenarios where either only landslides or flood causing dam opening and landslide, or dam opening causing worsening flood and landslide. So multiple scenarios. So you can see a multi-level, multi-scale progression of hazard. And this progress, which is actually contributing to a progression of risk and vulnerability in a spatial and a temporal manner, which is impacting, which is providing a cascaded impacts. That's what you are seeing with the death toll and all other elements. So the resilience need to be built in a multi-scale and multi-level with the inclusion of multiple stakeholders for engagement, empowerment in building community scale resilience. And there are a lot of community resilience factors. Some of the key areas we have to look into: economic resilience, institutional resilience, infrastructure resilience, and other. Just to give an example, like when we are issuing a warning, regional warning, imagine that I don't know the institutional actors. Then what I am sending as an information will be to the wrong people. So you will not be able to utilize, even though you have done everything else to come up to warning. If you don't know the actors playing there, you are not going to achieve the required resilience. That is what is happening. So it is very important to understand the stakeholders who are involved in it: community members, local administrators, scientists, youth organizations, government. Each society will be differing, and there will be a lot of things. You have to understand each one of them, so that your multi-hazard identification, from hazard identification to interaction to exposure to vulnerability to risk curve, which will help us to connect it to the resilient factors, the different variables, and thus reaching into the different cases of adaptation. So if you look at the case 3 here, it is where we are saying the state before adaptation, they have limited or no ability of adaptation. So because of the inability to implement adapt. In the case 2, they are able to take a first level of adaptation with the different adaptation measures, whereas but still there is problem exists, so inability to live with that. But whereas in the third, they have the ability to live with respect to first order adaptation, second order adaptation, it is going forward. So in your solution,
Manisha, you have 2 minutes.
Yeah, you have to build that, how you will bring in. Yes, ma'am. You have to bring in the different adaptation mechanisms. So here, if you see that in our case, the landslides and flood, the first level, there is no adaptation, no regional, neither local. The level 1, we have the regional warning using rainfall thresholds, weather models, flood models, etc., which is basically going into the stakeholders for understanding the larger area where it is impacting rather than the specific location. But when level 2, you have the site specific, whether you don't know the regional, but you know the local, where exactly where it is happening, you know it, but the largest perspective is missing. But level 3 adaptation, you have the comprehensive system where you have both regional and local, where we have built the landslide tracker app, AI/ML predictive system, then the Amrita visualization, and also the Amrita Kripa crowdsourcing application for flood management and 24-hour closing. With all these things, we have moved forward for a holistic approach. And if you see in our university, the Chancellor has brought in multi-hazard resilience as a holistic initiative, where we were looking into community resilience in housing by providing housing which are disaster specific and disaster resilient, as yesterday's presentation where Bhavani has talked about, where we have built houses which are resilient to the tsunami future, providing fishing vessels for income generation and livelihood security after the tsunami has hit, building the bridges between the backwaters there as called Amrita Sedu for the evacuation of the people, then building shelters and community centers, providing Jeevamritam clean drinking water solution to provide the water access. Then to build in community resilience on the livelihood side, we have brought into skill development, Amrita Shri, which is a self-help group building, and Live in Labs, which is a program where students are involved. So in skill development, what we have done is in fisherman community, when the tsunami hit, we know that they don't have any other skill they have. Our Chancellor has brought in the different schemes like nursing, driving, etc., so that livelihood diversification can be brought in. This will bring in the resilience. Then Amrita Shri has been built as a self-help group, which provided financial inclusivity, empowerment, and entrepreneurship for women, which will build in the resilience. The Live in Labs, the students and faculty has been equipped to look at community-specific problems, co-designed with the community, so which is building in on a long-term the sustainable solutions for this, which will give you the living. And on top of that, on the community resilience, we looked into the lives where we looked into landslides, floods, droughts, ocean emergencies, and tsunami. So here we have, as I talked, there is a landslide early warning system, landslide tracker app, in flood evacuation application to look at flood level progression in a geospatial manner and giving the warnings. Amrita Kripa app, which gives the flood management, disaster management for handling droughts, building check dams, IoT level water distribution systems for looking at water access and at the same time water sustainability, building drought resistant crops and empowering the communities, in ocean emergencies, building offshore communication network to provide them communication facility to handle the ocean emergency, tsunami, where we started the tsunami readiness program in collaboration with INCOAS, and also deploying Casuarina tree planting all along this one. So this, whatever we are talking, our chancellor has bring in as initiatives which are holistic, where we are looking into community resilience with respect to infrastructure, livelihood, and lives. Thank you, everybody. Thank you.
Thank you so much, Dr. Manisha. It's always amazing to listen to your tremendous work. Over to the next speaker, and then we'll keep some time for wrapping up. So it's with great pleasure that I invite Dr. Shiresh Ravan, Program Officer, UN SPIDER. He has dedicated his work to global space governance and promoting peaceful uses of outer space, Austria. He implements global programs facilitating the use of space-based technologies and achieving sustainable development goals and disaster and climate resilience. He coordinates activities of the United Nations Platform for Space-Based Information for Disaster Management and Emergency Response. The program is called UN SPIDER, a network of 26 regional support offices across all continents. He has extensively worked with several countries in Asia, the Pacific, and Africa to offer advocacy, technical advisory services, and the capacity to promote the use of space-based technologies in disaster management and emergency response. In the past, he has led the illicit crop monitoring program of the United Nations Office on Drugs and Crime in Afghanistan. So over to you, sir. It's a pleasure that you could make it today. Thank you so much.
Thank you, and please allow me to share my presentation. I hope you can hear me well.
Yes, thank you. We can.
Okay, good. So it seems we are running more than an hour late, and also my apology. Yesterday I could not present in the allotted time because of family emergency. So yeah, the topic I have chosen to speak here is on multi-hazard early warning systems driven by risk information. So how risk information plays an important role in early warning system. That is the thing that I would like to just discuss. Let me note the time. It's 7:20 in India. So I will try to finish less than the time that is allotted to me. I would necessarily focus on the power of space-based technologies. And as you know that in our daily life, we use space, but also in early warning and risk assessment, these space technologies are very, very important. Earth observation, communication, weather forecast, navigation services. If you look at what Sendai framework for disaster risk reduction advocates, there is a 7th global target that talks about availability and access to multi-hazard early warning system and disaster risk information and assessment. And among the 4 important components of early warning systems, having a risk knowledge, monitoring and warning services. These 2 are very, very important. And this is where Earth observation technologies along with geospatial technologies can help, which Yogita was speaking before. So just to let you know that my office, along with so many other offices, here you can notice this is my office, United Nations Office for Outer Space Affairs. We have launched this international network for multi-hazard early warning systems, and there are lots of global meetings happen. The latest one was in the in Bali in April. It was a global platform for disaster risk reduction. That is where we had the 3rd international meeting on these multi-hazard early warning systems. So some of you might have attended. If not, you can become part of this particular network and can contribute to this global effort. So just to let you know that why I'm just talking about risk information is very important for early warning, and with 50 years of accumulated knowledge of Earth systems, you can get lots of risk information about atmosphere, land, oceans, and ice coverage. And this is just one example from one of the regional support office of UN SPIDER program that from 1960s, they are monitoring the glacial lakes. Just to know about glacial lakes, possibility of glacial lake outburst floods. So right from 1960s, the images are in the open domain, which one can use, and you can get the risk information that is useful for designing your early multi-hazard early warning systems. That's what it just thinks. Also, I would like to mention that just if you remember the flood in Bangkok in 2011, it was not just a heavy rainfall. It is because Bangkok is sinking every day. Every year it sinks almost 110 millimeters. That's land subsidence. And because of that subsidence, if little rainfall happens more, then the floods are unprecedented, and you can see how much loss it happened, 800 deaths and billions of dollars of economic loss. Similarly, Jakarta is sinking. So there are many cities sinking. So these are some of the risk informations which space can provide you through the technological analysis, which otherwise you cannot perceive this on the ground. So monitoring the unseen risk. And if you know what kind of risk exists, then you can think of what early warning systems we should be designing. Similarly, you see, biodiversity is very, very important. Nature-based solutions. See what has happened in Bangalore recently, the floods there. So we have destroyed the natural systems, and we also need to know what we have destroyed, how we can recover that. And if that knowledge exists with us, we can offer the blue and green infrastructure to save our cities in future. So what in this context, we just published importance of monitoring the World Heritage Sites from the space. So World Heritage Sites are not just to be seen as a house of wonderful animals or wonderful biodiversity, but they have tremendous role in ecosystem-based disaster risk reduction. So this is one review we have published very recently, about a year back. That entire episode, this review is dedicated for power of space technologies, how they can deal with the disaster risk reduction and dealing with climate change. So these are some of the glimpses. It just shows you that what you can't see normally from outside, you can monitor regularly using the multiple satellite images, and you can get a lot of information that you can use in the early warning systems. Not only just monitoring the damages that happen, but you can also generate lots of dynamic information that is needed for early warning. So when I talk of nature-based solutions, I would like to know about extent of the ecosystems, compositions, the biodiversity, potential, how much biomass potential it has, what is the net primary productivity, carbon sequestration potential, or is that ecosystem valuable for various, key indicator animals that indicate health of ecosystem. So many things you can evaluate when you combine the ground data, and that contributes to ecosystem-based disaster risk reduction or ecosystem-based adaptation, and subsequently it contributes to sustainable development goals, and of course through disaster and climate resilience. I would like to also highlight some of the risks that we don't really think much. We call it high impact and low probability risks. So HILP is the high impact, low probability risks. So COVID-19 pandemic is one such risk, and then another is near Earth object impacts, asteroids that might hit Earth at some point. So these are some of the risks that we don't think much, but we never thought of pandemic, and we know what happened during pandemic. Similar thing can happen also when near Earth object impact happens on the Earth. So therefore, we published two very important documents now. One is in Nature Medicine Journal, which has impact factor 57, something very high. And we are talking about, can space-based technologies help manage and prevent pandemics? 100 years back, there was a Spanish flu and pandemic, and we did not even remember it until COVID hit us. So we forgot all the lessons 100 years back, that pandemic that hit us. So now can we correct our mistakes? And now we are blessed with space technology. 100 years ago, we were not blessed with space technologies. So lots of things that are used in the space for astronauts, those systems can be downscaled and adopted for the health services. And then you can develop a lot of technologies which in future can definitely help manage the pandemic. And this is the thought we have left in this particular journal. It can include epidemiology, virtual care, biomonitor, mental health, or One Health approaches. So space has a lot of things because someone supports 6 astronauts high sitting in the International Space Station. How we manage that? If we can manage that, why can't we manage pandemics like this? So just we need this thinking and continuous work on this kind of aspects. Another thing I wanted to also mention on high probability, high impact and low probability disasters is the near Earth object threats. My office is part of the International Asteroid Warning Network, I1, and we also are part of the Planetary Defense Conference. And this is where we bring entire global community together to understand risks coming from space, the asteroids. So we have published recently a paper in International Journal of Disaster Risk Science where 10 authors got together with me, and we are talking about when these strikes, these kind of asteroids, when it strikes, are we ready? Lessons identified in preparing near Earth object impact scenario. So what we did is, with the help of NASA, we created entire scenario. If asteroid hits us, what is the range normally it can cover? And how accurate is that? When accuracy can improve? How many years before the such kind of impact happens? How many years before we know it? To what accuracy? So we will not leave people in limbo when such kind of threat happens. So early warning is very, very important, but you also need lots of systems and not knowledge of risks that we are living with. So this particular paper talks a lot of things about lessons learned, how we detect and provide the early warning, how we plan and exercise, what are the social, economic, political considerations, how to communicate the risks. Early warning also needs to communicate it well, not create a panic. What should be the governance structure around it? How we can do continuous outreach and education in such kind of scenarios. So these are very important aspects we have given. This, I think, is first kind of paper that is published on near Earth object threats, but it has a potential of destroying entire Earth. What dinosaurs got destroyed because of that, but we have the space technology, so we can save ourselves. So these lessons are not only for those kind of disasters, but these lessons can be used in regular disaster management and providing early warnings. And space is going very, very high right now. You can see sudden launches. Last 2 years, the launches have increased exponentially. With that, you are getting frequent monitoring capacities, near real-time data, better data, merging with cloud technologies, big data, artificial intelligence, then machine learning, and so on. So with that, we are very well basically now placed to use the technologies to create the multi-hazard early warning system. But not only that, but also create the risk information that should go on the backdrop of the early warning system. So with that message, I would like to hand it over back to the chair. Thank you so much. I think I've taken less time than it is required, but I think everyone delayed, so I would like to just save some time. Thank you so much.
Thank you so much, Dr. Suresh. Really appreciate your work and telling us about how the revolution in space activities is playing such a vital role in improving Muse. So we have one more speaker, and this is the last speaker for our panel today. It's with just give me a second, sir. Yeah. I invite Dr. Padmanabhan M., who is currently working as scientist at the Indian National Center for Ocean Information Services in COIS, Ministry of Earth Sciences, Government of India, Hyderabad. He has more than 15 years of IT experience in realizing various applications. He is one of the key persons who contributed significantly to the Indian Tsunami Early Warning Center at INCOIS. His work includes the implementation of various mission critical projects or applications to support early warning services, technology refreshment of the TEWC data center, and a decision support system for storm surge services. He's a member of IOC UNESCO Working Group 2 on Tsunami Detection, Warning and Dissemination in the ICG IOTWMS framework of IOC UNESCO, and his research interests include decision support systems, disaster risk reduction, geospatial technologies, and artificial intelligence. So over to you, Dr. Padmanabhan. Thank you. Yes, please start, sir. I think you're muted. Can't hear you.
Am I audible now?
Yes, thank you.
Thank you, Dr. Professor Sudha and Dr. Manisha and the entire team of Amrita for giving this opportunity. In this topic, I'm going to cover on the Indian tsunami and storm surge early warning system at INCOIS. Before venturing into the next slide, I'd like to express what exactly INCOIS does. INCOIS is an operational ocean services agency. Our prime responsibility is to bring the science to the society. If you observe on the left corner, we focus on the research and continuous observations and consortium of experts we do have at INCOIS, and we provide ecosystem services as well as multi-hazard early warning services. When it comes to ecosystem services, it is potential fishing zone advisories, coral bleach alerts, and harmful algal blooms. And recently we started with coastal water quality measurements as well. Coming to multi-hazard, we deal with tsunamis, storm surges, and ocean state forecasts such as high wave alerts, wells, and rip currents. And also we provide marine safety and rescue operations, like Sarat is one of the tools where extensively used to find any object that has been lost into the ocean. And we also deal with oil spill trajectory to provide appropriate oil spill trajectory guidance to the Indian Coast Guard to mitigate or to respond to any active oil spills. And when it comes to society needs, we in general take part of industry and servicemen and common people requirements. Our services are more onto the user centric, and it deals with livelihood, safety, security, and rescue operations. Yeah, my current presentation deals with, my outline will be addressing the tsunami early warning service, storm surge early warning service, and implementation of tsunami ready, and challenges and key priorities. Before going to tsunami early warning service, if we consider in the Indian Ocean scenario, we have two potential tsunami zones that are part of our Indian Ocean basin. One is Sunda subduction zone right from the Myanmar to down the Australia, and the other one is Makaran subduction zone near to Iran and Pakistan. These are the two prime subduction zones where a frequent earthquakes can happen, and that may lead to tsunami if it is beyond a threshold of 7.0 magnitude. And if we see the possibility of tsunami generation, there are four kinds of possibilities that can generate a tsunami. One is seismicity in the oceanic part. The other one is landslides that are happening at the sea bottom, and volcanic eruptions, and any atmospheric meteoroids that are hitting to the oceanic part. However, if we consider the gamut of outlook of these events, earthquakes plays a vital role to generate significant tsunamis very frequently. And considering India, we have tsunami risk assessment. We did a tsunami risk assessment for Makaran and as well as Andaman Sumatra subduction zone. What we found was, if any earthquake happened near Makaran zone, and it will take hardly 2 to 3 hours to reach to the Indian coast, like Gujarat state. For Andaman, there is no time because it is just sitting on the subduction zone. And whenever there is an earthquake near Andaman, it will take hardly 2 to 2.5 hours to reach the Indian coast. So, keeping in view of these risk assessments, the early warning center at INCOIS was designed post event of 2004 tsunami, which was one of the deadliest tsunami that would have been that occurred till date. And these are the components of the tsunami early warning center. Any warning system will have 3 phases: detection of the hazard, and providing timely warnings and disseminating to the coastal communities. To achieve this, we have established a group of networks, observational networks with seismic, sea level, and tide gauges. And we have redundant communication methodologies adopted for data reception like VSAT, INSAT, GPRS, and MRSAT. And we do have a sophisticated modeling system at INCOIS where we deal with various numerical models in terms of tsunami as well as storm surge. And we also do conduct capacity building exercise to various stakeholders like disaster management officials and user community and fishermen community and other disaster related officers. We do conduct communication tests very frequently because tsunamis are very rare events, but it can devastate much greater magnitude. So to keep the tsunami warnings afresh, we do conduct tsunami mock exercises and mock drills with considering the SDMS, state disaster management, as well as district disaster management to include and take part in the drills. And we also did paleo tsunami modeling and GNS data. As on today, since its inception, we recorded around 658 earthquakes across the world, and out of which 101 are occurred in the Indian Ocean, and wherein we have issued only 7 events which led to issuing a warning to the public. This is the observational network. We have a 130 broadband seismometers and 35 strong motion accelerometers and 35 GNSS receivers. This data is coming in real time at a much lesser latency. And we do have a sea level network with 7 tsunami buoys and 36 tide gauges. And we have also established 5 sets of quadas along with our sister organization NIOT. Coming to tsunami modeling, for any warning system to provide timely advisory, modeling plays numerical modeling plays a vital role. And we ran our tsunami models for entire these 2 subduction zones. It coming around 3.2 million grids of spacing, and we have a ABC of OOPS-DB, which is a pre-computed database that is there for a live access to a decision support tool. And if we see India, INCOIS is not only having a presence in India. We are providing tsunami advices to India as well as Indian Ocean rim countries. We are facilitating these advisories to 25 rim ocean countries. And currently, India, along with Indonesia and Australia, is monitoring this entire Indian Ocean basin. We are currently giving a service level 2 bulletins, wherein tsunami threat at the coast is being given, and INCOIS is currently working on service level 3, where the inundation extent also can be given till the block level. If we see the warning chain from the warning center to the public, these are the several ways in general we communicate our advisories directly to the public. Whenever there is a bulletin being issued, we issue to the local disaster management officials and critical installations like ports, harbors, and nuclear plants. And we also do send this information to NDMOs, National Disaster Management Authority, as well as Ministry of Home Affairs. And at the same time, NTWC, as a National Tsunami Warning Center, we also constantly feed this information through various media like national radio and national TVs to the public. So at any given point in time, the idea of formulating this warning chain is not to miss or not to keep anyone behind without knowing when there is a tsunami is going to hit. And our operational, our standard operating system procedure has been formulated meticulously. Why? Because India is having near source tsunamis as well as far source tsunamis. When it comes to Andaman, it is a very near source tsunami. So the SOP is formulated in such a way that we deal with both less than 60 minutes events as well as greater than 60 minutes events. And whenever we record an earthquake of more than 6.5, we normally send out the first bulletin as an earthquake information, followed by a pre-model scenario based, potential tsunami information, where it will clearly give at what location, at what time the tsunami is going to approach, and what could be the wave height based on the model results. And further, we rely on these sea level observatory to confirm the tsunami, whether it has really triggered a tsunami or not, and give confirmed tsunami from third bulletin onwards. And our timelines are very strict in nature. Within 10 minutes of time, we will send the earthquake information. Within 20 minutes of time, we will send the first tsunami bulletin information with appropriate tsunami threats. These are the different threat statuses that are being calculated and sent to the public, and associated actions. So warning means the highest action where public should be advised to move inland or towards the higher ground, and they should avoid beaches as well. Alert means only beach level evacuation is essential and vessels should move into the ocean. Watch means there is no immediate action is required, but still be vigilant and be updated with this information from warning center as well as disaster management official. And threat pass. Yes, ma'am. VSAT aided communication. This is the fail-safe communication we have implemented for Andaman because it is just sitting on the abduction zone. And this is the website where one can access our bulletins. Coming to storm surge early warning service, it is a collaborative service between IMD and INCOIS. IMD gives the cyclone information, and whereas INCOIS gives the storm surge information. We ran at such model. We give at mandal level what could be the storm surge and what could be the extent of inundation. These are the list of cyclones we have dealt as of today. And these are the different dissemination methods to reach the stakeholders. There are conventional communication methods through which we normally approach all the stakeholders. There is a satellite-based dissemination also implemented for mariners and remote areas, such as Gagan and a NAVIC-based dissemination. And currently, INCOIS is taking part of tsunami ready implementation. As of now, for Orissa coast, 2 villages got tsunami ready communities like Venkatrayapur and Nolia Sai. And currently, we are working with Kerala State, and a pilot village is identified in consultation with Amrita, Vishwa, Vidyapeetham, and KSDM. And the program is yet to initiate. And these are the different prepared and responses we normally deal with. And capacity building, we normally conduct workshops and user interaction meetings and disaster awareness at Andaman as well as all the places of Indian coast. Coming to challenges, in general, the earthquake magnitudes at an early stage will be underestimated. And if we consider March 11, 2011 event at Japan, initial estimate was 7.9, whereas it reached to almost 9.2. And to overcome this, for Indian scenario, we have established a GNSS and strong motion accelerometer network at Andaman with a network of 35 stations. And there are challenges in terms of inundation. As of now, across the world, no one is giving directly inundation. We are trying to attempt to give the real-time inundation with the use of ETSAT that can be computed within 3 to 8 minutes. And this was the experimented with the 2004 tsunami, where the results are at par. And there are other tsunami warning challenges like submarine landslides or liquefaction. If we consider the event happened near Indonesia, the Palu event, it took 5 minutes for BMKG to give a warning. Before that, before they received the first warning, the wave reached within 3 minutes. And there are other tsunami warning challenges like volcanic eruptions, where Anak Krakatau was one of the example. And currently we are working on the methodologies to identify and go forward for these tsunami warnings. And emergency communication system is one of the greatest challenge. During October 2010, there was
I'm so sorry, sir.
Yes,
I'm
madam.
so sorry, sir.
This is the last
Oh,
slide.
thank you. Thank you. So sorry. Thank you.
These are the key priorities we are taking part in the next 5 years to minimize or mitigate the tsunami and storm surge effects. Thank you.
Thank you so much. I really feel so bad when there's so much information, interesting information going on, but we have our chief guest waiting, and so
Yes.
we will be sharing everybody. We'll be sharing the proceedings with everyone, and you'll have the contact information. So I just want to wrap up today. We unfortunately don't have time for question and answers, but I just wanted to appreciate all our speakers. We had Professor Deepthi Vikramasinghe from Sri Lanka, from the University of Colombo, who talked about nature-based solutions in helping to build community resilience. If I may have everyone turn their cameras on.
Ma'am, I think we have time for at least one or two questions, isn't it?
Living in about nature-based solutions and the importance of seagrass beds in carbon sequestration and her interesting work over there. We have Mr. Sunil Jaivira, who is a practitioner working work with keeping it safer. Ordinary regions understand it. So India, Germany, Japan, and so on. For Meta, who talked about global to local and the importance of all these from data from Munich Re, and he showed us the various graphs, and he said it's not
Hello, everybody. I think Dr. Sudha is experiencing networking challenges, I think. Internet challenges. That's why I think we are getting the results broken. Just to, I can see one of the question on the panel as it is as a student in geospatial domain, how and what we can utilize the space data for integrating with field level data. If any of you have an answer to this question, would you be able to, Dr. Yogita or Professor Formato, any of you have the answers for that question? That would be helpful.
Yes, field level data. Thank you first of all for your question. And level data, I was guessing about river level. I guess I don't know if I am correcting. In that case, it will be very, if I understood well, in that case, it will be very important. A recent study just demonstrate how from satellite, for example, for large river can detect the level of large rivers, for example. I saw one on the Mississippi one, for example, or a river like the size of the last one that I mentioned. So this could be like validation of these kind of spatial data that come from the space. This could be one idea. But in case I didn't get very well the question, please be more specific and I will be very happy to answer.
I would like to add to what Professor Formetta has said, that geospatial is one system like GIS where we can integrate both the spatial and the non-spatial information. So whatever field data you collect is called an attribute data, and we can link it to the thematic data which we develop from the satellite images. So as I said in my presentation, that whatever satellite gives is the raw data. From that raw data, we develop that into an analysis ready data, which are the thematic maps like vegetation maps, hydrological maps. So all these maps, they need to be connected with the field information which is collected. So you get the right information about that particular place, about that particular feature, about that particular geography and attribute. So this is what you can do by connecting it. And as a student, if you want to pursue this domain, you have to figure out what exactly you want to contribute to, whether you want to contribute through research, whether you want to contribute through being in the private industry, as an academician. So this is a personal thing, and as you move forward, you will get the answers to these questions. But yes, at technology level, you can connect the field data with whatever observations you get from the satellite data.
I have not seen any other questions in the chat, in the Q&A. I think I thank each one of you for joining. And what we think is, like, we hope to make like a working group where we can work on some specific challenges which is in the early warning systems. And then based on that, we can come up with a specialization and then plan for a bigger program in the next year where this working group can take forward that particular area also. So I would request all of you to respond when an email comes for seeking for your collaboration, and we look forward to work with each one of you. Thank you. Thank you, everybody.
Thank you. I'm so sorry, everybody. I lost connection. Thank you. Dr. Manisha took over.
Oh, we
what
were
a pleasure
resilient and
having all of
adaptive
you.
to handle the situation.
Thank you. Thank you. Please, if you all have the time, please come over to the attend the closing ceremony. And after that, we have student presentations. So if you all can wait for another hour and a half, we would really appreciate it. Thank you so much. Thank you.
Thank you.
All right. We have now reached the culmination of the successful two-day international symposium on multi-hazard early warning and community resilience, MWCR 2022, organized by Amrita UNESCO Chair on Experiential Learning for Sustainable Innovation and Development, Amrita School for Sustainable Development, and Amrita Center for Wireless Networks and Application. To commemorate the culmination of MWCR 2022, we welcome each and everyone to our valediction event. For the last 2 days, we have witnessed elaborate and inspiring keynotes. I'm hearing an echo, so all right. Inspiring keynote speeches from a wide range of experts from around the world. We believe that all of you have enjoyed each and every session at MWCR and gained valuable insight from the experts hosted. My name is Mustafa Niati.
And I am Yekaterina Lengerfeld.
All right.
We are the students.
Ekaterina, you have an echo. Can you mute all the other devices around you?
We will certainly try.
Okay, go ahead.
Is
Yeah.
it better?
Yes, it is fine now. Thank you so much. Go ahead.
Okay, thank you. Thank you, everyone. So sorry for the technical part.
Okay, we are facing the same issue.
Yeah. So Moshtaba and I, we are students. We are PhD students at the School of Sustainable Development. And we are very happy and very honored to be here today. And we would like to welcome you to this session. And we are very honored to be the host of this session. Thank you very much.
All right. Now I have the pleasure to introduce Dr. Danya Ang. She is currently serving as an assistant professor at Amrita Vishwa Vidyapeetham. She completed her PhD at the Indian Institute of Space, Science and Technology, IIST, Trivandrum, Kerala. Her research was focused on data assimilation of satellite observations for improving the forecast of heavy rainfall events. Presently, her research involves analysis of extreme events such as cloudbursts, as well as utilizing data-driven models for landslide early warning systems. May I request Dr. Danya to deliver the welcome address, please. Dr. Danya?
I think, Mostaba, we have a short break, isn't it, before we start the valedictory?
I've been told that the break has been removed, but if it's a time, yeah, we can have a break.
So I think we can take a short break because it was a long day. We can say take some 3 to 4 minutes break and then come back.
Sure. Let us come back after 5 minutes of break. Thank you so much.
Thank you.
Thank you.
Thank you.
Located in the Idukki district of Kerala, lies along the famous Western Ghats and has experienced multiple landslides in its history. Over the past several decades, many homes have been destroyed and many lives have been lost as a result of the rainfall-induced landslides. European partners of the Windsock project visited Amrita in June 2009. Amrita University's landslide detection system monitors 7 acres of unstable land and currently includes 20 sensor columns, 20 wireless network nodes, and around 150 sensors. The sensor columns are solar center, which then transmits through the satellite network to Amrita University's Amritapuri campus. The data are then analyzed, stored, and streamed to the university's web server. The system has successfully given warnings 3 times. Amrita's wireless landslide detection system has also been featured in several leading Indian newspapers. The team is currently working on implementing a landslide detection system in the Himalayas. Based on the initial survey of population distribution and slope vulnerability, the Chandmari region in Sikkim was assessed to be the most needed area to install the detection system. The pilot phase of the project has been completed. The system will be fully deployed and operational by the end of 2017. Once completed, the system will be able to monitor landslides in an area of approximately 130 acres.
டைம்ல எங்களுக்கு ஒரு இன்ஃபர்மேஷன் கிடைச்சதுனால இங்குள்ள மக்களையும் வந்து ஒரு பாதுகாப்பா இருக்கிறதுக்கு முடிஞ்சிச்சு. அதனால இப்போ வந்து என்ன செய்யுது மக்கள் பயம் இல்லாம இருக்கறாங்க. இதனால இது வச்சதுனால அமிர்தானந்த அம்மாவுக்கு அவங்களோட இன்ஸ்டியூட்டில் வேலை செய்த எல்லாருக்கும் ரொம்ப நன்றி.
நன்றி. அமிர்தா அம்மைக்கு வளர நன்றி. ഞങ്ങളുടെ നന്ദി ആസ്വദിക്കുന്നു.
കഴിഞ്ഞ വർഷം അനേക പ്രകൃതി ദുരന്തങ്ങൾക്കും സംഘർഷങ്ങൾക്കും ലോകം സാക്ഷ്യം വഹിച്ചു. പ്രളയം നമുക്കൊരു താക്കീതായിരുന്നു, സന്ദേശമായിരുന്നു. സ്വാർത്ഥമായ താൽക്കാലിക ലാഭങ്ങൾക്ക് വേണ്ടി പ്രകൃതി ചൂഷണം ചെയ്യാൻ തുടങ്ങിയിട്ട് കാലങ്ങൾ കുറേയായി. അതിൻ്റെ ദിഗ്ധഫലമാണ് നമ്മൾ കണ്ടത്.
Love, serve, and be compassionate to all beings, going beyond all differences and barriers, is the vision and mission of Amrita deemed to be university. Our Chancellor, Srimata Amritanandamayi Devi, Amma, is the living embodiment of these very values. To instill this in all aspects of life, including the nature that we live in, a compassion-driven approach to ecosystem restoration and conservation and community-level hazard resilience has been embraced by Amma's organization from almost the mid-1980s.
നമ്മുടെ പ്രപഞ്ചത്തിനൊരു താളമുണ്ട്. ഈ വിശുദ്ധം അതിൽ അകലജീവിയാളും അഭേദ്യമായ ബന്ധമുണ്ട്. പരസ്പരം ബന്ധപ്പെട്ട് കിടക്കുന്ന നെറ്റ്വർക്കുകളാണ് ഈ പ്രപഞ്ചം. 4 പേര് ചേർന്ന് പിടിച്ച് ഇവരുടെ ഫോണിൽ സ്ഥലമുണ്ടായാൽ അതെല്ലായിടവും പ്രതിഫലിക്കും. അതുപോലെ നാം അറിഞ്ഞോ അറിയാതെയോ ഒറ്റയായോ കൂട്ടമായോ ചെയ്യുന്ന എല്ലാ കർമ്മങ്ങളും
All right, welcome back. I'm honored to introduce Dr. Danya. She is currently serving as an assistant professor at Amrita Vishwa Vidyapeetham. She completed her PhD at the Indian Institute of Space Science and Technology, IIST, Trivandrum, Kerala. Her research was focused on data assimilation of satellite observation for improving the forecast of heavy rainfall events. Presently, her research involves analysis of extreme events such as cloud bursts, as well as utilizing data-driven models for landslide early warning systems. Dr. Danya, the stage is yours to deliver the welcome address, please.
Thank you very much. Good morning, good afternoon, and good evening to all the distinguished speakers and attendees from around the world. We have arrived at the culmination of our International Symposium on Multi-Hazards Early Warning and Community Resilience, and it's my privilege to welcome all of you to this valedictory event. To grace this occasion, we have our chief guest with us, Dr. Mrityunjay Mahapatra. Dr. Mahapatra is the Director General of Meteorology, India Meteorological Department, Government of India. Dr. Mahapatra significantly contributed to the remarkable improvement in cyclone warning services by the India Meteorological Department. As a project director for modernization of weather forecasting and cyclone warning services of IMD, project director for forecast demonstration of landfalling cyclones, head of cyclone warning division, and WMO recognized regional specialized meteorological center for cyclones since 2008. His contribution as team leader not only helped India to manage cyclones, but also helped other countries around Bay of Bengal and Arabian Sea. He has served as chairman of Committee for Technical Evaluation of Web-based Decision Support System for National Cyclone Research Risk Mitigation Project of Government of India. He introduced scientific methodology in cyclone forecasting, including extension of lead period of cyclogenesis forecast from 1 day in 2008 to 3 days in 2014 and 5 days in 2018. Also, in the cyclone track and intensity forecast, the lead time has increased from 24 hours in 2008 to 72 hours since 2009 and to 120 hours since 2013. His efforts have been lauded by various national and international leaders and nations, and he has been the recipient of several awards such as Chintamani Memorial Medal 1985, Bharat Gaurav Award, Achievers Award 2013, Bhumiputra Samman, Satya Samman, MOES Young Scientist Award 2008, to name a few. He has authored over 100 publications in the area of climate change, cyclone forecasting, disaster risk reduction, as well as delivered keynote addresses in global events related to disaster risk management. He's a very vibrant teacher and a guide to younger generations, always happy to interact with students across disciplines and landscapes. He has guided more than 10 PhD students and is part of doctoral committee of many more. I'm extremely honored and privileged to welcome Dr. Mrityunjay Mohapatra to this August gathering. We have with us Dr. Manisha V. Ramesh, who is spearheading the research activities at our center. She holds a UNESCO chair for experiential learning for sustainable innovation and development. She also holds other eminent positions at Amrita Vishwa Vidyapeetham. Dr. Manisha is the Provost, Strategic Initiatives, Research and Innovation, Dean, School for Sustainable Development, Dean, International Programs, and Director of Amrita Center for Wireless Networks and Applications. Dr. Manisha heads the Live in Labs program, which provides an opportunity for students and faculty to work extensively in 101 Indian villages, focusing in part on ecosystem restoration and multi-hazard resilience. Through this, she has been involved in developing a unique curriculum at Amrita, which incorporates experiential learning, peer learning, project-based learning, inclusive learning, etc. In a subject-wise analysis carried out by Stanford University, Dr. Manisha has been cited among the top 2% of scientists in the world based on publication list available in Scopus. She was a recipient of NABARD Award for Rural Innovation, second prize from the Honorable Finance Minister, Government of India in 2012 for her research activities that benefited the rural community. She has more than 160 publications and 15 patents to her credit. Welcome, ma'am, to this valedictory event. We have Professor Vinod Kumar Sharma, who is the Senior Professor, Disaster Management, Consultant at Indian Institute of Public Administration. He is also the Vice Chairman, Sikkim State Disaster Management Authority, Government of Sikkim. He was member of UN ISDR Asia Science and Technology Academic Advisory Group from 2015 to 2019. Member Committee for Framing National Science, Technology and Innovation Policy 2020 of Government of India. He is a recipient of Subhash Chandra Bose Aapta Prabandhan National Award 2022, as well as recipient of Paul Appleby Award for Public Administration in 2017. Professor Sharma started his career from DAV College, Muzaffarnagar, and served in a number of universities in India, Middle East, and USA before joining the Indian Institute of Public Administration in 1992. He was instrumental in setting up National Center for Disaster Management and at IIPA, which is now National Institute of Disaster Management under Ministry of Home, Government of India. He is member of Executive Committee of Sphere India, which is a network of NGOs and UN organizations working in disaster management. He is a visiting professor, Kyoto University, Japan, and many other universities and training academic institutions in India and abroad. He has published more than 75 research papers and 15 books in the area of environment and disaster management. He is a member of several important committees of NDMA and IDM. It's a privilege for us, for you to be here, sir. Hearty welcome to you to this valedictory function. We also have with us Professor Sudha Arlikati. Professor Sudha has degrees in architecture from Pune University and city planning from IIT Kharagpur. and urban and regional science from Texas A&M University with an emphasis in environmental planning and hazards management. She has over 12 years of practitioner experience and 19 years of teaching and research experience in the USA, India, and the UAE. Her research interests include risk communication and protective action decision-making in multi-ethnic communities, responding to tsunamis, floods, earthquakes, hurricanes, and biological threats, disaster sheltering and housing recovery, and individual and organizational resilience for sustainable development. It's a great pleasure to invite Dr. Sudha to this valedictory event. I would also like to welcome all the participants to this event, all the attendees who have been listening to the speakers over the last 2 days, over the various sessions. It's with great pleasure and privilege, I welcome all the speakers who graced this event with their excellent presentations. Welcome to all the panelists and all the other participants of our International Symposium on Multi-Hazards, Early Warning, and Community Resilience. Thank you.
Thank you so much, ma'am. Thank you so much for a very warm welcome. All right. So now I have the pleasure of asking Dr. Manisha to start, and she is the provost of Strategic Initiative, Research and Innovation, Dean of the Amrita School for Sustainable Development, and the Director of Amrita Center for Wireless Networks and Application. She is also the UNESCO Chair on Experiential Learning for Sustainable Innovation and Development. All right, thank you so much. Please, may I request Dr. Manisha to deliver the summary of the symposium, please.
Pronouns to one and all. Good evening, good afternoon, everybody. Om Sri Gurubhyo Namaha Harihi Om. Om Sri Guru Brahma Guru Vishnu Guru Devo Maheshwaraha Guru Sakshat Parabrahma Tasmai Sri Gurave Namaha Tasmai Sri Amrite Shri Namaha Tasmai Sri Amrite Shri Namaha Tasmai Sri Amrite Shri Namaha. Pranams at Amma's lotus feet. My humble prostrations to one and all present here. My humble pranams to Dr. Mrityunjay Mohapatra, Professor Vinod Kumar Sharma, Dr. Sudha Alikati, Dr. Dhanya M, and all keynote speakers, panelists, and participants. I am very delighted to present the summary of the International Symposium on Multi-Hazards Warning and Community Resilience, conducted from 25 to 26 October 2022. The symposium has spanned 2 days, allowed us to explore various multi-hazard early warning systems and disaster risk reduction methodologies to address the increasing rate of multi-hazards. The symposium showcased 30 eminent international speakers from various state disaster management authorities, national disaster management centers, United Nations, international non-governmental and governmental organizations, international universities, etc. The keynote speakers included representatives from a total of 14 countries. The symposium provided a platform for officials, policymakers, academicians, and practitioners to showcase the impactful work conducted by them to ensure community resilience towards multi-hazards. Some of the key institutions and organizations that participated are UN Space-Based Information for Disaster Management and Emergency Response, SPIDER, Asian Disaster Preparedness Center, Bangkok, Thailand, UCL Warning Research Center, UK Geological Survey of India, India Meteorological Department, Earth Observatory of Singapore, Nanyang Technology University, National University of Singapore, ArtGeo Foundation, India, Resilient Projects, Australia, Kerala State Disaster Management Authority, Natural Hazards Center, University of Colorado, Boulder, USA, Disaster Management Center, Sri Lanka, Himachal Pradesh State Council, Tamil Nadu State Disaster Management Authority, University of Trento, Italy, University of Colombo, Sri Lanka, Sikkim State Disaster Management Authority, Kobe University, Japan, National Disaster Risk Reduction and Management Authority, National Institute of Technology, Karnataka, Indian National Center for Ocean Information Services, and National Earthquake Monitoring and Research Center, Department of Mines and Geology. The symposium drew more than 1,000 plus registered participants from various countries. I will now provide a summary of the symposium. The plenary sessions on day 1 broadly covered global and national perspectives and solutions for multi-hazard early warning and multi-hazard early warning for disaster resilience, implementation and lessons learned. The session showcased 13 international speakers whose expertise focused on areas such as impact-based forecasting and warning, protective action decision model, disaster risk reduction endeavors in various Indian states, challenges in multi-hazard warnings and disaster management, and a theoretical understanding of excellence in humanitarian operation by virtue of disaster relief operations performed by Amrita's parent organization, Mata Amrita Mud, among many others were spoken out. The keynote addresses highlighted the disasters prevalent in various states across India, the early warning initiatives and systems that have been implemented, the challenges and gaps in getting the early warning communicated to the last mile in Indian states of Uttarakhand, Sikkim, Kerala, and Tamil Nadu and Gujarat was also discussed. They have also brought out the solutions which they have implemented in these states, the successful solutions also. A data-driven approach for disaster risk reduction was also brought out. The role, achievements, and way forward in landslide disaster risk reduction endeavors in India and abroad by various governmental and non-governmental organizations were also spoken of. Furthermore, the talks emphasized on community-centric approaches for disaster risk reduction, as well as importance of active community participation, thereby ensuring effective stakeholder engagement at various levels of disaster management. These talks also has brought out the need for having interdisciplinary domains to work together to build in a solution which will provide resilience. 12 keynote addresses were presented on day 2 through 2 plenary sessions, integrating technological solutions with community-based initiatives for disaster resilience and community-scale disaster resilience challenges and opportunities. The topics covered focused on earthquake damage estimation, importance of considering gender-sensitive approach to disaster, low-cost sensors for disaster risk reduction, multi-hazard vulnerability assessment, and GeoAI-enabled vulnerability indices and smart decision-making solutions, among others. The session focused on earthquake damage estimation and its function in disaster preparedness, which included a categorical approach to handling earthquakes, identifying infrastructures with high vulnerability, using a translational research approach and making additional scale damage factors enhancements, allow the damage category to be explicitly defined from an academic standpoint. The approaches for hazard identification, vulnerability assessment, and risk analysis were described in the sessions that followed. The talk after that concentrated more on creating a future that is more resilient in the face of unpredictable extremes. Subsequent talks detailed the importance of low-cost sensors for disaster risk reduction, while also recommending them to localize communities' profile as much as possible. The final talk of the first plenary highlighted the difficulties that women face to cope with the disasters, while recommending more specific guidelines to reduce women vulnerabilities, increased contribution to disaster research that includes sexual minorities, and develop the relevant curriculum materials. The second plenary session on day 2 focused on community-scale disaster resilience, challenges and opportunities, the importance of co-development strategies in realizing SDGs, along with the importance of using nature-based solutions for sustainable management. Various examples of ecosystem restoration in India, Sri Lanka, Nepal, and other countries were brought out. The challenge of nature-based solutions being not prioritized was attributed to the lack of understanding, awareness, and low stakeholder involvement. Various trends in multi-hazard impacts for the last 38 years were brought out. The critical importance of moving towards localized risk analysis, assessment of vulnerability, and impact quantification were also stressed. The importance of application of a global and spatial explicit framework to integrate population was spoken out. A comparison of Earth systems to geospatial systems was drawn, and geoinformation was showcased as the integration of many tools such as AI, ML, and IoT. The importance of building climate resilience through mitigation and adaptation using geospatial technologies by creating data and information structure and building climate resilience strategies was showcased. Case studies from Uttarakhand and Nepal were brought in. Several multi-hazard frameworks, early warning models with special emphasis on early warning systems in Kerala, AI-enabled decision models, multi-level warning and disseminations were also showcased. Initiatives centered towards women empowerment and sustained livelihood, like formation of SHGs like Amrita, which transformed the lives of 3 lakh women were presented. COVID-19 and near-Earth objects impact and their related publications were mentioned. Monitoring of asteroids and making studies accordingly, for instance, early warnings, advanced planning, risk communication, governance, and outreach and education were also presented. The symposium has also put in dedicated effort to bring in panel discussion in both the days to discuss, ideate, and brainstorm on the topics. People-centered warning systems and government, industries, non-profits in multi-hazard early warnings. What is next? The panel discussion on day 1 focused on people-centered warning systems. The discussion deliberated on ways to leverage emerging technology to create a warning system for the people at risk who need them. Localizing interventions by embedding them into local communities and incorporating the wealth of local wisdom from indigenous communities were emphasized. Beyond warning, it was also highlighted in the discussion the importance of involving the communities in the process and to empower them. People typically take warnings as passive recipients, but they have the potential to participate far more actively in the process. The case studies of how people observe their own rain gauges with levels of warning for each site in the small catchment was discussed. The panel agreed on the necessity that for the systems to be efficient, it comes down to the fact that communities should believe in the warning. Along with this, the importance of technical systems to cater to specific people-centric requirements were highlighted. The importance of a bottom-up approach for communities to imbibe technology and have an efficient warning system operating in the end was emphasized. It was also agreed that it is important to prioritize simple and cost-efficient handheld devices that local employees can use and understand, which still give valuable information to implement a warning and evacuation process. The panel discussion on day 2 deliberated on how best we can utilize early warning in the coming 5 years and how to come up with a better early warning system so that the community can benefit and evolve. It also emphasized the importance of urban dynamics and how electronic sensors are just extension of our eyes. It is important to connect the last mile and to communicate with people to empower them. The early warning systems also need biological indicators which come from the indigenous people. The importance of enhancing the calculation of risk needs was brought out to reflect low-value assets from the community. Especially inclusive measures to integrate women and children and vernacular language were also highlighted. The need for multi-hazard early warning systems and sharing of transboundary data between India and other countries were brought out. The importance of two-way communication capability with the satellite, SMS communication, and the importance of reaching the last mile was also spoken out. The importance of involving the private sector and the tourism sector to conduct responsible research was emphasized upon. The panel discussions highlighted the importance of creating a network of practice where sensor and IoT-based information from technology solutions can work together with a community of people, and how Amrita can take an initiative by integrating state and national disaster management authorities as the backbone of knowledge for India and Southeast Asia. MWCR 2022 thus provided a platform for interaction and knowledge sharing between state disaster management authorities, national disaster management authorities, UN, industry, and academia to ideate and brainstorm about enhancing the access and availability of multi-hazard early warning system for all. We hope that the symposium will pave the way for the formation of a coalition of experts from global north and south that include governmental, non-governmental, private sectors, and community members that can work together in building community capacity and resilience. With this, we are working towards the curation of risk awareness materials for multi-hazards and forming a compendium of educational resources in traditional and new media formats. We are planning to organize a large conference early next year in disaster risk reduction to shape the conversation regarding the changing paradigm with respect to MHWS, for which we sincerely request your support and participation. Based on the participation in this one, on the different panels and on the different groups, we are forming working groups with specific thematic areas, and these working groups will work towards in developing the larger conference which we are planning next year, and also coming up with a compendium of of materials which can be used as publications for the future generation. And all the panel members' cooperation for this I seek, and we will be taking forward this initiative. The symposium has broadened our horizons and opened the doors to new avenues in the areas of multi-hazard early warning systems that can be effectively utilized for disaster risk reduction to build community resilience. This, coupled with the adoption of cutting-edge resources and technology, will make our journey towards a sustainable tomorrow a much fast-paced one. Thank you to one and all for joining the symposium. We hope that this will be an impetus for making community resilience a reality by touching the diverse and multifaceted sections of society. Let's make sure that the inspiration that we garnered from the symposium will be one for future generations to cherish. Thank you all.
Thank you, Mari, for a detailed summary of the proceedings. This symposium is such an important endeavor to undertake, and it was held at such a timely moment. It is crucial now more than ever to discuss and to come up with the solutions for multi-hazards and community resilience. And it is indeed an honor to be part of it. And we are looking forward for the conference next year. And now it's my honor to introduce the chief guest of the evening, Dr. Amrita Mohapatra. Dr. Mohapatra is the Director General of Meteorology at the India Meteorological Department and permanent representative of India with World Meteorological Organization and member of the Executive Council. May I request you to deliver the address, sir?
Namaskar, good evening. Dear Professor Vinod Kumar Sharma Sahab, Vice Chairman, Sikkim State Disaster Management Authority and Director IIPA, Professor Dr. Manisha, Provost and UNESCO Chair on Experiential Learning for Sustainable Innovation and Development, Amrita Vidyapeetham, India, Dr. Sudha, Professor, Amrita School for Sustainable Development, Amrita Vidyapeetham, India, Professor Dhanya, Amrita Center for Wireless Networks and Applications, distinguished guests, delegates, ladies and gentlemen, as well as the dear students participating in this conference. At the outset, I congratulate Professor Manisha and the entire team of Amrita Vidyapeetham for considering this contemporary topic as the theme of this conference, that is multi-hazard warning and community resilience. I also feel honored being invited to participate with this program, even though I would have been happy to be a part of the entire conference, as the subject matter of this conference is very close to my heart and very close to each and every person living in this society. As all of us know that the society is experiencing day by day more and more frequent and intense natural hazards. And 80% of the natural hazards are associated with weather and climate. And especially when we consider the tropical countries like India or South Asia, the impact of this severe weather leading to the disasters is felt more. At the same time, most of the countries in the tropical region are either developing countries or the underdeveloped countries or the least developed countries, or you can find many island nations. So therefore, the threat due to this type of weather and climate related hazards become more serious and the region become the more vulnerable At the same time, there are situations when the hazard is multiplied due to the presence of various types of hazardous situations simultaneously. Say, for example, the tropical cyclones, which is a very good example of multi-hazard. When you get the wind, you get the storm surge, also you get the rainfall. Similarly, there could be the multi-hazards in association with the floods. There could be floods, there could be landslides, mudslides, things, etc. But apart from that, there could be many primary hazards and secondary hazards and tertiary hazards occurring simultaneously. There could be situations sometimes in a particular country or the region, while in the one end you have got the floods, in the other end maybe cyclones, in the third end you may have the heat waves. So therefore, the spatial distribution of these multi-hazard scenarios is another issue which is also threatening to the entire community. But however, over the years, the community has tried to build the resilience. And of course, there is some difference among the countries, but there are certain countries who are moving ahead, and some countries are just coming in the initial stage. But it needs to be improved further, considering the fact that the climate change is a reality, and climate change has the maximum impact in terms of the extreme weather. Now, considering this tropical region, for example, you will find that the frequency of heavy rainfall events have increased, while the frequency of light rainfall, moderate rainfall has decreased. Similarly, though the frequency of cyclones has not increased, but the intensification of the cyclones has increased, and at certain ocean basins like Arabian Sea, the most intense cyclones like extreme severe cyclone storms have increased. So therefore, it is not simply that in terms of global warming, the temperature has increased and led to the occurrence of more frequent, more durable, and more intense heat waves, but also it has led to the disastrous weathers like the frequency and intensity of the thunderstorms and associated weather like squalls and hailstorms and heavy rainfall, and also the cyclones and the monsoonal low pressure systems impact in terms of the heavy rainfall. So at the same time, it has improved in certain parts that it can be attributed to climate change, but in certain issues also cannot be attributed to climate change. So therefore, the need for the day is that to understand better the impact of the climate change vis-a-vis the various types of weather and climate related disasters, especially the multi-hazard scenarios, and bring out the facts for the management of various types of hazards. So if we consider the impact of the climate change, you will find that there are three aspects. One is the science of the climate change. Other two are the adaptations and mitigations. But the process of adaptation and mitigations follows from the science of the climate change. Therefore, science should be fully understood. Science should be downscaled in such a way that each and every person, those are affected by the climate change, they also understand it and they apply in their day-to-day life to minimize the impact. And also science should be available in such a manner to the disaster managers, the policymakers, that they can also formulate the adaptation and mitigation measures accordingly. So therefore, while considering the role of various agencies in this regard, I'll just tell that the role of academics and R&D institutes is also a very important aspect, that they should continue the research and bring out the facts and figures instead of simply propagating the half-truths or the false information generated by some people or the others. Though there are nodal agencies like Minister of Arts and Sciences to develop the statement, and there is Minister of Environment, Forest and Climate Change, but the issue of climate change and its impact on multi-hazard is such that it needs the more and more involvement of the various institutions, policymakers, policy bodies, and institutions, academics, for better understanding, better research, and better applications and adaptations and mitigations. So in that direction, there is many policy guidelines, and at international level and national level, especially Prime Minister's 10-point action plan, and vis-a-vis the disaster management plan and disaster management act, and various initiatives taken by the government in recent times. So we should take advantage of all these, and we should sharpen our approaches to mitigate this type of disasters. Now, coming to the various aspects of the disaster reductions, we also know that there are various aspects like planning, preparedness, prevention, mitigations, and early warning. But early warning is the first step in case of any kind of disaster risk reductions. Another point is that the investment, if you just look at the amount of investment needed to cope with the adaptation and mitigation approaches, and the amount of investment needed to improve the early warning, if you just consider, we'll find that the investment is quite less in case of early warning. And in terms of economy, if you just think about the return is quite high. The loss due to these disasters are about 5% of the GDP in the countries like India and other many tropical countries. And at the same time, I'll just give an example that is the investment of about 437 crores in India Meteorology Department in 2007 to 9 has led to improvement in weather forecast, which is minimizing losses of lives and properties. Taking an example of the tropical cyclones, it has led to the reduction from 10,000 to 10s and 20s loss of lives. At the same time, the cost towards evacuation, the cost towards payment of ex gratia, and the cost towards the management of various resources like power, water sector, agriculture, etc., has also reduced. It is because of the investment, technological investment. So therefore, there is still scope to apply the science and technology and to improve further the early warning, and hence also to improve the disaster preparedness and prevention approaches, so as to the no loss of life can be assured, and also the property loss also can be minimized. So we have come up with various schemes for that purpose, like say, for example, disaster resilience infrastructures, which is also being considered here in terms of the community resilience. The community resilience can be ensured with the better early warning, with the better early communications, and outreach to the each and every person in the society. At the same time, society also should be capable to deal with all these disasters by the way of having the better infrastructure, the better knowledge, better awareness, and better mechanism to deal with the various adverse impacts of disasters, especially in the presence of the climate change impact on the disasters. So the good thing is that India Meteorological Department, being an early warning agency, has taken off from time to time various initiatives to improve various components of early warning, like the observational systems, the modeling systems, early warning communications. At the same time, countries also come up with the common alert protocol, so as to reach out to the outreach. It is just in beginning stage, but I hope it will come up in a full-fledged manner within 2 or 3 years. And considering all these, that we have to assure the community with the resilience, you need to go for not only the early warning, but also have to go for impact-based forecast and risk-based warning. And that we have started in the country. In many countries in the globe also they have started. It is a new initiative taken by many countries. You can say that India is the far ahead of many countries. And we have a complete dynamic cyclone risk assessment on the real time. And it provides the loss forecast also. How much could be the loss due to the cyclones in terms of money, in terms of the loss of houses, in terms of loss of electrical infrastructure or telephone infrastructures, etc., other infrastructures. So that helps the disaster managers nowadays. Government of India has also become an example by providing the financial support even before the cyclone hits the coast. So that isn't possible because of all this improvement in early warning and its disseminations and its appreciation by each and every person in this area. Because unless people appreciate the unless people have the confidence, the early warning does not work. So that's impossible because of the integral approach in the country with the development of the knowledge base, with the development of the institutional organizations, with the development of policy and planning infrastructure, and also with the development of the physical infrastructure. The socio-economic conditions of the country has also improved. And all these are possible with the integral approach of the entire society. So credit goes to entire society, but still we have to go further, as we know that though loss has reduced, but loss of property is not reduced. It is increasing over the years, and it will increase also because social condition is improving. So we have to minimize this loss of property through this resilience infrastructure, which has been taken up by India also in terms of the Coalition for Disaster Resilience Infrastructure, CDRI. India is doing that. And also by adopting various types of environment-friendly technologies, the green technologies, which can also minimize the greenhouse gases and hence can at least assure that no further adverse impact or no further increasing adverse impact of the natural disasters on the society. At the same time, we have to sharpen our early warning system also by augmenting all the components in terms of operations, communications, early warning and definitions. While I'm talking of the impact-based forecast, it needs a lot of data. It needs not only the meteorological data, but also needs the socio-economic data of the society. It also needs the information about the geospatial database, needs the data on the secondary hazards and tertiary hazards arising out of the weather and climate-related hazards also. So all this data has to be integrated, and that we are doing, but therefore it involves again, just like a mass movement, we need collaboration and cooperation, and I hope this type of conference will certainly help to sharpen our policy planning and approaches and have a realistic impact-based forecast and risk-based planning. As all of us know that World Meteorological Organization has put off a theme this year, that early warning and early action. So that is the motto of WMO for the next 5 years. By 2025, WMO has declared that every household should have the access to early warning. All of you should be very happy that India has access to early warning. About more than 80% of the population get the early warning. But there are many countries in the world where still it is not reaching out, that there is no early warning mechanism. There are many countries also. By that we are helping many countries. Our country is acting as a regional center to provide guidance to many countries in South Asia, Southeast Asia, and Middle East. And certainly we can improve further towards this early warning and early action for management of the multi-hazards. So I want to say that though WM has told this year, but India Meteorology Department adopted this strategy 3 years back when I took over. I told that har har mausam, ghar ghar mausam. That means each household should have the access to weather informations, and each household should have access at any time he desires or she desires the information on the weather. So towards that directions, we are working that, and we are also working with many international agencies in the WMO community. I hope the society is also facing the challenge and converting into opportunity. Also, it is our responsibility. So I once again thank all of you for giving an opportunity to speak on this occasion. And I hope the recommendations, as it has been discussed by Dr. Manisha Madam, will be carried forward by all agencies and also by the various individuals to further improve the R&D, to further improve the applications, and to further improve the strategy towards disaster risk reductions. So thank you very much.
Thank you for your enlightening speech, Dr. Mohapatra. As you convey to us, the climate change will especially affect countries in the tropical regions, and that we have to be prepared to address multiple hazards simultaneously. As you rightly pointed out, there are spatial differences between the countries. Therefore, it's important to shape the conversations around the multi-hazards and find the solutions collectively in order to minimize the impact and increase preparedness for these challenges. Thank you very much once again for it, and it was such an honor having your presence. Thank you very much.
It is the first honor for me to invite Professor Vinod Kumar Sharma, being the senior professor and the consultant of disaster management at the Indian Institute of Public Administration. He's also the vice chairman of Sikkim State Disaster Management Authority, Government of Sikkim. Sir, the stage is for you.
Thank you very much. Dr. Mohapatra ji, Director General, Indian Meteorological Department, a very distinguished scientist and a person of international repute in meteorology, associated with the World Meteorological Organization and all international networks, and who is doing, I should say, wonderful work, in this area, in this country. And we are proud of him. We have with us Professor Manisha ji, who has taken this initiative. She and her team and the center, which is working for landslide mitigation since long time in Himalayan region as well as in Western Ghat, and Professor Sudhaji, Professor Dania Madhuji, all international delegates. I think I couldn't attend the entire conference, but I attended some of the keynote speech. I could attend, some of the sessions, inaugural session, as well as some other sessions. And it was really a remarkable conference. I really appreciate that within no time, within a couple of weeks, Professor Manisha and her team, she could gather, some of the top speakers of disaster management, more than 30 speakers, and 12 keynote addresses from, I think, about 14 countries, she mentioned in the summary report. But the most important thing is that it was attended by many researchers and students as well. There were more than 100 participants who were attending this conference. Dr. Mohapatra, as you very rightly said in your valedictory session, that we really want to make resilient India, disaster resilient. And in case you see our, national disaster management plan, the first page, you will see that the vision is very clear, that we want disaster resilient India. And this is possible when, all the stakeholders take their responsibilities. Now government, some data is given by Mahapatra ji, and I know because I am closely working in this area, that how much progress, these agencies have done. You take the example of Indian Meteorological Department, I think they have done remarkable job in last 10 years. And today the network of radars, the network of Doppler radars, the buoys and all these things. So we are not less than any other country in collecting, informations. Then the interpretations, then the dissemination. I think in each and every aspect we achieve a lot. And but there are so many things which we should achieve, in coming years, because the frequency of disasters increasing, frequency of climate-related hazards increasing because of climate change. And for this, these agencies, they are working, I should say ahead of time, but still they need, much bigger canvas. And I always say that the bigger support can come from the academic institution. Dr. Mahapatra has also mentioned very clearly in his address that we have very good, institutions in the country. And these institutions should play a key role, in future, in coming years. And for example, I know that since last 10 years, Amrita University, they are working in Himalayan region, they are working in, Western Ghats, and they are assisting different states. I know that in Sikkim, they are helping us. They are, yesterday, our people were here and they were giving some of their observations. Similarly, I think they are working with several states, and this really we need. There is a need in this country that academic institutions should work with the states. They should educate them. They should do their research data, share information with them, and they assist, government and government agencies in doing research and in dissemination of this knowledge. I think I know that all the IITs, they are doing wonderful job. They are having seismological, departments. They are working in area of atmospheric science. They are working. So I think all this research should be utilized by the government agencies. And this network is required. In case we work in silo, we are doing good work. There is no doubt in it. University will getting PhD degree. There is no problem in it. But the benefit, the nation will not get the benefit. So I think in case we want to multiply the, impact of this research, then I think we should work together. And work together means the government agencies which are already working. In India, we have Indian Meteorological Department, we have Central Water Commission, we have, Groundwater Commission, we have so many agencies, ISRO, etc. And in case these agencies get support from academic institutions, then definitely it will be a big assistance. I know that IMD is having wonderful scientists, Ministry of Earth Science, they have their own network, but still they want to do more and more. In case you visit IMD, recently I was there in IMD and I visited it, about after 1 or 2 years, and there was a great change. I was surprised, and I was really feeling proud on this organization that how much work, they are really doing. Now, in case academic institutions who are working in this area, in case they join hand with Indian Meteorological Department, in case they take up some projects, which will definitely, be a research scholar, in case they are working, definitely they need degree or something. But at the same time, I think as in the industry, we have corporate social responsibility. Similarly, the academic institution also having social responsibility. And this social responsibility is to assist, these organizations which are working in this area. Friends and international participants, particularly I would like to mention here that approach. Now the approach to science and technology is completely changed in this country. And you will be surprised to note that we are spending money on, suppose there is, much risky project where the results are not known. Still we are, spending money on research, and this approach was not there. Earlier, we were spending money only on research, which will give positive result. We are sure that we will be. Now, the quantum research and all that, if you see the DST approach, if you see our national science, technology and innovation policy, we are spending on different type of research, and more money is available to academic institutions. I think we should take use of this, benefit of this, and Ministry of Earth Sciences, Department of Science and Technology, all these, they are much more open today for academic institutions. So I think this is very much required. Honorable Prime Minister in his 10-point program, he is mentioning inclusiveness, he is talking about gender issue, He's also talking about public-private partnership. He's also talking about academic institutions. So I think it is very clear, from 10 points program, it is very clear, from Sindai framework, that unless and until academic institutions are not part and parcel of this, we cannot do risk reduction. I am grateful to Amrita University and respected Amma, that she has initiated this thing. Earlier, they were working in relief only, but now they are spending on research. Now they are having a full-fledged center. Now there is large number of researchers, working on different topics. It is not only national, but international approach. I think I compliment, this institution. At the same time, I encourage and I really appreciate in case other institutions will also participate in the same way. Other universities, some can work on hydrometeorological department, some can work on some other, because we have different specialization. Each and every university or academic institution cannot work on same subject. But I think in case we work, on our specialized area, we can achieve a lot. I'm very happy that these 2 days conference was very useful. It was a very good initiative. I'm happy that Manisha ji has announced that they are going to have another, second conference soon. So next year maybe. So I look forward, and I will certainly, wherever I am, I would like to contribute in that. And I think in the next one will be more planned, and different thematic areas will be covered. And in 2 days, you have covered so much of area that I really appreciate. And you brought some people who are not only international eminence, they are authority in their own areas. So thank you very much, for including me in the advisory board, and your invitation for this conference. For me, it was very useful, I can say this much. And the valedictory session of Mahapatra ji, I think he has covered each and every point. He has covered the use of science and technology. He has used what we are doing in this country. He told us that how international cooperation is in our agenda. You can see yesterday there was a cyclone, Sitrang, in Bangladesh, and all advisories were going from India. So India is assisting, other countries, neighboring countries, whoever is asking for help, this kind of scientific assistance, this is being provided by Government of India. And our Honorable Prime Minister is very much there for international cooperation. This is his priority. And in 10-point program also, he emphasized that particularly in disaster risk reduction, international cooperation is required. So I am grateful for the international participation, though they are not in that number, but each one is authority in their areas. Each one contributed a lot. I am grateful to each one of them. So thank you very much. Thank you, Manisha ji. Thank you, Sudha ji, for this wonderful opportunity which you provided to me. And I will always be available, for such causes. You can depend on me. And whatever little I know, I will certainly like to share with others. Thank you very much. Pranam.
Thank you ever so much, Professor Sharma, for your words of wisdom and for emphasizing the necessity of performing research in this area. Now we have Dr. Sudha Arlikati to deliver the vote of thanks. Dr. Arlikati is a professor of sustainable at Amrita Vishwa Vidyapeetham. She has over 19 years of teaching and research experience in the United States of America, India, and the UAE. She has degrees in architecture, urban and regional science, and planning with an emphasis on environmental planning and hazard management. Dr. Suta, I kindly request you to deliver the vote of thanks, please.
Amritesh, thank you. Just let me know if you can hear me clearly. I'm having a lot of network issues.
Yes, yes. I can hear
Hello?
you. Yeah.
All right.
Yes, ma'am, you're audible. Yes.
Thank you. Om Amriteshwari Namaha. Good morning, good afternoon, and good evening, everyone, all the distinguished speakers, attendees, and the students from India and around the world. I feel extremely privileged and humbled to deliver this vote of thanks at the close of the Multi-Hazard Early Warning and Community Resilience Symposium, jointly organized by Amrita Vishwa Vidyapeetham's UNESCO Chair on Experiential Learning for Sustainable Innovation and Development, Amrita School for Sustainable Development, and the Amrita Center for Wireless Network and Applications. I would like to start by thanking Dr. Dhanya, Assistant Professor Amrita WNA, for delivering the welcome address for the valedictory event. Next, I would like to take the opportunity to thank Dr. Manisha Ramesh, UNESCO Chair for Experiential Learning for Sustainable Innovation and Development, and our Provost, for delivering an excellent summary of what transpired in the last 2 days. Additionally, we are indeed extremely thankful to Dr. Mrityunjay Mahapatra, Director General of Meteorology, Indian Meteorological Department, Government of India, for gracing this occasion as the chief guest. Thank you, sir, for emphasizing how important it is that academic institutions continue to conduct good research to ensure that half-truths do not get propagated. More institutions need to work together and take guidance from our Prime Minister's policies and plans. And Amrita is going to be at the forefront in trying to do just that. We should not only do early warnings, but rather focus on impact-based forecast and loss-based forecast, as you advised. And the faculty and students will work together with other organizations and trying to just do that, so that we not only help the government, but also individuals to work on mitigation and building resilient infrastructure for our future. We thank India safe, but our neighboring countries as well. Furthermore, I'd like to thank Professor Vinod Sharma, State Disaster Management Authority, for your compassionate and supportive words of felicitation. You have been the backbone of the advisory panel, along with Professor Vinod Menon. Without both of you, we couldn't have done so much as we did. Despite being held online with participants joining us from different time zones, including Europe, USA, Canada, Australia, Singapore, and the African nations, each one of you participated in the sessions with passion and enthusiasm. Oftentimes, actually, we had to cut you short because of time restrictions, and we hope we can carry forward this conversation at another point as we start creating joint groups to work some more. We will leave today with a renewed sense of purpose that we will break down our individual disciplinary or agency silos and work collaboratively in improving early warning systems and build capacity worldwide. This whole symposium could not have been possible without the backing of our Amrita University faculty and staff. Hence, my heartfelt appreciation to all the senior members of Amrita University, Swami Amrita Swarupanandapuri, President, Dr. Venkat Rangan, Vice Chancellor, Professor Manisha Ramesh, Provost, and for experiential learning and sustainable innovation and development. I would also like to extend my heartfelt gratitude to the advisory committee, consisting of Sri Gopinath Acham Kulangara, Inspector Joint Inspection Unit, UN System, Dr. Ian Davis, Visiting Professor, Kyoto Lund, Oxford Brookes Universities, and Honorary Visiting Professor, RMIT, and Amrita, Professor Venkat Rangan, Dr. Vinod Sharma, and Dr. Ramesh, KG Ramesh, Director General, Retired Indian Meteorological Department, and then Anup Karan, Senior Disaster Risk Management Specialist, practice at the World Bank Group. Professor Vinod Chandramenon, founder member in DMA, Government of India, and adjunct professor at Amrita Vishwa Vidyapeetham. Without all these excellent advisors, this symposium could not have been possible at such a short time. Special congratulations and thanks to the faculty and students at Amrita, the School of Sustainable Development, for helping with this arrangement, and also the Amrita Center for Wireless Networks and Applications. Thank you all. Also the ICTS team for helping put all this together in the online mode. And last but not the least, my humble pranams to our Chancellor, the world-renowned humanitarian leader, Srimata Amritanandamai Devi, for continuous guidance, support, and inspiration to lead such initiatives. Thank you once again, and I hope if you all can stay back, please. We would be having 6 of our students present their posters. They have worked very hard, but because of some time constraints, their program had to be shifted back. But if you can provide some valuable support for their presentations, we would appreciate it, because it will start almost immediately. But thank you very much. A big round of applause for everyone over here. Thanks so much.
Thank you, ma'am, for delivering the vote of thanks and adding a heartfelt note to this session. We at Amrita Vishwa Vidyapeetham thank all the speakers, participants, attendees from the bottom of our hearts for helping us make MWCR 2022 a grand success.
We do now have a session called Research by Young Amrita Scholars, where we have a few bright young minds showcasing the research they have done through poster presentations. I would like now to hand over to the program coordinators for this session. Thank you very much.
I would like to give my thanks to Sir for joining, Professor Mohapatra Sir and Vinod Sir, also to join this program, and all the participants joined. Thank you so much for joining, and we hope to work together for the larger conference coming next year. And we are forming working groups, sir, on specific thematic areas. We will need all of your advice to take forward this initiative, sir. In your busy schedule, you agreed. Thank you so much. Thank you very much, sir.
Welcome back, everyone. We will now have the section titled Research by Young Scholars. It will be chaired again by Dr. Al-Qasim. Dr. Al-Qasim is an assistant professor, Center for Wireless Networks and Applications, Amrita WNA. And Amrita, she doubles also as the associate professor, School of Biotechnology at Amrita Puri. We are honored to have you, Dr. Al-Qasim. Over to you.
Thank you very much, Anthony, for the brief description. And a very warm welcome to all our students and the attendees, and yeah, regards and thanks for all the people who are organizing this event. The first presentation in this sequence we have from our PhD student from Sustainable Development, Ms. Shelina Mariana Shah. Has, before joining Amrita, she has already worked for 20 years in as a teacher, and she has a long experience working on autism, and she is kind of a specialist in this field. She has also worked for National Center of Computing Education in UK as a training teacher. Without further ado, Phil, we welcome you, and can you please share your screen and discuss your poster?
Thank you very much. Can you hear me all right?
Yeah, loud and clear.
Okay. Okay, please let me know if the signal goes, then I'll turn off the video. So I'll just begin now. So over the past 2 decades, sorry.
We lost you, Phil?
Yeah, she's been having a lot of network issues.
Yeah.
do we want to go with the next student?
Okay, so yeah, maybe we should go for the second one. So I would like to welcome Bal Mukund. He's another PhD student with us in the Institute of Sustainable Development in Amrita University. He has been working on different landslide related early warning system and different multi-hazard issues as well. So warm welcome, Bal Mukund. Dice is over to you. Please share your poster.
Thank you. Namaste all.
The volume is very less, Bal Mukund.
Namaste all. Am I audible?
Yeah.
Okay. So I hope my screen is visible.
Yes, it is.
So thank you for this opportunity to present the work. So this work is actually in collaboration with British Geological Survey, and I am a small part of that. So the title of my presentation is Modeling Subsurface Dynamics with Point Sensors and Geophysical Imagining Technique for Landslide Early Warning. As we know, in Western Ghats, it's significant landslide prone areas, and there are a large number of landslide related casualties which we can see every year. So it is crucial to develop systems capable of capturing real time and spatially variable changes in slope stability to assess the increasing vulnerability levels. And in this work, our university, Amrita Vidyapeetham, has a site in Western Ghats, which is Munnar. We can see the picture in figure number 1. So here, the world's first IoT-based WSN system for landslide monitoring and early warning was established in 2009, where the monitoring of key parameters such as slope movement, rainfall, moisture, pore water pressure, and vibrations are there. And in collaboration with British Geological Survey, a prime system was installed in 2017, which is basically electrical resistivity tomography system, which is designed to provide a monitoring tool for low cost and low power. So in this presentation, the preliminary results from the combined interpretation of geophysical data collected from the IoT system and the prime system in Munnar for the monsoon season of 2019 is presented. This figure shows the study. This figure shows the study area site, and here we can see there is a scarp of a 1926 landslide, which was a major landslide in that area. And another landslide happened in 2005. So here we can see the smaller scarp in which 9 people had died. The red marks here shows the houses that got damaged. And then in 2018, further more landslides happened in this area, which is marked in this red color. And in the figure number B, the ERT monitoring lines, which are basically the four lines here, are the places where we have deployed 128 electrodes, and we are receiving the ERT data from there. So geologically, this area belongs to Precambrian gneisses and the foliations in this area, which are northerly dipping. And the area is moderately dissected, structurally controlled drainage network, and it receives a large amount of rainfall, about 1650 mm of rainfall annually. The soil thickness varies from 2 to 10 meter, and which lies in situ weathered rock or saprolite. About 150 IoT sensors have been deployed, and the ERT electrodes which are placed there are having 2 meter spacing along the line and 4 meter spacing across the line. The total length of the system is about 128 meter and width is about 12 meters. So the measurement that happens is basically twice a day from the ERT system, and we use dipole protocol for comprising the reciprocal measurement. This figure, figure number 2, shows the workflow of the prime system. So we have the sensors array, and from the census array, the prime instrument collects the data, and it is basically sent through Ethernet connection to the router, and from router via wireless internet, it is sent to the control center. So here the motion sensing is taken up, and through automatic processing, the image is generated. The ERT images, the resistivity images are generated over time, which is translated through the calibration of equations into the moisture content images, and it can be visualized in the different GUI dashboard. Figure number 3 shows the resistivity model of the February 2019, which is basically baseline time. And we can see in this figure, there is a strong resistivity contrast, which basically shows the change in geology and the weathering intensity at different parts of the slope. Here, the blue color shows the low resistivity, and the yellow color shows the high resistivity area. The superficial layers has irregular extension at depth. We can observe the variable thickness of soil in this area through this ERT imagining. So this clearly demonstrates the use of this method to identify the changes in the variability in the slope in terms of geology and in terms of soil. So basically, this figure, in figure number 4, we can see there is a comparison between the initiation of the monsoon. So here we can see that initially in this figure, there are places with
I'm sorry, Barnukul, can you please like conclude in 2 minutes?
Yeah, sure, ma'am. This is getting over. So with each month, the different parts of the slopes are getting moist, and there is a variation that we can observe, and it very well correlates with other sensors data like pore pressure data and rainfall data, which is also increasing in this site. So ERT, the resistivity is very well correlating with the pore pressure in this area. In concluding remarks, we have the preliminary result shows that the moisture changes during the 2019 monsoon significantly decreases in resistivity, coupled with increase in pore pressure at different depths. And our interpretation of this time-lapse ERT points to soil layer very clearly says that the moisture content in these deeper areas are basically increasing. So this method can be actually utilized for catchment area monitoring. It can effectively give us the monitoring of larger area at a relatively lower cost. And in this work further, we are focusing on analyzing bedrock geology and overlaying soil information to further extend into the catchment area. So yeah, with this I'll conclude. Thank you.
Thank you, Barnukul, for the interesting presentation. Right now, I don't see any question, and I'll get back to you because we have overstretched this time. So I'll get back to you at the end. Maybe for now we can move to the next presentation, which
I just heard that Cell is able to present. She has gone to another. Yeah, thank you.
Yes.
So welcome, sir. Are you there?
Sit.
And she's presenting from Dr. Shabrina's computer. Yeah.
Let's see. Hello again. Right. So I'll begin.
Welcome back.
Can you see the screen all right?
Right now, not.
Okay. Bear with me. How do I share the screen? Share screen. Okay, I'll give you a bit of background while we're waiting for that. So my name is Sel Shah. So I'm studying towards a PhD in sustainable development at Amrita, Vishwa, Vidyapeetham. And I'm specializing in inclusion and autism, in particular screening and diagnosis of autistic children in rural India. So over the past 2 decades, human-centered and inclusive disaster management practice has been consistently raised as a matter of priority. This theme has run through many of the presentations in the past 2 days. In particular, I very much enjoyed the session on people-centered warning systems yesterday, chaired by Mr. Ian Davis. The ideas that I'm going to put forward in this brief presentation aren't new, but put a different lens on disaster warning systems. I've taken the liberty of looking at a wider context of disaster management and disability, with a focus on a specific minority population, autistic children and adults and their families and carers. So, poster still isn't there, but I will carry on. So to give some historical context, I'm going to talk about a couple of disasters. So the World Trade Center disaster in September 2001, although it was a man-made disaster, the impact was similar to a natural disaster. After the event, we had stories of guide dogs guiding their owners to safety, accounts of people staying behind to wait with their disabled colleagues and friends, and they waited in vain to be rescued. In hindsight, lots of difficult questions were asked about wheelchair users and loss of life. Then the Indian Ocean tsunami in December 2004 in Sri Lanka, in a school for disabled and mentally ill, had an article written about it where it was described that disabled children were lying in their beds as water engulfed them. As Dr. Ian Davis said in his introductory talk yesterday, form follows failure. We need to learn the lessons from these events. Can you see the poster now, everyone?
Yes, now we can.
Great, that's great. Okay, thank you. So we can't underestimate the impact of the media. The stories were told from these events awakened people's awareness and compassion and laid the foundation stones for change. Treaties, guiding principles, and global frameworks for inclusive disaster management came about as a consequence of these disasters. So vulnerable groups can be determined by gender, age, so that can be the very young, it can be the elderly, immigrants, refugees, economically or socially disadvantaged people, language, physical, perceptual, mental, and cognitive impairments. So why are they vulnerable? It's about their ability to receive and effectively act on warning information. Not only is there risk to life, but there are the longer-term impacts, physical and psychological. So for autistic people in disaster, an autistic child or an adult is commonly described as having limited communication skills and difficulty in forming relationships. They could have different sensitivities to stimuli and exhibit fixated behavior or repetitive movement in speech. That's great for the screen, thank you. Every autistic person is different. Key points to consider in a disaster scenario. An autistic person might have language challenges. They may be nonverbal or non-literate. They may have lack of awareness of what's going on around them, issues with social interactions, anxiety about being touched, sensory issues, loud noises, light, smell, taste, etc. might really cause them a lot of problems. Meltdowns, emotional meltdowns, and violent behavior can be triggered by change. Any change can be a major issue, something as simple as the wrong cereal for breakfast, or with even greater impact, the introduction of a new person in their lives. The unexpected, overstimulation, stress, or frustration are all things that can trigger difficult sort of meltdowns. For the large part, this behavior is not misbehavior. It's an autistic person's inability to cope with a situation or environment. That's great for the screen, thank you. As a meltdown progresses, the autistic person's ability to communicate and their awareness decreases dramatically. Family and carers play a key role supporting them, as well as organizational and logistic burden in a disaster scenario. They hold an emotional responsibility. Additionally, an autistic person can be highly sensitive to their carer's emotions and will take the lead from them. So that person, their carer, needs to stay really calm. So here on the screen, there's an inclusive model for disaster management. It is for autistic people, their families and carers, but a lot of it can be applied to a more general group of vulnerable people. So what we put here is it's based on the 3 papers which are listed below and referenced here. So at the top, for pre-disaster care and planning, we have inclusive planning, which means that you would involve all the stakeholders at the very first stage, right from day one. We need to have accurate information with mapping, who, what, and where can they get support from, before, during, and after. We need training for families, for the carers, and actually the autistic individuals, so that they can understand and prepare them in advance. We need to use things like practice drills to get them used to the idea of what can happen. And we need to design risk assessments that are specific for individuals. In terms of response, we need to develop a response database so that the people who are responding, they know who the autistic people are and about their carers, what their needs are, and where they are as well. Training is absolutely essential for first responders, volunteers, aid workers, and medical personnel. And communication needs to be through multiple channels, which has already been discussed in the past couple of days, but it needs to be in different formats as well. Many autistic people are visual, and so they'll need visual cues and instructions under pressure. So in the interest of time and the other presentations, I won't go through the relief and recovery stages, but you can see the requirements that would be needed in terms of making adaptations and additional training that would be needed. So really, to conclude, raising awareness, either preparedness or autumn awareness of all stakeholders is really crucial. This is a population that are increasingly also able to self-advocate when given the opportunity. So involving autistic people at the earliest stage in planning is a key to success and saving lives. Thank you very much.
Thank you very much, Sel. It was a very interesting and intriguing presentation. And I was really wondering how to do this kind of research in real world. Like, how do we really reach out to these people and make them prepared? And, they are like case by case, we may have to handle, we have to identify first. How are you planning to take this research?
So at the moment, I'm working on screening children in rural areas in India, because diagnosis is very tricky when there are no services in rural areas. So the project that I'm working on is about screening leading to diagnosis of children. And so that's where the information gathering would start to happen. So that's the area that I'm working in. In terms of research that's already going on, there has been research done sort of, if you like, post-disaster, and a lot of, particularly in the United States, there are autism charities which are actually posting information and providing training for families and carers and children on sort of disaster awareness and giving them sort of toolkits to work with. So that effort is happening in some countries, but we need more of it, really. And the other thing is there's an excellent book which is in the reference at the bottom of the presentation, which was Accommodating Special Needs Population in Disaster Management, and it's case studies, and they actually give training materials as well, so that they can be implemented and tried. There's another piece of research where they actually look at self-efficacy of carers and the autistic children themselves, and they train them and they do like simulation of a disaster, but they do it repeatedly so that the child gets used to the situation and is able to, if you like, participate without becoming too anxious and too stressed. I hope that answers your question. There's still loads more work that needs to be done. Yeah.
Sure. I mean, especially in India, mental illness is not that easily identifiable because it's considered as taboo and it is hidden somewhere. People don't want to talk about it. So to really identify people who need help is the first challenge, I think. So it's a very interesting work and a lot of challenges.
Yeah, we're working with teachers initially. So we'll try and get teachers involved in the screening process.
Okay, that's a good idea. Mm-hmm.
Thank
Wonderful.
you.
Very good luck to you. And thank you so much for joining.
Thank you.
So next presentation in this line is from Mr. Masood Baratika Kolaki. Mr. Masood is one of our PhD student in sustainable development in Amrita University. He has interest in agriculture and precision farming. He has done his master in biosystem engineering from Shiraz University, Iran. Welcome, Mr. Masood. The desk is over to you. Please present your poster. Masood? We can see your, you need to unmute. We can see your poster, but yeah.
Yes, it's unmute now.
Perfect.
Okay, thank you. Okay, can you see my screen now?
Yes.
Okay, thank you very much. Let's
Can you
start
zoom?
my
Can you please
presentation.
zoom? Can you please, Masood, sorry, can you please scroll up? We can't see the title.
Yes.
Yeah.
Yes, this is the title of my presentation. First, thank you for the introduction. It's good now. It's okay now.
Yeah, it was good. It was good before actually. You may zoom out a little because it's partly not visible.
Okay.
Yeah, this is better.
Yes, thank you. Yes, it's the title of my presentation, which considers multi-hazard scenarios for analysis of compound cloud characteristics. In this presentation, I trying to use the concept of compound drivers in extreme events, which are differently weak to express and show the risks of the event. For example, in this presentation, fallout is the extreme event that we consider for analysis the return period, but the return period here will be shown as very period that is very phenomenal. In this paper, what we did is that we provide some rainfall data from satellite-based from Persian NCD, and then we try to consider the rainfall characteristics as a trigger of flood that is very important aspect of monsoon rainfall in Karakal state, state of Karakal in India, which is affected by very erratic and fluctuated rainfall, monsoon rainfall in monsoon seasons. As Professor Chris Quinn stated in his talk, we need to communicate information with community, and we also need to continue community facing with hazards and any vulnerability. We don't need to just analyze the early warning. It's not worked well, but together with the community, we can increase the possibility of competing with this climate change induced extreme events. So that's why for having community and for increasing the social adaptability to
Sorry, Masood, can you scroll down your poster? I mean, maybe you are talking something which is there, which is more interesting to see with
make
figures.
them show that yes, yes. That's why the early warning systems should work very well. And here I'm going to zoom in to show it better. And yes, here's an example of flood in Kerala in 2018 that affected several areas deeply across the Kerala. And you have shown it is shown here the flood map and shows how the impact overview in fatalities and educated people and relief camps, and also the rainfall during the monsoon, how it's distributed during across this region. So to address this issue regarding the Karakal region, Kerala region, Kerala region, as I mentioned, we use the Persian CDR data, a 40-year series of Persian CDR data, and we try to extract two most important characteristics of this data, rainfall data, which are rainfall intensity and rainfall depths, the associated depths corresponding to that intensity. So these two can help us to predict and define the return period of this phenomenon. Although there are some others like water level, statutory water level, or a stream flow peak, for example, that can be considered also. And there are some literatures and ocean level as the driver of flood. In fact, the return period is the most and the key of early warning system for flood that applied for flood management and hydrologic constructions like dams. So what we did, we used here, instead of univariate return period, meaning that using considering those separately, we calculated the joint distribution of these two characteristics that help us to.
Masood, sorry, Masood, yes, can you finish in 1 minute, please?
Yes, I'm going to finish. That's why a couple of functions with a high flexibility and with a good correlation parameter that shows the strength of the two characteristics help us to do this to do so. And finally, by the return period that applied couple of functions. Here we consider we could calculate the joint distribution and joint period of the coupler, which shows here that instead of considering separately, we have a joint return period here that can help us to reach to the accurate return period of the same of the example of return depth or intensity of rainfall. Thank you.
Thank you, Masood. So I understood that you are working on flood forecasting and in multi-hazard term. A little confusion. What do you mean by flood, compound flood?
Yes, and scenarios and or scenarios. To do this analysis, and scenarios considers both of them should be more than a specific or threshold, or scenarios defined as one of those must be more than threshold. And as you can see, there are differences between AMIT scenarios and our scenarios. That AMIT scenarios is better, approved based on literature for flood management in the different regions. Okay, thank you very much for the time and opportunity.
Thank you, Masood. I still didn't get what you meant by compound flood.
What I mean by what?
Compound flood. The title you had, like.
Yes. Flood is a compound phenomenon. It means it include it has lots of drivers, which comes from one physical property. For example, the rainfall has rainfall intensity, rainfall depth, or river has river flow, river level, that they are for rainfall, both depth and or duration and intensity are related to rainfall itself. So they have high correlation, and it can be a compound phenomenon for flood to be to occur. Occurrence of flood, in fact, occurrence of flood affected from compound drivers that
Okay, thank you, Masood. Thank you for the nice presentation. We'll move to the next presenter.
To one other phenomenon.
Yeah, thank you very much. The next presenter is Miss Nilofer Abed. She is a PhD student in Sustainable Development, Amrita University, India. Nilofer has a bachelor's and master's in biosystem mechanics, again from Siaz University, Iran. So she has interest in IoT system, renewable energy, precision agriculture, sustainable ecosystem, etc. So she's going to talk about an overview of multi-hazard warning system and community resilience. Nilofer, are you there?
Yes, I am.
Can you please share your poster and present?
Yes, I shared it. Can you read it? Is it visible for you?
I see you, but yeah, the poster is still, I think, from Masood.
I shared. I have shared, but I'm trying again. Now I think it's visible for you.
Yes, yeah, it's there.
Thank you so much. So good. Now this presentation and this poster is a review, and it is an overview of multi-hazard warning system and community resilience. Really, this poster will show the relationship of some important global initiatives to multi-hazard early warning. Really, we want to know where we are. We want to know, have we overtaken or fallen behind from a schedule? Which schedule? Some schedules established by global initiative. In these posters, I want to share something about three main initiatives. Sendai Framework for Disaster Risk Reduction. Next one is Paris Agreement, and then Sustainable Development Goals. As you know, hazard and every disaster are really catastrophic and has a very, very important impact in ecological, social, and environmental in all levels, from small stakeholders in isolated remote island to big, gigantic institution and international institution. So in this way, we checked and we reviewed three main global initiatives that working or emphasize about climate change and reducing climate change impact. First of all, I want to check about Sendai Framework that established after really marathon negotiated in Sendai in Japan. So this framework emphasizes on reducing the disaster and improving prediction. So it includes some priorities and some targets, and includes really 4 priorities, 7 global targets, 59 recommended action, and 38 indicators. For example, when you are working in based on Sendai framework that India is assigned this framework, you should check again about understanding disaster risk, or you should focus on enhancing disaster prediction for effective response and build back better in recovery. So in one way, and another way, we have some targets. Targets include sustainability reduce and sustainability increase. It means, for example, we are lucky to be and to achieve reduce and reduction global disaster morality. Vice versa, we are pursued to increase number of countries with national and local disaster risk reduction strategies. In the other way, when we are speaking about Paris Agreement that was established around 2015, if you know, the first of this agreement was established in 1979, but for a long time, any country didn't mention to this, and it's renewed and get a new life in 2015. So these specific argument mentioned to keep and reduce world average temperature below 2 centigrade. It means it's not focused on reduction climate change, but it is mentioned about reducing the global temperature. It's completely has a direct relation to first framework and innovation. Second,
Nilofer, you have 1 more minute, please.
Yeah.
Yeah, carry on, please.
Yeah.
You wanted to finish?
No, just I'm saying for you. May I?
Oh, no. No, I said you. I asked you to finish in 1 minute.
Okay. Just I think it's from your side. It's okay. We should go ahead. But now we are working about SDG goals. SDG goals is the main project, is the main major for our students and scholars in sustainable development school. It works in 17 different thematic areas, but specifically the 13th goal proposes strengthening resilience and adaptive capacity in all countries to climate-related hazard and disaster by incorporating climate change measuring into the national policy, strategies, and planning for future and forecasting. So if you check it here, you can see some synchronizing and a really direct relationship with different international documents. If you check SDG and Sendai framework, you can see exactly these targets. We have 7 targets. First of all, for example, we check one of them. One of them is the global disaster morality. We want to reduce it. So it's here, it's A1. It is completely has a relationship to another goals. 3 goals from sustainable development is completely related to the Sendai framework. No poverty. It's the first one.
Okay, Nilofar, I have to interrupt. We are in short of time. I mean, this is a really interesting topic, and so many things you talked about these different frameworks. There are some questions in my mind, but because of the time limit, I would rather rush to the next presenter. Thank you for the interesting presentation.
If you let me, I can just share my result if it is possible.
You need 1 minute to talk. You're saying
1 minute, I think, is enough. All in all, we understanding we are behind of the schedule, and we need improve our gaps. Current gaps is including disaster, losses, lack of awareness, and something like this. So this paper and this poster mention some suggestions like increasing women participation in gathering and training, removing barriers to community like languages, local languages, and use stakeholders participation in and make disaster and vulnerable maps. Also, attention to people with disability makes and improve, recover a lot of gap in this area and in this time. Thank you for attention to me, and sorry for late.
Thank you, and that's an interesting idea you have to take it further. Very good luck to you. So we are looking forward to hear more from you in the coming presentations and in coming years. So moving on to the next presenter, we have Mr. Devashish Brahma. We have Hello.
Hello. Hello, Dr. Alka, are you saying something?
Yeah, I was trying to introduce you, but some internet got disturbed, and I was thrown out. So,
okay. I was wondering there's something on my end. Yeah, I can hear you now. You could also see my screen, right? And hear me and see me well, right?
Yes.
Okay.
Yeah.
That's great.
Your poster is visible. Just let me shortly introduce you. So,
Sure.
Devashish has, BTech in electronic engineering, BTech or MTech?
Dr. Alka, I have a Bachelor's of Technology from the National Institute of Technology, Rourkela, in Electronics and Instrumentation Engineering, followed by a PhD and Postgraduate Diploma in Management from the Indian Institute of Management at Shillong.
Yes, you introduce yourself. Okay. Yeah, go ahead.
Because your voice is breaking, so I'm just filling it up. So thereafter, I have close to 10 years of work experience in marketing, finance, operations, and public policy. And in the last few years, I've been mostly engaged with empowerment of remote communities and the youth. And in this PhD, in the E4 Life PhD under the Amrita School for Sustainable Development, I'm mostly looking at how technology, specifically drone technology, can be of use to remote communities in helping them, empowering them. And hopefully this will clear my path to be a global leader, as all of us vouch to be one day. So hope, Dr. Alka, I've made it simple for you. Thank you so much. And before I begin, I just take a quick second to thank Dr. Manisha, the organizing team, and all the participants here. I'm sure I'm putting your dinner plate away, but we are going to all have it together at our own places, and I'll make sure that I'll make it very light for you. And I finished up quickly within 3 or 4 minutes. Om Amriteshwarya Namaha. This poster is about the work that I'm doing at Uttarkashi and a few remote communities in Odisha, where I'm trying to understand how I should engage ideally with remote communities for the application of drone technology. My observation has been that the poor and the underprivileged sections of the society are the ones who are the most vulnerable to disasters, primarily because of lack of integration and interest with the state-of-the-art disaster management solutions and public policy solutions, which are already there in place. And as a compassion-driven step, first I went on to study from a systems thinking point of view, how to integrate all the stakeholders involved in the disaster management scenario with the context of Uttarkashi in Uttarakhand in mind, in my mind, which is a highly disaster-prone state with multiple hazards, landslides, earthquakes, flash floods, mostly, and even forest fires occasionally. And then how I branched on to focus more on a behavioral study that could transform the most vulnerable person at the bottom of the pyramid. So the poster is going to present some key points related to that. Keeping a tab on the time, let me quickly introduce Uttarkashi to you. Uttarkashi is located in the Uttarakhand state, which is in the northern part of India in the Himalayas, and all the qualities of the Himalayan ranges that we heard from the plenary discussions and the panel discussions are absolutely true. It is a highly vulnerable zone with newly formed mountains, as Mr. V.K. Sharma was detailing, and the local community has its own solutions, and they are not very well connected with the existing state-of-art scientific agencies or international agencies and even government policy officials, including the SDMAs. But if we look at what really is the problem with disaster management, so when I started to understand the solution, started to understand the problem at Uttarakhand, I figured out that it is the people who have to be integrated, because ultimately it consists of remote communities scattered along the mountains. And if they themselves are not willing to come forward and integrate themselves to the existing solutions, no matter how great a solution I might be able to plan and deploy with great collaboration, it will not reach the last mile. So I started to look at what are the events, the patterns and the structures and the models that are behind the disaster management scenario at Uttarkashi. And I figured out that the place has had a history of hazards, but the scene of disasters is new, if all of us are technically aware of the difference in the nuances. Where, just to quote a very prolific delegate in the symposium, that disasters are man-made actually. And the patterns have been that the rising incidence of damages caused by earthquakes, flash floods, and landslides due to unplanned construction activities, dams, and rising incidence of loss of lives and local and tourists. A major part of these patterns were, in fact, I could find them very well present in Dr. Manisha's presentation. And just to give you a reference to link it to that, and that's actually true, all the patterns are evident there. And the structures that are underlying these patterns are mainly because of lack of adequate techno-managerial capacity at the local level for disaster management. And even there is a local lack of access to scientific advisory and early warning systems and forecasting systems. At times, especially during the Char Dham Yatra and special tourist seasons, when the government is proactive in providing access to these solutions for the local communities, the people themselves are reluctant to take it. So this is where I come to the models behind these disasters management. And I've stayed with the community for more than 60 days continuously to really understand what is their thinking behind such disaster management. This primarily, I was there at the Chamoli, district, I was there at the Uttarkashi district, and the Bhatwari disaster hotspot, which is there in Uttarkashi, which is the #1 hotspot among the 19 disaster hotspots in Uttarkashi. And I was trying to understand the pattern of disasters in a rain-prone duration during the Char Dham Yatra. And fortunately, by God's grace, I could do the Char Dham Yatra also and meet with and interact with the tourists. And I could understand from their perception is that they still consider disaster management to be a state job. And for them, it's mostly an emergency relief measure. Mostly people consider themselves helpless and adequate at the forces of nature, and ultimately put it in the hands of God and the forces up there. And also technologically, I found most of them very inadequate. But at the same time, there's a lot of sincerity, there's a lot of goodwill. That is what drove me to further understand if there is something that I could do to transform this section of the people so that the change can really come from the last mile rather than being pushed to the last mile. So as I told you, I had undertaken a system study, which I'm not presenting in the paper here, where I tried to integrate all the stakeholders to look at a synergy that could possibly evolve. And why I didn't further push it, because I understood that a systems study, no matter how grand, how organized, and how how resourceful, will not be able to contribute to transform to the life of the last person at the last mile until and unless he himself comes forward to accept the initiative. So that is where I say that the behavior study is planned to bring about a transformation in this society, in this section of the society. People at the bottom are largely disconnected to these developments. They also manifest disinterest and lack of confidence in highly developed solutions. They are most interested in rather traditional opinions and solutions. There are actually a list of qualitative interviews that I've done to study what are the traditional wisdoms, and a lot of that is actually pretty interesting. Actually, just to give you an anecdote, if that's going to make the movement lighter, I met a very old man at a village in Dunda who's the local priest at a very ancient temple there. They call it the Kachor Devata temple. And he told me that whenever there's a disaster impending and I come to the temple here, I always get signs right here. He showed me the places where he has been getting those signs in the last 30, 40 years. Actually, his father, his forefathers, grandfathers have been temple priests, and all of them have been connected to that. This is not to reciprocate the vibe of Kantara, which is nationally prolific, but to just tell you a fact that I have encountered in the village of Dunda. So that is where I started to look into Fishman and Eisen. Of all the models of Skinner, Bandura, and others, I could understand this is where. Yes, Dr. Alka, half a minute.
Yeah, please.
Half a minute, okay. So I looked into the behavioral and normative beliefs which are existing in the community and the control beliefs. And now the approach is that I'm trying to integrate all these beliefs in the flowchart that I'm showing you to understand what actually drives that behavior. And if there is a possible way that I can fill into the actual control here through a virtual control up in the loop so that I can transform this behavior. So hopefully this will transform the people at the bottom of the pyramid, and we will possibly have a disaster-free remote communities in the Himalayas. Thank you so much, Dr. Alka.
Thank you very much, Debashish.
Professor Banerjee here.
Oh,
Can I make a few points?
Glad to hear you, sir. Namaskar, please.
Om Namah Shivaya. Devashish, you wrote that Uttarkashi is home for over 3 lakh local population and 2,000 listed government offices, etc. are there.
Yes, yes,
are
sir.
these 2,000 agencies active in Uttarkashi itself?
Yes, yes, sir. This is because of the 2013
2,000
North India flood.
agencies in Uttarkashi alone.
Yes, this is according to the NIDM report.
Oh, great. That's the news one. You talked about models. Do you mean mental models?
Yes, yes, sir. Mostly what people think about the situation.
So better you call it mental models.
Yeah, right.
Okay. The system thinking study and all that real study that you said, I couldn't get the point that you're making. Could you define precisely your research problem?
Yes, sir.
And I'm just putting this, don't try to answer me now, lack of time, just note down and I'll share this with you.
Sure, sure, sir. I'll get back to it.
When you took the Hofstede's culture dimension theory as a framework, a line explaining why you choose to follow this model will be useful.
Sure, sure,
okay.
Sure.
And then you have given all these power density index, etc., etc. This looks like to be your preliminary findings. You could provide a heading to that effect.
Sure, sure, sir. Okay.
And in the end, I'm a little bit uncertain about your overall presentation.
Okay.
At what stage your research is and what you are trying to do, etc., etc. Okay. So these are my thoughts. Hope it will be of use to you. And Dr. Alka, I have got some general observations to make to all the research scholars. So when appropriate, you please let me know. Otherwise, I'll share this document with you.
Sir, we have just one more presentation. After that, we can discuss it if you want.
Okay. Please go ahead.
Thank you so much, Professor Banerjee, that you kept my request of guiding me through it. There's actually a process which has gone through the research, and I'll be very happy to answer all your questions. In fact, I've noted down all of them. I'm recording the audio and I'll answer all of questions as you suggested privately instead of taking time of this session. Thank you so much.
Done. You're most welcome. Thank you.
Thank you. Namaskar.
Thank you very much, Debashish, for the engaging presentation.
Thank you,
I mean,
Dr.
you maneuvered very nicely from your own describing about yourself to about the community in large.
I was trying to make it easy for everybody.
Okay, wonderful. Thank you so much.
Thank you, Doctor.
Now moving on to our last presentation of the day. So we have Miss Fernanda Imada de Lima. She's also a PhD scholar in sustainable development in Amrita University. Her research title is in planning of an agroforestry system model as a climate change mitigation and adaptation strategy in parts of Mandakini River Basin. Fernanda, can you please share your screen and with your poster?
Okay.
Welcome.
Is it visible?
Yeah.
Yeah. Okay. So thank you everyone for the opportunity to present my PhD research in this during this event. So I will briefly talk about my PhD research. So the title is Planning of an Agroforest System Model as a Climate Change Mitigation and Adaptation Strategy in parts of the Mandakini River Basin in the district of Rudraprayag in India. So agroforestry is a note practice, but is still very important for the current socio-economic environmental scenarios that we are facing today due to its multiple benefits. And as a complex ecosystem, it can help in a more integrated landscape management, and also can enhance food security and diversify the income of family farm, and also reduce the erosion, soil erosion, and also protect hilly areas from landslides. So it's seeking some of these benefits that my research proposal is to plan an agroforest system model to enhance the climate change resilience to a rural community in Chandrapuri, called Chandrapuri, in Rudraprayag district in Uttarakhand, and also enhance the livelihood of these families. So the methodology of my studies divided in phases. So first, I conduct a preliminary study to understand the state of art of the agroforest system practice in the state and in India. Sorry?
Fernanda, do you want to zoom into your methodology chart?
Yeah, sure. Okay, I will try to zoom in. Okay. I don't know exactly how to do this.
No, you continue with
okay.
We're talking.
Okay, so first, this preliminary study was to get to know the study area. And the second step will be conduct thematic studies so I can gather information, biophysical information of the river basin. And Then I will use also secondary data for weather analysis from the last data, that it will also be important to understand the climate change that is affecting the study area. And to collect the socioeconomic data, I will conduct a participatory rural appraisal in the village. So I will use some techniques such as semi-structured interviews and also problem trees, so I can identify the problems together with the residents, so they can also have active participation in the process. And then with all this information, I will conduct a diagnosis of the area, so I can understand the main challenge and constraints, socio-environmental and also economic. And after this, with these informations, the diagnostic, I will plan the better design for the agroforest system and how they can also get to their products to the market, and what is the best species for the system. So I already had my first visit to Chandrapuri village, and during this visit I could understand some of the problems and issues the villagers, the people living there are facing. So some of them that I want to highlight is the invasion of animals to their crops. So this sometimes it's a problem for them. They lost many of their products. Also, the people there reported to be noticing changing the rainfall patterns, and this is affecting the productivity of the crops. Also, there is a difficulty to access their products to the market, so for that they would need cold storage and also better infrastructure in the road that they could access the market. And there are also many landslides occurring in this main road that is dangerous for the security of the people living there, and also can block the access to the village. And there is also a need to a better irrigation system, because now they just have rain dependent crops. So the environmental challenge there that needs to be overcome is that this stage has a geographic aspect that made it prone to disasters such landslides and floods. So this is even more there is even a better concern now with climate change to these disaster-prone areas, and also women are the people responsible for farming in this village, and for that reason they are even more vulnerable to the climate change. So with my research, I expect to help the villagers, the people in the river basin, Mandakini River Basin, to overcome some of these challenges. Thank you very much.
Thank you, Fernanda, for keeping the time. It's interesting work, and I'm wondering how you are going to add on climate change stuff, which is a longer time window and larger scale phenomena. And right now you are looking into very localized and at a particular time window only. So this will be another aspect you have to add on, and I'm curious what you have planned for that.
I'm planning more now as a strategy, or climate change strategy. I mean, in the terms of to make their crops more resistant to climate change, because now they have not so much diversity in their crops. So I believe with a more diversification of these pits, maybe they can be more resilient to the change of the rainfall patterns. So this will be a benefit that I expect to see in a long-term research, maybe with other students coming to and work, make the project in more long-term. So now I'm planning just conducting the study for the planning of the agroforest system, because it's a very important step of agroforestry. If we don't plan very well, it's not going to be an efficient models to produce income, and also for the long-term benefits such as climate change resilience.
Yeah, so there will be many aspects you have to think of it. We can discuss this offline, Fernanda.
Okay.
I will welcome Dr. Banerjee, sir. So you had some comments for students. Can you please share your comments, your thoughts?
Yeah, thanks. At the outset, I would like to congratulate all the scholars who have come forward to make the presentations, and wish you all the best in your doctoral journey. Personally, going through the posters has opened several new windows of knowledge for me, and I thank you all and the organizers for this opportunity. Now, a poster presentation offers a young researcher an opportunity to present his or her research to a peer audience. So you must look upon this as a great opportunity to receive feedback. You must have clarity and inform your audience what is the stage of your research that you plan to present in the poster. This could be a proposal, a work in progress, or an initial draft report after you have finished your research work. So that clarity, if you make it, it will be good for those who look at your posters. It is preferred that you follow the established structure of a final research paper as seen in one of the presentations. Broadly, as I see it, following a brief introduction, you provide a brief backdrop of the context and relevance of your research, try to frame the research problem, the research question, hypothesis if available, methodology for research, proposed or actual, data collection, means what the sampling you are going to do, analysis, if you have done, results and conclusion. Due to space and time constraints, you need not be elaborate, but try to give an overall sense of your research. It may be a good idea to have a section at the end where you might seek specific feedback. This MWCR event may be considered as a trial opportunity, as you get feedback from 2 individuals. This is what I thought initially, but maybe more. But in real life situation, you may expect the conference participants to have a round of all the posters, and if you are lucky, may expect some questions. This is all the more reason to display clearly a structured presentation to quickly attract the attention of a visitor, either online or in person. So that's all I have to say in general. Thank you very much for the opportunity.
Thank you very much, sir. This is really very important piece of information or advice you have given. I think they have taken it very positively, and this is where they have to improve that within this short period of time, they have to catch the audience and put their whatever they work forward so that they can get interest and most importantly, comments to improve further and maybe get further opportunities in their career. So wonderful. All those presentations were great, and we are very much looking forward to listen more about your work in the coming presentations. And thank you very much, sir, for joining, and all the audience and participants. Great thanks, a deep thanks from my heart to all of you. Thank you so much. Thank you. With this,
thank you, everybody.
Thank you.
Thank you so much, sir. Thank you, Alka.
Thank you.
We at Amrita.
I just wanted to add one small thing to all the participants and the presenters, especially the students. Hats off to all of you. We all had very little time, and despite that, 6 of you came forward. So this is the spirit. I hope for the next conference, we will ensure that we put a larger time frame and we have it bang in the middle so that you have a lot of other people asking you questions as well. So, but appreciate it a lot. And thank you, Professor Banerjee. As always, it's such a great honor to hear all your comments. Thank you, Dr. Alka, for taking this on. Everyone, good night. Take care.
Good night. Thank you so much. Everybody work hard for this.
Bye-bye.
Thank you. Namaskar. Namaskar, sir.
Namaskar. Congratulations. A wonderful seminar. I attended the inaugural function, and that gave me an idea. So, in conclusion, one point that I got, and I think it will be a very good idea, Brahma actually tried to attend that, how to reach the last mile and how to ensure that they get benefited. We all get kind of engaged in our technicalities and details and research and all that, but whatever excellence we may achieve in our wonderful scientific research, unless it impacts positively the person in the last mile, my research doesn't get translated into reality. So that is something I would request all the researchers to bear in mind. And since you are in Amrita, our Chancellor Amma would love it the most if that happens. That I can assure you. And you will get her blessings for your life. This is something that I can assure you.
Thank you very much, sir. So we at Amrita Vishwa Vidyapeetham thank all speakers, participants, and attendees from the bottom of our hearts for helping us make MWCR 2022 a great success. Thank you. And from you, Nilofa.
Hope to see you all soon for our future events as well. And thank you once again. Thank you so much. Dedicated the best wishes to all participants.
Okay.
Thank you, everybody. Namaskar. Thank you for all the cooperation. Hope to work together.
Thank you.